and welcome to today's session on MySQL. Do you know, friends, that MySQL is an open source relational database management system? MySQL creates a database for storing and manipulating data, with each table's relationship defined. Clients can submit requests to MySQL by typing specific SQL statements. And on the other hand, the server application will respond with the requested information, which will be visible to the clients. Now, before we hit our today's agenda, do not forget to hit the subscribe button and click the bell icon. So first, we are going to study about installation guide and brief overview of the SQL Server. Then we are going to learn about creating, using and dropping database in SQL. Then we are going to learn about data types constraints in SQL. Moving ahead, we are going to study about creating table, select, where and or not operator. Then we are going to learn about numerical and character data types. Moving ahead, we are going to discuss about inner left, right and full join in SQL. Then we are going to learn about insert into, update and delete statements in SQL. Moving ahead, we are going to discuss about create and use cases of temporary table. Then we are going to learn about types of functions in SQL. Moving ahead, we are going to discuss about use cases of string function, such as alter and temporary tables. Then we are going to learn about min, count, sum and average functions. Then we are going to learn about case statements if function in SQL. Moving ahead, we are going to discuss about user-defined functions. Then we are going to learn about complete hands-on and important interview questions.
Now, the RDBMS that we are going to spend most of our time going forward is SQL Server, right? This is a Microsoft product, and the latest version that is available is 2019, right? So we are going to do exactly that. Now, if you already have any other version installed on your system that is already running, fine. It could be anything above 2012. It should be okay, right? Any version above 2012 until 2019 should be okay if you already have it installed. If not, then I would say you can go with the 2019 version, and this is the link that will help you reach that the download path. And in here, if you scroll down a bit, you will find something that's called as a developer edition, right? It says or download a free specialized edition. The above ones are paid ones. We'll not go for that, as we are just going to practice and run a few test queries on it. So yeah, we're going to go with the developer edition. Now, the developer edition is something which the Microsoft team builds for the community, right? For people who are willing to learn SQL Server development, the community of learners and who are trying to explore more. Developer edition is a free and a full featured edition, right? That means it has all the features that a enterprise edition. Enterprise is the I would say the full featured paid edition, right? So the developer edition has all the features, but the number of connections and the number of users that can connect to a developer edition is strictly limited, because it's a free edition, right? They obviously they'll have some things cut out from the original enterprise edition. So they give you everything that you can have with the enterprise edition. It's just that a few features like the users number of users that can parallelly connect and everything will have a certain limitation, which is perfectly okay. And that's the reason we will be going with the developer edition. You can download the file from here. And once you are done downloading, now with SQL Server, we'll also have to install a SQL Server Management Studio. Okay, now what exactly is a management studio? So as we discussed already, SQL Server is the RDBMS, is the actual relational database management system, which helps us create and manage databases for us. Now, the SQL Server itself does not have any user interface. So let's say I want to create a table inside a database, insert some data into a table inside the database, modify some data, delete some data. How do I do it? we basically have to write commands. We basically have to write SQL queries, SQL queries to be able to perform those operations on the database or on the tables. Now, in order for us to be able to write those commands, we need a platform, correct? Now, that platform is the SQL Server Management Studio. SQL Server Management Studio, the whole purpose is to serve as a user interface that helps us connect to multiple different SQL servers and execute queries against them. Okay, any kind of operation that we want to do, starting from creating a database to removing a database, anything in between can be done using the management studio. So this is just a user interface that lets us connect to different SQL servers and perform the different operations on the data. Okay, so with this link that I have provided you, the YouTube link, it will guide you on how to download and install SQL Server 2019 Developer Edition. Furthermore, it will also guide you on how to download and install the Management Studio as well. By the way, if you follow the instructions correctly, right after you're done installing your SQL Server 2019, it will also ask you if you're interested in downloading the Management Studio as well. So from there, you can directly go to the link, but never mind, you will have all the instructions on the YouTube video. Moving forward, as mentioned already, SQL Server is the core RDBMS or a database engine, which we use to create and maintain databases, right? And we create tables inside the database. So in a single database, let's say we are working on an organization database, we will have multiple tables like employees, departments, employee salary, and so on. Okay, we will have multiple tables inside a single database, and the data is not directly stored inside the databases. The data is stored in the tables. About the SQL Server Management Studio, as already mentioned and explained, it's a user interface that lets us connect to different SQL servers and also help us perform all the different operations that we want by letting us execute queries inside them, right? Inside the Management Studio, we can write queries and execute it against the server and the database that we intend to, right? I'll give you a walkthrough of the management. I'll show you what are the different components that you would see once you open your Management Studio. Now, before we jump on to SQL Server development, I want you to understand the prerequisites, or just in case someone asks you, hey, can you tell me if SQL Server is installed in this system? Or can you tell me how many SQL servers are installed in this system? Okay, that is the base to it. That is the fundamentals of any programming language that you're talking about. How do you identify and connect the dots? Okay, is the installation done correctly? How do you identify it? Right, so let's first talk about that, spend some time on that, and then we'll move on to the Management Studio and talk about SQL Server more in detail. All right, so whenever I speak about server or a system, right, I will be referring to our own laptop, our own laptop or desktop, where we will be installing SQL Server. All right, so a server or a system is usually referring to our own laptop or a desktop where we will be installing SQL Server. So when I say server or a system, it will be usually your laptop, your desktop, or my laptop, right? I'll be referring to these. Now, SQL Server has multiple versions. Like, I hope there was also a 2005, but I'm only aware, or I have had the opportunity to only work from 2008 and beyond, right? So 2008, we have a 2008 R2 version, a 2012, a 2014, a 2016, 2017, and a 2019. So these are the different versions that are available for SQL Server. Now, whenever we install one particular instance of SQL Server, one particular version of SQL Server, it is referred to as an instance, right? Instance is one particular version of SQL Server installed in our system. right? Now, out of these available versions, the most popular one that gained Microsoft a lot of customers is the 2008 R2. Companies, organizations, database developers are and were and are still crazy about this version of SQL Server. I mean, it was very difficult for SQL Server for Microsoft to convince the organizations using this version of SQL Server to upgrade into the next versions. I have in fact seen people were so companies were so adamant on using this particular version that they only migrated to 2019 or 2017 only when SQL Server, only when Microsoft said it's not going to support this version anymore, right? That is how much the developers and the companies or the organizations used to like this particular version. And since then, it has been a groundbreaking success for Microsoft. All right, and upgrading is not that difficult. It's pretty easy. Again, the database administrators are the ones who are in charge of the upgradation, but upgradation is really easy and simple. But downgrading is something that will be very tough, as is in a lot of systems, right? Downgrading compatibility is usually a lot tougher, in fact a lot impossible as well, right? So upgrading, as in the other systems with SQL Server also, it is really easy. Now, each instance is independent of each other. That means in one particular laptop, I can have multiple versions of SQL Server that I can install. And each version of SQL Server is referred to as an instance, and all the instances will be independent of each other. It means if I, let's say, have a 2017 and a 2019 version of SQL Server installed on my system, if I create a database on the 2017 SQL Server, it'll be only be visible there. Okay, although both of them are on my system, on my laptop, but the database once created on the 2017 SQL Server will be visible only there. Okay, on the 2019, it'll not appear in there. Now, one other interesting thing is when you install a 2017 SQL Server on a machine that already has 2017 installed and already an instance of 2017, it will try to repair it. It'll ask you if you want to modify, repair, or uninstall. Okay, it will not let you create another instance for 2017. Okay, I don't know if it has changed recently, but the last time I tried installing it didn't work. So yeah, you can try it if you wish to, but earlier it did not allow to create one single instance of multiple instances of the 2017 version of SQL Server. Okay, and as already mentioned, each instance will be corresponding to different versions, as it does not allow one version to be installed multiple times. Each instance will correspond to different versions of SQL Server. Now, during our installation, so while we are installing our SQL Server, we can assign names to our instances. Okay, we can name the instances while we are installing them, and based on our choice to name them or not, we either keep them as a create them as a default instance, or it is called as a named instance. Now, when we say it's a default instance, basically we do not assign any name to it. Okay, we do not assign any name. So instances for which we do not assign any name during the installation are referred to as default instances. Now, as I mentioned, we are going to connect to SQL servers using the management studio, correct? So when we are trying to connect to a default instance, let's say hosted on my particular laptop, I can connect it by providing the laptop name or the system name itself. Okay, so whenever I specify my laptop name or the system name to my in my management studio, it will try to connect to the default instance of that particular system. So let's say if my laptop name is Dinesh laptop, then if I provide Dinesh laptop as my server name and try to connect from the management studio, it'll try to look for the default instance of SQL Server on Dinesh laptop. Okay, because it does not have an instance name, so it can directly connect with the default instance. Now that is the reason we can only have only one default instance per system, so that there is no confusion as far as the connections are concerned. Because if SQL Server would have allowed multiple default instances, it would be very difficult for the management studio to identify which default instance should it connect to, right? So that's the reason there can be only one default instance per system. But I'm not a big fan of keeping a instance as default. So what I usually do, I name all my instances. If I have one instance of SQL Server also, I choose to name it, and those instances are called as named instances, right? So obviously these are instances that have a name attached to it. And how do we connect to named instances? We can specify in the server name, we are going to specify the name of the system, which is, let's say, Dinesh laptop slash the name of the instance that I would have provided. Okay, so this is basically how we connect to a named instance. Okay, so that the management studio can get into the system and look for the specific instance name and connect to it. Okay, and we can have as many named instances as you want, because while connecting we can specify which particular instance should it be connecting to. So as this way of connecting gives more clarity, SQL Server allows to have uh, more than one number of named instances. In fact, all what I usually do is I choose to name all my instances. Okay, I don't leave any default instances because of management reasons. I mean, managing named instances are a lot easier. Now let's say I how now how do I know how many instances are there in my system? How do I know which one is a default instance, which one is a named instance? Correct, these questions are very relevant here. So how do we know? How do I know, given a system, let's say I'm given a brand new system, and asked, hey, can you figure out how many SQL servers are installed in this? That means how many instances are there and how many of them are named, how many of them are default instances. So in order for us to figure out if a software or any other particular application is well installed, we need to check for its dependent services, right? For example, Bluetooth. Let's take the example of Bluetooth. Bluetooth is an application that helps us connect to wireless devices and helps us either transfer data or information based on our need, right? Or we can also connect to devices so that we can stream music or watch movies or whatever we wish to do. Now, for Bluetooth to be able to perform all these operations, to be able to connect to devices, stream music, transfer data, it will need a certain set of services that are installed during the installation of the software. Okay, so these are assistants of the application that helps in performing their core operations. So those are called as services. Okay, the dependent services can be found in services app. Okay, so if I search for services, I'll find a services application, and upon opening this, I'll get a window wherein all of these that you see in the list are all services. So Bluetooth, if you see, has its own set of services. There is a Bluetooth audio gateway service, there's a Bluetooth support service, Bluetooth user support service, and so on. So these services help Bluetooth perform all its internal operations. So for SQL Server as well, we will have a set of SQL Server services like here. As you can see, we have a set of SQL Server services here. Now, the most important out of every SQL Server service is this particular service, which is the SQL Server service itself. The rest of them are all dependent services. We will not be talking in detail about that, but yeah, we're going to spend some time on here, the SQL Server main service. Now, this SQL Server service acts like a universal listener. So as I mentioned earlier, from the management studio, we are going to specify the server name, pass the credentials, and connect from there. Now, who exactly validates if the user, the credentials that has been passed for that particular server has enough uh, privilege to connect, to be able to connect. That will be decided by um, that will be decided by this particular service, right? So the authentication request will be sent by the management studio to the SQL Server service of that particular instance that we are trying to connect, right? So this is kind of a gatekeeper for the SQL Server. Now, how do we know which instance is this SQL Server service meant for? Um, First, let's see if this is a named instance or a default instance. Now, for us to be able to figure out the name of the instance, you can see it right inside the bracket in here. You see, it's called as MySQL Server 2019 inside bracket. That means this is a named instance. If you find a name inside a bracket, you know that this is a named instance of SQL Server. And as a good practice, what I do is I usually name my instances based on the version that it belongs to. So if I'm installing a 2019, then I tend to name it as MySQL Server 2019. So this is the name of the instance. Now, what would a default instance look like? For a default instance, it would just say SQL Server. That's it. There will be no brackets and no name inside of it. So whenever we try to connect to the MySQL Server 2019 instance from the management studio, we will specify my laptop name / the instance name, and on clicking on connect, this SQL Server service will be receiving that request, and this will validate if the particular user has a sufficient access on the SQL Server 2019 instance or not. If it has, it will connect to it. It will let the user connect. If not, it will throw an error saying access is denied. So we will have as many number of SQL Server services as there are number of instances. So that means if we have 4 instances of SQL Server, we will find 4 SQL Server services for corresponding to each one of them. Okay, so in my case, if you see now, I have only one SQL Server instance in my system, and it is a named instance. So this is how you identify how many instances are there and how many of them are named and how many of them are default instances. Next is the now owing to the importance of this being a gatekeeper, right? It's very important for this service to be always in a running status. Why? Because if it is not running, it will not be able to process any authentication requests anymore. So although the SQL Server is online and in a healthy state, but as the service is down, it can no longer process the authentication request, and the requests will start timing out, right? So when the request time out, obviously it'll look as if the SQL Server is down, but it is not. The SQL Server is well online and healthy, but only because the gatekeeper is not running, it is not allowing anyone to connect. So that's the reason I call this as the heart of the SQL Server, because very similar to how a human heart is important for humans. In case, you can be as healthy as you can or you might, but if your heart is weak and if it is not pumping enough blood to your body, I might be wrong technically, but I'm trying to make a point here. If you're not able to, if it is not able to pump enough blood to the body, then obviously you tend to get weaker and you are in danger, right? The same happens with this. It's like the heart of SQL Server. If this is not running, that means no one will be able to connect to the SQL Server, and the SQL Server will be considered to be virtually dead, right? So this should always be in a running state. Next, coming to the startup type. The startup type here should be automatic. Now, what does the automatic startup type means? Whenever we reboot our system, right? Whenever we, let's say, restart or shut down, sometimes this service if it blocks the restart for some reason. Okay, Windows might choose to stop this service before the reboot, right before the reboot, or during the reboot. Now, once the system is back up again, obviously we want this service to be running again, right? So if we set the startup type to automatic, Windows itself will take care of rerunning this service again. In case it is not running, it will make sure that it runs again. Okay. The other options that are available that you can change to are, if I go to properties here, you'll find other startup types like automatic, manual, and disabled. Right, manual is when whenever the service stops, you will come in and manually start the service. But again, we cannot afford that owing to the importance of this service, so we keep it at automatic. All right, so this is all about the SQL Server service and how to identify if it is how many instances do we have, and if those instances are named instances or default instances. Second thing, and the most important thing is if this is actively looking or processing the authentication request that we are getting. Okay. Now with that, let's try to open the management studio, because as mentioned already, we cannot connect to a SQL server directly. In order for us to be able to, connect to SQL server and perform the different operations on the SQL server instance, we need to connect to the management studio. We need to connect it using the management studio. So I have already SQL Server 2019 Developer Edition installed on my system and the Management Studio. All that I can use and see is the Management Studio itself. So let's open the SQL Server Management Studio. As you can see, Microsoft SQL Server Management Studio 18. Now this is the latest version of Management Studio that is available. Okay, Microsoft releases a version of SQL Server doesn't necessarily mean that they might also be releasing a new version of the Management Studio. As I said, these two might be used to connect. Uh, um, uh, uh, the Management Studio might be used to connect to SQL servers, but it doesn't necessarily a part of each other. Okay, these are entirely two different softwares which are maintained by Microsoft. Now, the moment I launch it, it will show a pop-up saying that it's coming up. You see, it says Microsoft SQL Server Management Studio version 18.6. I don't know if there is already an upgraded version of this, update of this, but yeah, the one that I have is version 18.6 and copyright of 2020 Microsoft. And the moment it comes up, this is what you would see on your system. Okay, this is the entire Management Studio, how it looks like. And as mentioned, the whole purpose of a Management Studio is to be able to connect to SQL servers and perform the different operations on it, perform different data operations on it. So fair enough, the moment we open the Management Studio, we get a pop-up that asks if you want to connect to a server. Okay, and it says this dialog box, the first component that we see here is the server type, right? So it asks what type of server do you want to connect to. So in the server type, you will find a lot of them, especially the MSBI ones, the Microsoft Business Intelligence ones, like analysis services, reporting, integration services, or Azure integration services. But as part of the SQL development, we are always going to use the database engine, because we are mostly going to work on database development using SQL Server. So yeah, we're going to go with the database engine. And as far as the server name is concerned, if you remember, if you recall our discussion a few minutes back, I mentioned the fact that whenever we want to connect to a default instance, we would just provide the laptop name. Now this is my laptop host name. So I can use this, and when I click on connect, it will connect to the default instance on my laptop. But I don't have a default instance, right? I have a named instance. So in order for me to connect to my named instance, I would say I would have to specify my laptop host name and a slash and the instance name. So you see the name of the instance that I'm trying to connect is MS SQL Server 2019. So the management studio will try to connect to this system and this particular instance inside that particular system. So in the list of services, it will send the authentication request to this particular service because this is the instance name that we have specified. All right. Next up is the authentication mode. That means what kind of authentication are you specifying for the connection request? Now, the two important ones that we are going to use is Windows authentication and SQL Server authentication. We're not going to talk about the Azure ones as of now. So Windows authentication, when we choose this option, it is going to automatically use the credentials that you have used to connect to your Windows, right? So as you can see here, it does not even allow me to modify the username or password field when I choose the Windows authentication. Got it? That's because when we say Windows authentication, it by default takes up the Windows user ID and password that's been used to connect. But if I choose a SQL authentication, it would let me specify explicitly a login and a password, right? This is a user ID and password combination that is only available inside this SQL Server. So inside a SQL Server, you can create a login and a password explicitly as an account, okay, which is called as a SQL account. Okay, so this user credentials does not have any importance outside of the SQL, outside of this SQL server. Okay, so here, as you can notice, any user who has this combination of user ID and password and is on the network can connect to this SQL server and do any changes that they wish to, provided this user has sufficient permissions to modify data. So that's the reason SQL Server authentication are a lot dangerous. In case the user ID and password fall or is falls in wrong hands, then you always run into the risk of maybe exposing your data to the wrong individuals. So we usually use the Windows authentication as much as possible. But in some scenarios, I mean, we still use the SQL authentication. So after providing all these stuff, I would just say connect, and it would connect the SQL server and would automatically show up on the Object Explorer. So if I expand it, this is how it will look like, the Object Explorer. The Object Explorer helps us explore everything that's inside the SQL server, right? Now, inside each of the SQL server, we will find a lot of subfolders, right? And this is where a few of them are used by the database developers, and the rest of them are mostly managed by the DB administrators. Okay, so when you install any SQL server, it will have all those properties. Okay, now as simple as it gets, let me give you a definition of the role of a developer and an administrator. A developer is one who is in charge of developing and maintaining a database. Okay, but a database administrator is one who is responsible for maintaining this server altogether, right? Checking for the space, checking for the server health, checking for the performance of the SQL server, okay, and controlling who has access and who should be provided what level of privilege, right? All security aspects of this server are all taken care by the database administrators. They are basically the admin of the server. They manage this server, whereas databases development is something that we developers are going to work on.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
All right. So if you see here, these are the different subfolders that we have inside every SQL server, and we start with so we are going to spend most of our time, in fact, all of our time in the databases section. Okay, the rest of them will be mostly used by MSBI developers or the DBAs, the DB administrators. But just for you to have a brief bit of idea about everything, about all of these, I'm going to walk you through, give you a brief walkthrough about all of these subfolders that you see here. Okay, so let's start with the databases. So in the databases, we will have two types of databases. One is the system databases, wherein the moment we create our SQL Server, we will have a bunch of system databases created. That is pre-defined. Okay, and since the time I have started working, I've seen only these four system databases. The master database, as the name suggests, is the master to the rest of to the entire server. That means it has the users who can connect, the privileges that they have, the details about the different databases, what is the size of each of the databases, how much of space do they take, and which user is mapped to which database, everything else, right? So it's like a configuration, it is like a configuration store where the configuration of the entire server is inside the master database. The model database is how an ideal empty database should look like. Ideal new database should look like. Uh, so when Microsoft engineers were building SQL Server, they had a lot of good practices that needed to be followed while creating a new database. Now, they did not want to put the burden on the database developers while we were creating the database. So what they did was they created a model database. They created a database called model, which with all the good practices. And whenever we request for the creation of a new database, this model database would be copied with the name that we would have suggested. So let's say I want to create a database with the name Dinesh. What it will do is internally, it will copy the model database as it is and name it as Dinesh. That's it. Okay, so we have all the good practices now into our newly created database. Simple, right? So that's the entire purpose of the model database. Then we have the MSDB database. Again, this is a very important database, wherein in every SQL server that we have, we will have a friend in it. Okay, we all have that friend whom we can call at any point, at any time during the night, during the day, for any help that we need, right? And he or she will always be available. That is exactly what the SQL Server agent does for us as far as SQL Server is concerned. You might be wondering, what, how? Come on. The answer is here. So let's say you're asked by your manager to run a query every Sunday afternoon. Obviously, I mean, for obvious reasons, you might not be available every single day on every single Sunday on the afternoon to run your query. That doesn't make sense, right? That is where you can try to configure that query, that SQL query, the SQL command in your agent as a job. Okay, you see jobs here. So we can configure a job in the agent, and we can schedule it. So jobs are nothing but multiple steps, one or multiple steps that can be executed on the specified schedule. Okay, so this friend of ours will take full responsibility of executing your query at the scheduled date and time, right? So this is why I called this as a friend in SQL Server, because whenever you want to execute a query, let's say regularly at a specific time, you can always schedule it as a job, and the SQL Server agent will ensure that it picks up the job at the specified schedule and run it for you. And this is facilitated by the SQL Server agent service. You see the SQL Server agent service? Again, this is one per instance. So that means I'll have a SQL Server agent for this instance, I'll have another SQL Server agent for the other instance. Let's say I have another 2017 version. So each of these SQL Server agents will be responsible to call the jobs that are configured on that particular instance at the specified schedule, right? So the MSDB database works closely with the SQL Server agent, wherein it stores the details of all the jobs, all the steps inside each of the jobs, what is the schedule of each of the job, the historical runs of each of the jobs, when did it last succeed, what was the status of the previous runs, when is it going to run next, and everything else, right? So the details of the jobs and their statuses are all stored in the MSDB database. Next up, we also have a feature in the databases in SQL Server where we can send database mail. Okay, we can send emails from SQL Server. Okay, and all the emails that are sent also will be stored as part of the MSDB database. That means all the emails that has been sent, when was it sent, what is the status, if it was received if it was successful, if it failed due to some reason, right? The status of the email, everything else will be stored inside the MSDB database. Okay. Next is the temp DB, or as we call it as the temporary database. Now we will discuss about the concept of temporary tables. So sometimes during our processing of the data, during our manipulation of the data, we might need some heavy transformations that we would want to do, some heavy operations that we want to execute. Now executing it directly on the tables might not be a good idea. So it's better that we take the data into a temporary storage, do all the transformations that we need, heavy transformations, and then bring it back to the main table again, right? Those temporary storages are referred to as temp tables. Okay, we'll be discussing in detail about that. Now, all those temporary tables will be created inside the temp DB, inside the temporary database. Okay. So these are the different system databases that are available with every SQL Server that you install. And then we have other databases that are referred to as user databases. That means databases that we create for our own purposes. So what I usually do is for every batch that I conduct in the US, I have one database for each. Again, every batch that I conduct with Intellipaat, I have one database. This is my way of segregating my batches and making sure that I can segregate the sessions accordingly. So this is a walkthrough of the databases. Next up, you will find a security folder here. Now, as the name suggests, this folder helps us in configuring the different users. What kind of privileges do they have? What kind of access do they have on the server? So this security folder that you see here has the security configurations for the entire server. So this is a server level security folder. Similarly, we also have a security folder for every database. You see, AdventureWorks has its own security folder. April 2021 has its own security folder. So if you remember, in CORS rules, we discussed about the non-subversion rule. That means we can grant access to a child, cannot access to a child without granting access to the parent. So that means we can have a user configured to enter into the server, but have it configured to connect to only one single database. So that means that a particular user, let's say myself, I am supposed to be configured to enter into the server, but I only have access to the AdventureWorks database. So that means you will not find me in the security folder in the users. You will not find my name in here. Okay, because I am configured to only connect to the AdventureWorks database. right? So the security folder is for a server level security. That means what kind of privileges do I have on the server? And then in the databases, the security folder that is there has the database level security configured. Okay, so this is how the security is managed. Now, if you have opted for the DBA course, the database administration uh, course, then you'll be explained these in detail: the server roles, the database roles, and the logins, the privileges, everything. But we'll be not covering those in detail here. I remember you were asking about how to create a SQL Server authentication or a Windows authentication. So you can do it from here as a new login. Okay, so you can choose either to keep it as a Windows authentication, wherein you just have to provide the Windows user, or SQL Server authentication, wherein you can configure a new username and a password for that user, so that it can be configured, and you can choose what roles they should be a part of. Each of these roles have a different meaning. Again, we're not going to go in depth into it, but yeah, this is a very interesting topic in itself. So if you get time, not now, maybe once you're done with the course, and if you're more interested in the administration aspects, you can read more about the server roles and the database roles, and how a user and what each of these means, and how a user is configured into the roles. All right, so this is where you can create a new, either a Windows authentication or a SQL Server authentication. So basically, when you're creating a Windows authentication, it's not like you are creating the Windows user. It is just that you are letting the Windows user entry into your server. That's it. You are adding this user as a user who can connect to your server. That's it. You're not creating the Windows authentication itself on the network. Whereas on the SQL Server authentication, you are creating that SQL user, at the same time configuring what kind of roles and privileges that they would have. Okay, cancel that. Yes, interesting. If your SQL Server agent is disabled, like for example here, I can choose to stop it. If it is disabled, you will, in my case, you see a green color play button, but if it is disabled, you will see a red color square button, square symbol on your side. So in that case, you need to just right click and start it. Okay, either you can start it from here, or from the agent as well. You can right click and start it. Okay, because the agent, see, again, should be in a running state for your jobs to run. If this is not running, if you schedule your jobs also, it will not be run. Okay, let's talk about the server objects now. Out of this, the only thing that I've used is linked servers. So when you want to communicate between SQL servers, let's say I am connected on this SQL server. Let's consider it to be SQL Server 1, but I want to also get some data from SQL Server 2 itself, okay, as part of this connection. So I can link both these servers using a linked server feature. Okay, but for that we need two SQL servers, both available on the same network and having a common user credential. Okay, so only then we can use it. But one thing that you need to remember is, for linked servers to be configured, you need to configure them using SQL authentication. Okay, you cannot create a linked server using Windows authentication. So this is one such example where you cannot get away from using a SQL Server authentication. There's another feature called replication. This is another very underutilized feature in SQL Server, I must say. This feature helps in maintaining two tables across databases, across instances, or across systems in sync. Let's say I have two tables that I want to replicate. So that means a change done on the first table, it replicates onto the second one. That is when I create a replication. Now replication has two parts, the publisher and the subscriber. Publisher is the main source to which all the changes are done, and the subscriber is basically the table where the changes onto the first table are moved directly. Okay, now how is it moved, when is it moved, is based on what kind of replication you set up. You have transactional replication, snapshot replication, and a lot of other different types of replication, based on which it will move, it'll decide on how and when those changes on the publisher should be moved to the subscriber. Okay, so this is about replication. Polybase I haven't used, so I will not be able to comment on this one. Always on high availability is a feature that's been added on the SQL Server 2012, and it's been available since then. Now, the always on high availability is usually meant for very critical databases, right? So databases that are very, very important and cannot afford a downtime or cannot go offline, and the users are using it. I mean, let's say during the weekdays a lot. In that case, we can put the database in a always on high availability feature. We can turn the always on high availability to on for that particular database. Now what this will do is it will maintain a standby database for the database that we have configured, the high availability option. It will maintain a standby database with exactly the same structure and the same data as the primary database. Okay, and any change that is done to the main database, it will ensure that all the changes are moved to the standby real time. And under any circumstance, if the primary database, the main database, goes offline, then the standby database will be brought up to act like the primary database. Okay, so all the user requests that were coming in will now be hitting the standby database, and the changes will keep on happening, right? The users will be able to see the data, the users will be able to write the data, but it's just that it is now happening on the standby database, and in the meantime we'll have enough time to fix our primary database, and all this happens automatically. Okay, once we configure the always on high availability, all of these happens automatically. Again, I have not worked on this a lot, but I just understand the concept behind it. Then we have a management folder in which we can view the SQL Server logs, we can create maintenance plans. This provides us a very helpful user interface to create maintenance plan, and again it can be scheduled directly on the agent. So the maintenance plans are generated here, scheduled on the agent, so that it will be automatically executed at the specified schedule. And uh, uh, I've already explained you about the database mail feature. This helps us in sending emails inside our network to other users. Integration services catalog again is a part of the MSBI development package. So if you have already opted for the BI course, then you will be explained in detail about the integration services catalog. Then we have the agent, which I've already explained you about. X event profiler is something that I've not used, so I'm not going to go deep inside it. Can we create authentication for each DB? So yes, you will have to create all those. So if you're talking about different authentication for different databases, that means in one database it's a read-only access, in the other database it's a read-write access. You can do that with the same user. Okay, but if you're talking about different users for different databases, I don't see any relevance of that. Maybe you can use the same database, same user, to have different levels of access on the different databases. So yeah, I mean, up to you, but you can do both of them. You can create multiple users, or you can have the same user have multiple privileges, I mean different privileges on multiple databases. Replication that helps in replicating the data across tables. Okay, but in always on high availability, the entire database is in a sync with the standby. Okay, and also the advantage is the primary, in case it goes offline due to some reason, the standby is automatically brought into effect. That means it's brought live in place of the primary database. So the queries do not fail anymore. So yeah, the replication and the always on high availability are entirely different features. Now that we have taken a walkthrough of the entire of all the components inside the database, let's jump on to seeing where exactly can we write queries, where exactly can we write commands, right? Let's say I want to create a new database, or I want to create a new table inside a database. I would need to write queries, correct? Now, where do I write such queries? I write those queries on a query window. And how can we open a new query window? You see, there's an option here that says new query. All that you have to do is click on this or use Control and N together to be able to open a new query window. Okay, and this is how the query window looks like: empty, blank, and gives you a lot of space to write your queries. In your case, you might see your Object Explorer docked right next to your query window. So if you want to hide it, which is suggestible, you can just use this auto hide feature here. And if you use the auto hide, it'll automatically hide or dock to the left. And whenever you need it, all that you have to do is click on the Object Explorer and it will appear. If you again want to hide it, just click outside and it will go and dock itself. So the auto hide option is something that I find very helpful. And all that my motive while writing queries is that my query window should be clean. I should have a lot of space on my query window to be able to read and understand my queries. Okay. And we can write our queries here. I can have query 1, query 2, query 3, multiple queries written here and executed either together or in parts based on my need. Now, let me open a new. Okay, so how do we execute these queries basically, right? We can use 3 different methods to execute the query. We can use either the execute button at the top of the query window, that is here. You see there's an execute button. We can use F5, or in the new keyboards that has the function key, we can use function plus F5 together, or we can use Control E. Either of these options are works exactly the same, so it's up to your convenience. I prefer using the Control E, but yeah, it's up to you. You can use either of the 3 based on your own convenience. So you can highlight the queries that you want to execute and just click on execute. Now there's always this thing about being a good developer. You need to find ways in which you can make the lives of your fellow colleagues a lot easier, right? When you're a developer, you have a lot of responsibilities. Okay, you're building something. Building is as important as sharing why have you built it the way you have built it. Okay, this is something that very few people understand, right? Let's say someone did a great discovery, someone did a great invention, but they never spoke about it, but they never explained about it. Do you think it would be that particular person would be famous? Obviously not, right? So whenever we build something, it is always a good thing on our part to make sure that we document it properly, we explain it properly, so that anyone who reads about it, anyone who finds out about it at any point in time gets benefit out of it. The same applies to writing code as well, right? It can be .NET code, it can be Java, it can be SQL code as well. It's always better that we properly document stuff, we properly explain what we are doing and why we are doing it the way we are doing it. That is where comments comes into picture. Okay, comments are brief description about the code that you are writing, about the queries that you are writing, so that you can help someone else who is looking at your code at a later point in time. Let's say you have built a very complicated piece of code that is of 150, 200 lines. I mean, anyone who looks at it the first time will be all lost. And they would always wish if they could talk to the developer who built it. and your way to communicate with them is using comments. So right on top of the query or right next to the query, you can always either provide a one-liner description or multiple lines of description based on the need. Okay, and all of these will be ignored by SQL Server. These are called comments, and for multi-line comments, we can put it in this pattern. You see, we have a slash and a star, and close it with a star and a slash. So everything inside it will be ignored by SQL Server whenever we execute it, right? So if I execute all of these, you will see that it just says commands completed successfully, but it wouldn't have executed anything, right? Comments are very helpful that way. Now, if you have a single line comment that you have to provide, you can always put a double dash in front of it and write your description, so that anyone who looks at your code reads the description and understands, oh, okay, this is the reason why this code has been approached or developed in this particular manner. Okay, this is a way in which you are not only helping your team, but all the other developers who are going to work on your team from that day onwards for a lifetime, right? So it's always better to document or describe whatever you're doing in the form of comments, and comments are a sign of a good developer, I must say. Okay, when I was in the very new in my career, I used to think this is a waste of time, this is a sheer waste of time, and I'm very honest about it. But now that I have worked on a lot of projects, I see how difficult it is sometimes to understand someone else's work. I now understand how important comments are. Now, this might take a few minutes of your time, but it is totally worth the time that you're going to spend on it. So if I execute this, all of these will be ignored by SQL Server. Okay, it will have no effect on it. And this that you see here, this window that comes up very often when I execute something that says commands completed successfully, is called as the results window or the results pan. Now, obviously, as I said in the beginning, I would want my query window to be a clean slate. Okay, I want to only see my queries and nothing that blocks my vision from the queries, right?
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
So is there a way in which we can hide or unhide it? You can use Control R in here. Okay, so Control R will help you hide and unhide your results window. Okay, so the moment I execute my query, I see the results and the comments, I just hide it. Okay, one benefit of learning from a lazy instructor or a lazy trainer is that you will get to learn a lot of shortcuts. All right, so I'll try to share all the shortcuts that I have been using, which has made my life a lot easier in the past few years. Let's say you are describing, you have described a lot of things and you just want to comment them. Okay, you can always use Control K plus C together and it will comment those codes for you. So if I use Control K C, you see I've highlighted these three lines, and if I use Control KC, it automatically adds double dashes in front of all of those lines. That means these lines are now commented, but I don't have to do that anymore, because as you can see, it is already commented. You see, I have already commented this entire block in here. Okay, and comments can be visible in green color, will be visible in green color from your query window. Okay, so all of these are comments, so everything is visible in green color. And obviously, if you want to uncomment something, all that you have to do is press Control K plus U. Control K plus C will comment, Control K plus U will uncomment. Okay, you also have a feature here, so you can select the lines that you want to comment and you can click on this particular button here, or if you want to uncomment, you need to click on this particular button. Okay, this has no technical relevance, I've just used this here, so just in case you guys have any questions at any point in time, you can always refer to the line number and ask me a question. All right, so now let's get into a very interesting part where we are going to create a database. Okay, so when I say we spoke a lot about databases, correct? A databases is like a storage unit that helps us in storing data in the form of tables. This is something that we have already discussed about. Database also holds certain other objects that helps us in managing and accessing the data as well, which we'll be discussing as and when the sessions go on. All right, so to start off, we are going to start off by creating a database and then tables, and slowly we'll move forward from there. Now we can create a database using two methods. One is obviously using Transact-SQL or the T-SQL query, wherein we would just say create database, and for every batch, as I said, I create a new database. So for us, we will be creating a new one as well. So this one is 25th of July 2021. So I'm going to create this database, and I can either create it using the T-SQL or also using the graphical user interface. Right now, I haven't created it, guys, yet. All right, I've just written the query. I haven't executed it yet. Only when I execute, the database will be created. But there's another option to create a database, that is by using the graphical user interface, or the GUI as we call it. So that can be accessed from the Object Explorer. Right click on the databases and say new database. Okay, so when I click on creating a new database, the first thing that it asks me, let me maximize this window. The first thing that it asks me is the name of the database. All right, now let me copy this name itself. And if you notice, the moment I place the name here in the database name field, you will see the logical name in here automatically populated with the same name. Let me show you. See, the moment I paste this name here, it automatically populates on the logical name fields as well. Now, for every database that we create in SQL Server, it will create two files in the background. Okay, and this is entirely for SQL Server's internal purpose. Okay, we can neither open these files, we can neither read these files using any other application. Okay, SQL just stores them for its own internal use. Now let's talk a little bit more about these files. So whenever we create a database in SQL Server, there are two files that are created in the background. One of them is called the MDF, or the master data file. Other is called as LDF, or the log data file. Right now, the master data file uh, stores all the data that we store inside the tables. Okay, and everything is in encrypted format. You cannot open it and see it using any other application. Okay, only SQL Server can read and understand, and somehow it stores the data on the MDF. Okay, but we will be seeing the data in the tabular format like we have discussed earlier. Okay, but ultimately SQL Server, for its own internal use, it stores the data in MDF, and somehow it reads from it and stores the data to us in tables. And the other file is called the MDF, or as we call it as the log data file. Now, whenever we make any change on our database, let's say we add some data to a table, modify some data in a table, or delete some data from a table, then everything generates a log. Okay, for every data operation, there's a log entry that is generated. Now, that particular log entry is stored in the log data file, wherein it says this record has been inserted by this user at this date and time. And we are just assuming it. Okay, it's just a hypothetical example, but yeah, that is what the log data files has it, again in an encrypted format. So it holds the log of all the changes that is performed on the database itself. Okay, and for every database will have its own MDF and LDF file. So if I take you back to the GUI again, here you will find the first file represents the data file, which is the MDF, and the second file is the log file. And these are the name of each of the files. You can rename them if you wish to, but I'm not going to do that and leave it as it is. Now, obviously, as these are files, these will be stored in a particular folder, right? And which folder does it store in? This is the folder that it stores in. You see the path here? So you can choose if you want to store it in a different folder. It's up to you. Okay, so if I open up that folder, all my MDF and my LDF files for each of the databases, for example, the AdventureWorks has already two files, the data file and the log file. Let's say this particular database, the 2nd August 2020, has two files. One is the primary data file, the other is the log file. So every database will have two files of its own. So yeah, this is the folder where I place all my database files. If you see, there's an initial size that is configured to 8 MB. Does that mean the moment the database is created, it will consume 8 MB worth of space, and the log file also will do the same? Not really. Okay, the files will take up 8 MB. That is true, but inside the files, we will not have data worth 8 MB or log worth 8 MB. Okay, it'll just have a buffer memory space of 8 MB reserved for both the files. Okay, and whenever we add some data, right, it will use up from that 8 MB. Okay, or whenever we have a log that's generated, it will start using the space out of the 8 MB. But let's say once it grows, what happens if it reaches the threshold? Let's say we store data worth 8 MB. What happens after that? The moment all the 8 MB is filled up, that is where the auto growth option kicks in. Okay, we can set the auto growth in percentage. That means it can grow in percentages of the current size of the file, or in fixed MBs. Okay, so you can choose on based on your own need. Okay, so here by default it is set to 64 MB. That means the moment the 8 MB worth of space is used up, the data file will be automatically increased to 72 MB. That is 8 plus another additional 64 MB space added to it. So it becomes a total of 72 MB with 64 MB worth of unused space. Used space will be 8 MB, unused space will be 64 MB. But the total file will be of 72 MB. So this auto growth will be taken care by the SQL Server itself. Whenever it finds the 8 MB being used up, it will automatically increment it based on the auto growth option that's set up. Okay, the same applies for the log file as well. But these two files are independent. That means once the data file is reaches the threshold of 8 MB, it'll be incremented by 64 MB. That doesn't mean the log file also will be incremented by 64 MB. No, only the data file will be incremented by 64 MB, and it will take up the size to 72 MB. The log file will still stay at 8 MB unless it is not entirely used up. But then till what level will the auto growth work? It depends on the max size that has been configured. If you want to limit it or set it to unlimited. When you set it to unlimited, that means these files can keep growing. The auto growth will be applied unless your drive is not filled up. Your C drive is not filled up. Okay, that is what unlimited really means. Okay, so now that we have understood all the aspects of it, let's say okay, and if I take you back to this folder here, you should be able to see 25th July. Yeah, there you go. You see 25th July 2021, the data file and the log file has been created. Okay, and at what time? At 25th of July 2021 at 9:50 p.m., which is a minute back. And let's see if the database has been created on our SQL Server. So if I open the Object Explorer, you see there's a database created with the name Intellipaat 25th July 2021. So now that the database is created, if I again try to create the database, it will throw me an error saying the database already exists. Use a different database name. So obviously, I mean, it doesn't allow two databases to be of the same name in the same instance of SQL Server. All right. Okay. Now our database is created. Let's say I want to execute or create a table in our database that we created newly. How do we do it? So we want to create a table where in our database that we just created, correct? So in order for us to do that, we need to ensure that our queries are executed against the database that we created. But for now, if you notice, our query, if we execute a query, for example, this one, where is it exactly executed? This query, when executed, is executed against, you need to refer to the connection details that's in the bottom banner. Okay, the query windows connection can be different when compared to the object explorer. Okay, a lot of developers, they get confused here. Okay, they assume that whatever server is connected on the object explorer is what exactly is connected on the query window, but that's not entirely true. Right, see, from here, from the object explorer, I can choose to disconnect my server, but my SQL server will still be active. If I just say, let me show you this one. Okay, you'll see that my SQL server is still in a connected state. And where is it connected to? To my server, SQL server, and it is using this particular user. And it is connected to which database? The master database. So whenever we open a new query window, it is by default connected to the master database. And you can see the same on the top here on the left hand side top banner and in the drop down here. So the drop down says the master database, right? So that means if I execute a query, it is now executed against the master database. If I write a query to create a table and execute it, it will be created in the master database. Is it expected? No, we want to create it in the database that we have just created, right? So in order for me to change the connection, I can either choose directly from the drop down the new database that we have created, which is this one, Intellipaat 25th July, or as we are here to learn about SQL, let's do it the SQL Server way, right? The T-SQL way. So in order to change it, we just have to say use and then specify the database name that we want to connect this query window to. So we are already connected to the correct instance. All that we need to do is change the database. And in order to change the database, the connection to point to this database, we say use and the name of the database. And if executed, you will see that now the drop down value has changed to the new database, and also in the bottom banner as well, it now says that our query is pointing to Intellipaat 25th July 2021. Okay, so this is how we can change the connection of the query window. If we want to remove this database entirely from the instance, all that we have to do is say drop database and the name of the database, right? So this query will help us remove the database entirely from the instance. Okay, so it will get rid of the database and all the tables, data, everything inside of it. Okay, but I'm not going to execute it right now. In case you want to try it, go ahead, it's okay. And once you drop it, you can again recreate your database. What I wanted to show you is that the object explorer is nowhere related to the query window. Okay, my server can be disconnected from the object explorer and my query window will still stay connected. That was my whole point. Some people assume that whatever server we are connected to on the object explorer will be the same on the query window. But no, you can choose to change your connection directly from the query window. How? From the right click on a query window anywhere and go to the connection and you can change it. Right? You can change it to anything else. Let's say I want to make it connect using my SQL authentication. I can connect it. You see, now it connects to this server, but using the Dinesh test user. But on the Object Explorer, I can connect it using my own Windows authentication. So in here it connected on the Object Explorer connected using the Windows authentication, but on MySQL server, my query window, it is connected using the SQL authentication, right? So the whole point of me explaining you this was to make you realize that you it's not always necessary that the server that is on your Object Explorer is the same on your query window. It can be changed directly from here as well, right? What the big mistake that people new developers do, is they assume that the server they're connected here is the same on this query window, and they tend to blindly execute the query. Let's say you are connected to the lower environment on your Object Explorer, but you're connected to a very critical environment on your SQL query window. Then you end up into the risk of executing your query in a much critical server, which you didn't want to do, right? So be very careful before executing your query. Check if the server and the database is exactly what you want to execute your query against. Okay, so let me again change the connection, because again it was connected to the master database. So in SQL Server, sometimes, in other querying platforms like Teradata or Postgre, you are expected definitely to use a semicolon if you are specifying multiple queries one after the other, right? But in SQL Server, there is no need to do that. And so you can either use a semicolon or a go as a replacement. Okay, so go is just to ensure that, just to say that I'm ending my query here. Go is entirely optional. You can choose to keep it or remove it. But in some cases, it might be necessary, where when you're trying to create two objects back to back, like let's say I'm creating one table here, and right after I'm creating another table, then I need a go in between, because two create statements cannot follow each other back to back. We need to have a go in between, so that we say, okay, this is one create statement and the other is another create statement. Okay, so go is necessary in a few situations, not everywhere, but I've just used it here so that I could explain it, but I wanted to go there, but thanks for asking anyways. There are two types of database architecture, as we discussed. One is the file server, wherein the data is stored in the form of files, and then is the client server architecture, which is a typical RDBMS. So this is the DBMS, where data is stored in files, and this is RDBMS, where data is stored inside the databases in tables. Okay, now talking about the file server architecture, I think we already had enough discussion on this. We'll have files inside local systems with data in them. So the files will have data, and these files will be placed inside the local systems. And if we somehow, if we at some point in time we create a copy of the original file, then tomorrow if we are making changes in the original file, it will not reflect on the copy. But in a RDBMS, we certainly have the privilege to have changes replicated from a database or a table to another by using multiple mechanisms. As far as file server architecture is concerned, the accessibility is also at a risk, wherein let's say one of the users is already accessing one of the files, and that same file I'm trying to modify. I'll not be granted permission to do that. It will tell me that it is already opened by someone for editing, so I'll not be able to access that file. For me, I'll have to wait until the first user is done with his or her changes, and only then it will process the it will allow me to edit the files, continue editing the files. But in a client server architecture with a typical RDBMS, we will have the data stored inside the database server. Okay, in the database server, in the database, the data will be stored, which will be stored inside a database server, which is SQL Server in our case, which will be installed in a system, and multiple components will be able to connect to the SQL Server using OLEDB components, multiple connections like the Management Studio, a .NET utility, Java utility, all of them will be able to connect to the database server using OLEDB components. OLEDB components are pre-installed in Windows that helps us in connecting to the SQL Server databases. Okay. SQL stands for a structured query language. We've already discussed about it, which is a standard language for accessing and manipulating databases, right? So SQL stands for structured query language. It helps us in accessing, storing, accessing, and manipulating data inside the databases. We have different categories of SQL commands. We will talk about each of them as and when we move forward. We have discussed about only the create database until now. So yeah, as and when we move forward, we'll be talking about all. But let's start. So just to give you a brief walkthrough about the different categories that we have. The first one is the data query language. The data query language has select query in it that helps us in querying the data. That means once we store the data, to retrieve the data, we use the select command. For the data definition language, the commands that helps us in defining the structure of the tables, okay, that is what falls under the data definition language. Now the data definition language has a create table, alter table, and drop table in it. So create is to create a table, alter is to modify an existing table, and drop is to drop the existing table. Okay. Next is the data manipulation language. Now in a data manipulation language, it helps us in manipulating the data in the database. So for this, we have insert, update, and delete command. This helps us in manipulating the data or changing, storing, modifying, or removing data as per our need. Last but not the least, we have data control language that helps us in controlling the access of certain users. We can either grant access or revoke access based on our need. Okay. Coming to tables in SQL, a table is a database object which comprises of rows and columns. This example is of an employee table. It has multiple columns. The example that I've given you with Excel, so I'm not going to go deep into it. A record is a row, whereas a field is a column in a table, right? So employee ID, name, salary, age, gender, and department, all of these are fields. So if you look at a field provides specific information about data in a table, like salary tells us what is the salary of each of the employee. Similarly, gender tells us what is the gender of each of the employees in the employee table. And then we have records in a table. Record is nothing but each row. So each employee corresponds to one row in the employee table. Each individual entry in a table is called as a record. Okay. Moving on. All right. Let's move on to the first question for the module. The first question is, what does SQL stand for? We will have multiple choice questions, and all I want you to do is key in the option in the chat window. Whoops, I see a lot of answers already. Fantastic. Okay, so that's pretty simple. I'm going to open up the answer in 3, 2, 1, and here we go. So all of you are correct. It's structured query language. That's a very good start. Thank you so much for participating. Let's move on to the next question. Which of these are different categories of SQL commands? Which of the below do you think are different categories of SQL commands? All right, so I guess all of you have gotten this one correct as well. The correct answer is D, all of these. So that's again a job well done. Fantastic. Let's move ahead to the next question. Grant and revoke come under which category of SQL commands? Whoa, you guys need to take a pause. You guys are too fast. Nice, keep going. All right. Okay. Nice. Okay, I see all of you have gotten this one correct as well. The correct answer is D, data control language. That's again a very good attempt, I must say. Moving on to the last question for the module. This is something that I want you to think about very carefully and then answer. Which of these is true about a record? We discussed about records and fields, right? So which of these is true about records? This, I think, can have multiple correct options as well. Okay, you can, there's a chance that you might have two correct options here, two correct answers here. Okay, I see a lot of answers already. I'll give you guys maybe a few more seconds. Perfect. So I'm going to open up the answer, and the correct answers are B and D. And I see most of you have guessed it correctly. How to draw a database if required, right? So today let's start by discussing about tables in SQL Server. Now, what are tables? As you already know, and as I've shown you in multiple examples, a table is basically it has multiple columns in it that helps us store data in the form of rows, right? So for example, employee, if employee is a table, then we have multiple columns for the employee, we have different properties of the employee that we store in the form of columns, like the employee ID, the first name, last name, address, designation, and so on. Similarly, here when we create a table, we essentially need three things, right? One is very important, the name should be self-explainable, it should be self-explanatory. Now whenever we storing, let's say we are storing employees, it's better off naming it as employee. Let's say we are storing products in it, it's better that we store it as create the name as product. I always prefer giving singular name. If you prefer doing that, feel free to go ahead, because I usually name all my tables in singular instead of naming it in plural. And then so in order to create the table employee, I say create table employee, and then we decide on what properties of the employee are we going to store. So here we are going to store the employee ID, the first name, last name, salary, and address. So these are the different columns that we want to store for the employee itself. Now, for each of these columns, the type of data that they can hold will certainly be different, correct? So the employee ID will be a number. So we are going to specify it as integer, right? I'm going to show you the different types of numerical data types maybe a little later in the session. But yeah, let's start with by using the integer data type here. Similarly for salary as well, let's go ahead and use integer, because assume that we have whole numbers in here, so we can use integers. I'm going to show you what can you use when you have decimal numbers. Okay, we have a decimal data type that I'll again explain you a little while later. For first name, last name, and address, we will have alphanumeric characters, correct? Especially for the address, it will be alphanumeric, whereas for employee first and employee last name, it will be mostly characters. So
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
for both of these and the address as well, we are going to use varchar data types. So the varchar data types helps us hold integer as well as character values, so alphanumeric characters basically. And if you see, the numbers inside the brackets represent the maximum length allowed on that particular column. Maximum length of the first name should be 100, maximum length of last name should be 100, and maximum length of the address should not exceed 500. Anything that we any name that we provide in excess of this length will fail. Okay, it will not be able to insert, it'll throw an error. So this is how we specify the we specify the creation of a table. Now is it essential to write it in exactly this structure? Not necessarily. Okay, and that's the truth. So here I can also write it in a single line. I mean, it would still work. SQL would not fail it on you. So if you notice here, I can write all of these in a single line. But as a good developer, as a good practice, you need to make your query readable. And how can you make your query readable? By indenting it properly, right? SQL queries can get any piece of code, on any language that you write. Okay, it seems a lot more complicated than it is when it is not designed properly, when it is not written down properly, when it is not arranged properly. Any complicated code arranged properly will definitely seem to be a lot simpler. Okay, so here I'm going to I usually have this habit of writing or creating my table structure like this. I mean, it wouldn't change anyway in any way the structure of the table, but it's just that the code is now easier to read and understand. So here I go about and say create table, and I let's say I execute the query. Now, before you execute the query, if you remember in the last session, I told specifically that before you execute your query, check if the database where you're executing it is correct. Now, we created a database for ourselves, right? Which is Intellipaat 25th July 2021. Now, how do we confirm if our query is going to get executed against that database? You should see it in the drop down here. You can see Intellipaat 25th July 2021. It's here as well as here as well in the bottom right banner, right? So that means we know for sure that the Intellipaat 25th July 2021 is the database against which our table will be created. So I'm going ahead and creating this table, right? So it says commands completed successfully. Now you would have noticed I have the address in square brackets, correct? Now this is certainly a address here. If I remove the square brackets, you will see it in blue color. Now, why does it show in blue? If you notice, all the SQL commands show up in blue color. All the special keywords which has a meaning in SQL are shown in blue color. So here we know for sure that address is a special keyword, is a SQL keyword. That means something in SQL language. We can certainly use these as column names, but if you don't want to see them in blue color, okay, just in case, you can put them in square brackets. When we put something in square brackets, we are forcing SQL Server to read this as a plain text and not as a command. Okay, so whenever you're using this, it is not necessary to use, I mean, it's not mandatory to use the square brackets, but again, it is not a good practice as well to name your columns on a keyword. Okay, you can maybe replace it with employee address or something like this, right? So I know that, okay, this is the address column. Okay, but I'm going to stick with the address itself as of now. I just wanted to let you know that you can use certain commands as column names, but not all. For example, I cannot use create is another keyword, right? But I cannot use this as a column name. You see, if I put it in square brackets also, it's not a good thing, because see, use a name, use a keyword that will work without the square brackets as well. The address works without a square bracket as well. A square bracket should not be mandatory. Now, so we have created the table, right? And if I want to see where it is created, if you expand the databases here, you will find in the 25th July 2021 database, inside tables, you will find the employee table has been created. Right now, if you remember, we spoke a lot about the metadata, right? And I also mentioned how the RDBMS should be responsible to store the metadata the moment we create our table. So here, how do we see the metadata of a table? We have to double click on the table name and do a Alt F1 here. So when I do a Alt F1, I'll be able to see the metadata of the object, like what's the name of the object, who is the owner of the object, who's the type of the object, and then when was it created, what are the different columns, what are its respective data types, and the length as well. Ignore the length of the integer, okay, they are not relevant, but yeah, you can check for the varchar columns the exact length of each of the columns. So this is nothing but metadata of the table. Now in So Alt F1 is what you can use. Now, in some cases, Alt F1 might not work. So in such cases, you can use sp_help and then the name of the table. Okay, this will also give us the exact same output, which is the metadata of the table. Now, did we store any of these metadata? We did not, right? It was stored automatically by SQL Server itself. Now, there are other things that you see here. We will talk about maybe a few of these as and when we move forward in our session. Okay, so now our table is created. Now, if you notice, there's something called as dbo.employee. What we did not add any DBO, right? In front of the table name, we just said employee. Now, what is this DBO exactly? We have in SQL Server something called as a schema. Okay. Now, DBO stands for database objects. Okay, and DBO is the default schema for all database objects that we create. Now, whenever we do not specify a schema name for the table or any other database object, it will be created by default in the DBO schema. Now, I must be wondering, okay, what exactly is a schema? Let me explain you with the help of an example so that you're very clear about it. Let's say you're trying to build a database for Amazon. Okay, now Amazon in itself has multiple different business lines, isn't it? They have they work with food products, they work with clothing products, they work with electronics as well. So they have different business line that they have to manage. Now the food business line will have its own set of employees who work in the food division, its own set of products for the food the different sales that has been performed on the food items, the profit that has been made on the food items. All of these are data specific to the food business line, correct? Similarly, we will have the same set of data for the clothing as well, the same set of data for electronics as well. Now, how do we segregate these data and store it separately, manage it separately, control it separately? We can manage that by using schema. So what we can do is we can create different schemas for different business lines or business units. Okay, and then let me create this. So I just say create schema and I create the schema names. And then what I'm going to do is, if you remember the structure of the employee table that we created earlier, instead of just saying create table employee, I'm going to create a table called food.employee. So food is the schema and employee is the table name. And the structure is going to stay the exact same. Similarly, I'm going to create an employee table for the clothing business unit, employee table for the electronics business unit. Right. So what is going to happen is later in the day, when we have employees in the electronics department, we are going to store it in this particular table, which is electronics.employee. When we have employees in the clothing department, we are going to store them in the clothing.employee table. Food department's employees will be stored in the food.employee table. Right. So this is how we segregate our data. So what we have now is we have created 3 schemas where under our database, inside our database, which is 25th July, right? So inside the database, we have schemas and then the tables are attached to the schemas. Okay, not only tables, but other objects that we will be discussing further. Okay, but for now, to give you a context, tables are attached to schema. So now, if you notice here, dbo.employee makes sense, right? DBO stands for database objects, and as I did not specify any schema name here, that is the reason it got attached to the DBO schema. Now, are schemas mandatory? Not at all. Did we create a schema before creating the table? No. Right? Because we already have a default schema, which is DBO. Now, let's say you do not want to segregate your data, you do not have multiple business lines to maintain, then you can happily live with the DBO schema. You don't need an extra schema or a specific schemas that you need to create. So let me go ahead and create these 3 new tables for the new schema. I mean, for the 3 schemas. Okay, you see, it says commands completed successfully. And now if I refresh my tables, okay, as you can see, we have 4 employee tables now, one for the clothing schema, one for the DBO schema, one for the electronic schema, and one for the food schema. Now, there is another advantage of the schema. Now, if you remember, I said a specific line wherein I said how to control the different business lines. We can do that using the clothing schema by, we can do that by using specific schemas, by also specifying which user can have access to which particular schemas. Schemas helps us in clearly segregating the access privileges as well. So this now serves as a container, okay, inside a database. Okay, let me give you another example. Okay, you will relate to with this within this pandemic. You must have heard of people in India must have heard of storage spaces that have come up and is in a lot of demand in the last 1.5 years since COVID has taken a toll. Right now, for people outside of India, let me give you a context. We have a monthly rental service storage space that is provided to us by in each of the cities in India privately. Okay, this is not a government initiative. This is a private initiative. I mean, there are multiple startups that have come up with this idea. What they have is they have huge warehouses, okay, wherein they'll give you one container each to store all your belongings. Okay, you can store your beds, your dining tables, your chairs. So you can basically vacate your flat if you don't want to pay rent. Let's say you're staying in an outside city, uh, um, and you don't want to rent that place anymore because now everything is basically work from home, right? Everyone is working from home, so you can basically work from your native as well, from where you're born and brought up. So you can vacate your rented apartment and shift all your belongings there at a much cheaper rent. So what they have is they'll have one huge warehouse, okay, of thousands of square meters or feet, and in there they'll give you each one container wherein you can store all your belongings, okay, after you vacate your flat, in the same city at a much cheaper rate. So we are all in a win-win situation here, right? Now, if we take that example, the entire data warehouse is a database, okay. Inside those, the containers that we have are our schemas, and each schema has multiple objects, that is our bed, our dining tables, even our bikes as well, even our four-wheelers. Okay, they'll give you a storage space where all of these will be stored safely. So my container keys will be with me, correct? So that is exactly what happens with the schema in databases as well, in SQL Server as well. Someone who needs to have access only to the food schema will have the access. I mean, there is a provision in SQL Server wherein you can control the access and grant him or her access only to the food schema. Okay, that is the reason you will see the schemas as part of the security folder here. You see, schema is in the security folder. You'll see the different schemas here. So whenever you're adding a user, okay, we are not going to talk about that in detail, but I'm just giving you a overview of what exactly happens. So when you are adding a user, you can also choose which specific schema inside the database a user can have control. Okay, maybe read or read write. You can specify that on your own. So maybe if you have opted for the database administrator course, maybe then you'll be explained about this in detail. Okay, but again, this is a very interesting read. Okay, if you want to explore on yourself, maybe you can do that later whenever you have some time. So schema is a way, is a method that we use to partition our database based on business lines, business units. It could be based on continents. It could be based on anything that you wish to. Now, are schemas mandatory? As I explained earlier, no. You can still live with the DBO schema. So whenever I just refer to the employee table, it means I'm referring to the DBO.employee. Only when I specifically mention the schema name in front of the table name, that is when I am specifically referring to a table inside that schema. If I only say employee table, it is going to always look for the DBO.employee table. So my point is, I mean, use a name that you can use like this. Okay, use a name in a table as a column name, when you can use it as it is without square brackets. See, it is failing here, right? So if I mean, most of the time it'll throw an error if I don't use the square brackets. That means it will mandatorily need a square bracket, which I don't feel is should be forced on the database users. Okay, that's the reason I feel address is a good choice, because address does not need bracket mandatorily. Okay, you can choose to keep it, but it is not mandatory though. But at the same time, this is a keyword. Okay, so these are like normal keywords in SQL Server, but create is a special keyword. When I say special keyword, that means you can only use it in that particular context itself to create something, not as a column name. But address is a keyword that can be used in multiple different contexts. These are two different tables in the database. I mean, food, electronic. So if I store some records in the food.employee, it will be specifically stored in that particular table. Okay. Okay, that's strange for me as well. Maybe in 2019 they would have resolved it, but until 2017 I was aware that go is mandatory between two create statements. And if I tried creating two tables one after the other, it used to throw me an error. But good for us. I mean, it's no longer needed. Maybe let me try something. Ignore this query. Okay, I'll explain what this query is about. Okay. Yeah, I guess it does not necessarily need a go anymore. So well and good. I mean, okay, thanks for letting that know. All right, perfect. So good way to start the session, isn't it? Something very intensive. So now what we have done is we have created tables, we have created schemas, and then we have created tables inside schemas and understood the entire ecosystem, right? Understood where each of these fits in. What is a database, what is a schema, and then what is a table. Now let's see, how do we insert data into a table. Okay, most of the times once we create the database, once we create the schema, once we create the table, the structure is already, it is usually filled, the data is usually filled from the application, from a website, right? A website. So for example, any database that we build has a user interface on the front, right? For example, Amazon has a user interface where you see everything very beautifully designed and displayed for you. But again, all the data that you see on the screen is pulled out from a database, is extracted from a database which is lying in the background, which is beneath. Now, whenever we build a database and the structure of it is entirely ready, we usually connect a user interface um, to connect to this database. And whenever the user makes some changes, let's say we will give a user a form on on the UI, wherein they will be asked to fill in the details of employees, and then automatically it will be saved into our database. So most of the time we just have to create the structure and the data will be filled in from there. But let's understand how we can fill data from SQL Server itself. Okay, so there are two methods in which we can insert the data into a table. One is using the values method and the other is using the select method. So how do we use the values method? Very simple. We just start with insert into employee table and then list out all the columns in a specific sequence. Now, one thing that you have to remember is whenever you're specifying the insert command, here I just say employee table, right? So that means where should it insert into? DBO.employee. You see, when I hover on top of it, it says Intellipaat 25th July 2021.dbo.employee. Okay, because as explained earlier, when we just put the table name, it automatically searches for it in the DBO schema. And then I specify all these column names here for the employee table. Now, should it be exactly in the sequence as they are present in the table? No. These should, you can place these in any sequence that you wish. Okay, irrespective of the sequence that they are there in the table. Okay, but one thing that you need to remember is, let's talk about values and then I'll tell you about that. So then what we do is we provide the values, and in here we provide the values for one row each. So here I say one is the employee ID for a specific employee with name as Dinesh. Going into the first name, Kumar is the last name, 1000 is the salary, and India is the address, right? So this basically constitutes the details of one single employee, which is Dinesh. Now, if I execute only this query, it will insert only one employee now. Okay, only if I execute this much, this part of the query. Okay, but if I want to add, let's say, multiple employees together at a time, right? You remember the high level insert, update, and delete rule, where it should allow us to insert, update, and delete multiple rows using one query. This is what I was talking about, right? We can provide multiple rows with values in here, and we can execute this together with the insert to insert the data. Okay, now in here, one thing that you should remember that we were discussing earlier was, in whatever sequence you place the columns here, in the same sequence your values should be provided, because if you do not provide the values in the same sequence as your columns in here, then you run into the risk of inserting values into the wrong columns. Let's say the last name and first name were switched in here, but I did not switch them here. So Dinesh will go into the last name column and Kumar will go into the first name column, which is bad, right? So in the values, you need to maintain the same sequence of values as the number of columns are, as the columns are there. All right, so here let's go ahead and insert, let's go ahead and execute this command, and it says 4 rows affected. As you can see, means 4 rows would have got inserted into the employee table. So you can either choose to insert one row or multiple rows, comma separated. Again, you see how beautiful this query looks. I mean, the only reason it looks beautiful is because it is readable, right? It is appealing to the eyes. I mean, you don't have to like scratch your head saying, oh, what is this, right? Anyone who is new also should be should easily understand what this query does. So again, the same exact thing that we do, that we did earlier. We say start with the insert into the table, employee table, and here I specify all the column names in any sequence, doesn't really matter. And then in the select, I pass the values in the same sequence as the column name. So here I select the employee ID, the first name, the last name, the salary, and the address, right? So this is for the 5th employee, right? We have inserted 4 employees here, correct? This is the 5th employee ID that I'm trying to insert. And here, if I want to insert multiple records, I use union all to merge them together into one single result set. Now, what does a union all really mean? Let's understand union all, and then we'll come back to our insert statement. So here, select, we use it to retrieve data from to see the data on SQL Server. Okay, to retrieve the data, we use the select command. So if I say select one as it is, let me show you what it gives us. You see, it just shows us one as a column. So it's a single row and a single column with a value 1 in it. Now let's say I put comma Dinesh in here. What do you see now? You see 2 columns in a single row. So the more number of columns that I add, I can add it using comma. Now, let me remove this. Okay. Now, if I execute, if you see there are 3 select statements here. So if I execute all of these 3 together, what do you see? You see 3 records, one Dinesh, and 2 Dinesh. Basically what we have here, one Dinesh, and 2 Dinesh. So 3 rows are inserted, but sorry, 3 rows are selected, but in different result sets. But when we want to insert into a table, we need all of them in one single result set, right? How do we have that? How can we have that? By using union all. Okay, and if I execute it now with the union all, you will notice that all of these are now merged into one single result set. Okay, now I can also use a union. Okay, instead of a union all, I can also use union. Now, I'll let you guys figure out and tell me the difference between the union and the union all. Right? I have executed both the queries. I want you guys to answer me what difference do you see between the union and the union all. I mean, you can put it in the chat window. Second one has unique values, remove duplicates, union all gives duplicate. Nice. All of you guys, brilliant answers. Nice. Yeah, that is what I was looking for. Exactly what the union does. The union only gives us the unique records from the set, from the result set, right? And that is the reason the union runs a little slower comparatively than the union all, because the union all doesn't care. It just displays whatever records are selected. But the union, on the other hand, gives us only the unique values from the select. So here what I've done is I am using union all. So certainly it is going to combine all of these uh, selects into one single result set. You see, one single result set. So this is why I love the select method of inserting data, because the select method, I can see the data upfront in the form of a table just to rectify any bad data that I might be storing, okay, just in case. But here everything seems to be okay. Let's assume that everything is okay. I just go ahead and insert it. See, another 4 records inserted. So here we inserted 4 records, and using the select also we inserted 4 records. Now, as I said, the reason I prefer using the select method a lot is because I can select and see my data before I actually insert it into the table. But here with the values, I cannot do that. That's the reason I choose. Going forward, you will see most of the time I'll use the select method of inserting data into the table. All right, so we have inserted about 8 records now, correct? Now we have stored data into the table. Let's see how to retrieve the data from the table. We can just fire a select command to see the data. So here I say select star. Now what does a star means? Star represents all the columns from the table. So I'm saying here, hey, get me all the columns from the employee table. Now when I say from employee, which employee table is it going to fetch from? The dbo.employee. So if I execute it, there you go. You see, about 8 records inserted. These 4 were inserted later using a select, and these 4 were inserted earlier using the values method, right? So this is how we retrieve the data from the table. We see the data that's stored in the table. I'll show you the different things that you can do with the select, how to restrict the columns that you can see, how to restrict the rows that you can see. We will talk about that in detail a little while later. Now here, if I want to see the data from the food.employee, I'll have to specifically mention the schema name. And here, if I execute, you see, I mean, the food schema employee table, we have nothing inserted yet. So it just shows blank, but it shows what all column.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Columns do we have in here? How have we to create table with schema or without schema? Have we create the table name? We created table without schema name, in which case it gets attached to the DBO schema. And if we don't want any specific schema to be attached, wherein it'll be attached directly to the default schema, we just provide the table name, which will be DBO dot, which will be assigned to the DBO schema. Okay, so next let's talk about constraints, or as we call them as integrity constraints. We discussed about this a little bit when we were talking about the different tables, right? When I was giving you examples of the employee and the department table, if you remember. So the employee and the department table, when we created, we discussed that we are going to reference this column while creating the department ID column. We are going to reference this column to point to this column, right? So the values from this column will be stored in the department ID of the employee table. And this is nothing but a rule, isn't it? That this column, this department ID column in the employee table will only store values from here, okay? Also, let's say I mean, no one will have a negative salary, correct? So I can establish a rule on the salary column saying do not, or in fact, accept values only that are positive. That is a rule. Employee ID cannot be the same for more than one employee, correct? It should be unique for each of the employee. So I can say the employee ID column should be unique in nature. That is a rule. All these rules are nothing but integrity constraints in SQL Server. So in a way, by applying these rules, we are ensuring data integrity in the tables, right? We are making sure that the tables have the correct data that we are expecting in each of the columns. So in each of the columns, you can choose which rule you want to apply based on your need. Okay, it's not mandatory that all columns should have rules, but you can apply on the columns that you are really interested in, so that the data consistency is always maintained. And this is something that was lacking big time in a DBMS. But in RDBMS, especially in SQL Server, it is very much possible for us to specify what criteria should be met for a record to be inserted into a table. Now, if any of those rules are violated, let's say the salary is negative, or the employee ID is duplicating, or the department ID doesn't exist in here, that record won't be inserted into the table, right? And these rules are called as integrity constraints. We have about 7 types of integrity constraints that we will be discussing in detail with examples one by one. Okay, let's start with the not null constraint. Now, what does a not null constraint help us achieve? Um, so certain columns in a table are mandatory columns and certain are optional columns. Okay, let's understand what I'm explaining here carefully. Okay, all right, so let's so when we're talking about mandatory columns and optional columns, let's take the example of an employee table. Now an employee can have a date of birth column. Let's say an employee table has a date of birth column. Now the date of birth column should be a mandatory column, isn't it? Because every employee is expected to have a date of birth, right? So mandatory column means we will have a value for each of the employee for that particular column. There can be another column which with the name date of resignation. Now, let's say we have a date of resignation column in the employee table. It will certainly have values for employees who have already quit the organization. For employees who are still working in the organization, obviously they'll not have a date of resignation, correct? Now, those columns are optional columns. That means some of them can have values and some of them might not have values. And the columns, the employees who have not yet resigned will have null values. And the employees who have resigned already will have a date there. Correct? So that means optional columns should be allowed to store null values. So basically columns that can store values are optional columns. Columns that are not allowed to store null values are mandatory columns. Now, how can we define which columns are mandatory and which columns are optional? By using the not null constraint, right? So the not null constraint helps us identify the columns that can hold null values and that cannot. And to show you with the help of an example, here I'm going to create a table called not null test, and I have an ID column here. ID is of type integer and name is of type varchar 100. Now, this is something that I'm adding newly. As you can see, I'm saying the ID column is not nullable. That means I am making this column a mandatory column. That means every row in the not null test table will definitely have a ID column, an ID value. Okay. The name, on the other hand, is optional. Now, I did not say that the name column is optional, correct? So how does it become nullable? Because by default, when we create a column, it is set to nullable. So unless and until we specify the not null constraint, a column is nullable. So the name by default is nullable, but ID, as I'm using a not null, is a not nullable column. That means it does not allow null values in it. So let's go ahead and create this table. Now, how can you see if a column is nullable or not? Again, we are going to use the metadata for this. If I use the Alt F1, you see that these two are the columns that we have, and this is the nullable property. This is where the nullable property can be identified. So for the ID column, as you can see, it says no. That means it does not allow nullable value. It doesn't allow null values, whereas the name allows null values. So it says yes. That means the column here, one of them is nullable, another is not nullable. Okay, so this is how we can create a table with mandatory columns and optional columns. The beautiful thing about constraints is not only establishing it. See, we just establish the rule while we are creating the table, isn't it? But the beautiful thing about this is further from here, SQL Server will ensure that any record that goes into the not null test is validated against this rule that we are applying now. So going forward, it is the responsibility of SQL Server, whoever inserts into this table, doesn't matter, but it's the responsibility of SQL Server to ensure that this rule is religiously abided to. Okay, so let's start with a few examples. Let me try to insert into the not null test table, into the ID and name column, a genuine value. Let's say 1 and Dinesh. 1 goes into the ID column, Dinesh goes into the name column. Okay, I'm just inserting one record, so I don't need union or union all here. Voila, one record affected. So I should see about one record in the not null test table. You see, one record has been inserted. Perfect. Now let me try to insert into the ID and name column null and John. Okay, if I try to insert null and John, you see it throws an error. It says cannot insert the value null into the column ID, and it says column does not allow nulls, and hence the insert fails. That means this record was not inserted. So anything, any row that we are trying to insert that violates the rule that we have applied will not be inserted into the table. So here it does not insert. So the tables will still continue to have one record only. Next up, if I try to insert again into the not null test table, but this time I provide a value for the ID, whereas for the name column I set it to null, you will notice that one row is affected. That means this record is well accepted. For the ID column, we have 3, and for the name column, we have null. Okay, so here if I, now that this record is inserted, if I show you, as you can notice, the ID 3 is inserted with the name as null. Moving on, there's another feature that is available wherein as the name column is optional, you can leave it out entirely from your insert. Okay, when I say you can leave it out, that means it doesn't have to, you don't have to necessarily provide a value for that. You can just insert and specify a value for the ID, in which case it will just insert into the ID column. The name column will be stored by default as null. See, one row affected, and here if I select, you'll find that the ID column has a null value, which is 4, has a null value. Now, did we insert this null? No, it was inserted automatically by SQL Server. All right, let's move on to the next constraint, which is the unique constraint. Now, what does the unique constraint help us achieve? I told you with an example here, the employee ID. If I want to keep it unique, I need to create a unique constraint. Basically, we are creating rules so that by mistake also no one is able to insert duplicate values, because obviously none of them will be inserted if they have duplicate values, unless and until we have this unique constraint specified. So here, if we specify the unique constraint, it will help us maintain unique data in a column. Now, how do we create a unique constraint? Here we say create table unique test. Okay, this is another table that I create. So for every constraint, to demonstrate you guys, I'm going to create one table each. Okay, and all of these is creating in which schema? In the DBO schema, right? Because I'm not specifying any schema name here. And I have again 2 columns in this table as well, ID and name. ID is of type integer, name is of type varchar, and the length is of 100 characters. And let's say I want to make the ID column unique. I just have to specify the unique keyword here. So that means I am creating a rule that says the ID column should never allow duplicate values. So here I create this table. All right. So the table is now created. And here, if I try to insert into the unique test table, ID and name, one and Dinesh, again, a legit record. So this should go in well. If I try to insert one and John again, okay, let's see what happens. You see, when I try to insert one and John again, it throws an error and it says violation of unique key constraint. And it also says cannot insert duplicate key in object unit test. The duplicate key value is 1. This is something that I love about SQL. The errors are so well explained that you don't have to scratch your head and be confused about what the error is about. Okay. Whereas in other programming languages, I worked on Java and .NET, and the error messages are quite misleading sometimes. Okay, not always, but sometimes they're quite misleading. But in SQL, it is very, very crisp and to the point. All right. So you know that you're trying to insert a duplicate key value, which is 1, into the ID column, whereas it does not allow duplicate values. So what do you have to do? You'll have to fix this. So you provide a value that is unique now. So which is 2. So we had 1 already. Now we are passing 2. And here I say insert into the unique test ID and name. Another property of the unique constraint is that you can have one null value per unique column. That means if I have a unique constraint on the ID column, that means we can have one null value per column. That means the ID column can have a null value, one null value only. So here, if I try to insert a null value with the name as John, it allows us to insert it. And here, if I select the data from the unique test table, you will notice that the ID column always has unique value, right? There are no repetitions. Irrespective of whoever is inserting it, they will never be able to insert duplicate values into this column. Okay. Now, null also, there's only one value that is allowed. So if I try to insert the null value again, it throws an error. You see, it says violation of unique key constraint, and it says the duplicate key value now is null, right? So the errors are very, very crisp and to the point. This is about a unique constraint. Let's talk about the primary key constraint next. All right, I have a question. It means null is equal to no value. No, null means nothing. Okay, I mean, you can say it is no value. Okay, but let's say if it is space or empty or 0, it is never the same. Okay, null, I mean, null means nothing. If you have a 0, if you have a space, or if it is empty, if it has a few spaces, let's say, then it is certainly not similar as null. It is not the same as null. All right. So yeah, null means no value. It means nothing. Okay, and that makes sense. All right. Okay. Let's talk about the primary key. Now, what is a primary key? The primary key constraint helps us uniquely identify each row in a table. Okay, like the employee ID. Okay, employee ID will always have unique values, right? I mean, if I know an employee, if I know the employee ID of a certain employee, I will definitely reach that particular employee. Under no circumstances can that employee lead me to 2 different rows. That means the employee ID helps me uniquely identify each row in a table, isn't it? And that is called as a primary key. A primary key is a column that helps us uniquely identifying a row in a table. Okay. Now, when we say uniquely identifies it, that means obviously it should be unique, correct? And at the same time, it should not have null values as well, because you cannot identify a row with a null value. So that means a primary key is a combination of unique and not null constraint. So here, let me go ahead and create this table to demonstrate you how primary keys work. So here I create a table called primary key test, and here I have 2 columns, ID and name. ID is of type integer, name is of type varchar, and I say ID is the primary key, right? Let me create this table. Now, how do we know which column is the primary key? We can do Alt F1 again. All right. And if I scroll to the bottom, you will notice that here there is a constraint that says primary key, and it is on which column? On the ID column. Okay. So the primary key constraint can be found at the bottom of your metadata. All right. So now the primary key test, as I said, is unique and not null at the same time, correct? So here, if you notice on the ID column, the nullable property is set to no. And did we specify a not null constraint here? No, we did not. So how did it set to not nullable? Because that's a default property of the primary key itself. It will by default set it to not nullable when you create a primary key on top of a column. Okay, and also at the same time ID should be unique as well. So if you scroll down here, you will find a unique index in here. We'll talk about indexes later, but the unique index will prevent any duplicate values to be inserted into the table. So by virtue of this primary key, this column has now become unique and not null at the same time. Okay, so here if I say insert into primary key test, I'm passing a value called with one and Dinesh. It should allow it to be inserted. It's a legit record. But if I try to insert the same value again, will it work? Provided that the primary key doesn't allow duplicate values, it's going to throw an error. But this time it says violation of primary key constraint. And the error is, it says cannot insert duplicate key in object of primary key test, and the duplicate key value is 1. Okay, and here if I try to change it to null, let's say let's test the other thing out. I mean, we also have the not null constraint created as well, right? So if I try to insert the null as well, it throws an error and says cannot insert the value null into column ID, and it says the column does not allow null, and hence the insert fails. Okay, so the only way I can insert this record is by having a not null and a unique value for the ID column. And now it works perfectly. So again, at any point in time, if you look at the primary key test table's ID column, you'll only find unique values and not null values. All right, so let's move ahead and talk about the foreign key next. Now, the foreign key is something that we have also discussed earlier. It's just that now we just name it. So earlier, if you remember, I mentioned the fact that we are going to establish a rule on the department ID column that will mention the fact that this references the department ID column in the department table, correct? So that means this now becomes, so this definitely is a primary key, right? Because the department ID helps us uniquely identify each department in the table. So this becomes a primary key, and this becomes a foreign key. So any column in other tables that is dependent on the primary key of our table is referred to as a foreign key, right? So in here, let's create a table called foreign key test. Now what I'm going to do here is I'm going to have a ID column, integer, and a date of birth. Okay, this time I'm using date time data type. And I say the ID is a foreign key that references the primary key test table's ID column. You remember this table ID column had a primary key that we just created a little while ago, right? So foreign keys can only reference the primary key of another table. So here we specify the table name and in the bracket the column name. So in the other table we had the ID and the name, and in this table we will have the ID and the date of birth. Right? So that means all the values that can be stored in the ID column should be present in the parent table. That is the primary key test table. So the table with the primary key is called as the parent table, and the table with the foreign key is called as the child table. Okay, so let's go ahead and create this table. Table is created. Now if I do Alt F1, you will notice that there's a foreign key constraint created on the ID column, and it references which table. This mentions the database name, the schema name, the table name, and the column name as well. Okay. Now, if I had a question someone asked earlier, can we reference other schemas across, can we reference tables across schemas? You certainly can. Let's say the foreign key test table is in the DBO schema, but the primary key test table is in the food schema. So you just have to say references food.primary key test. Now it throws an error because we don't have it yet, but let's say I make it food.employee, it should work. Okay. Here it shows an error because we don't have the ID column. So you see, it throws an error because we don't have a primary key on the employee ID. But yeah, this is how you can create your references across schemas, obviously inside the same database. All right. So you can see the foreign keys all at the bottom of your table. Now let's see if, again, we have created a rule, right? But it's the responsibility of the SQL Server to abide to that rule. So here I'm going to say insert into the foreign key test. I'm providing ID and date of birth. So the ID is 1 and the date of birth is 2019, 10th of January 2019. All right. So here, let me insert it. Works perfectly fine. One reflected. Now, if I show you the primary key, you will notice that we have 1 and 2, right? So that means in the foreign key table, we will only be allowed to have IDs of 1 and 2, right? Let's say I insert a value for 5, okay? And I guess someone was also asking me earlier, how do we provide a value for the date? I don't know if it was from this batch, but yeah, you can provide a value for a date also in the same format that SQL accepts it. SQL accepts it in this is January month, and this is the date, okay? And this is my ID. So the ID 5 is not existing on the primary key test table. Will it be allowed to be inserted in the foreign key test table? Obviously not. You see, it says the insert statement conflicted with the foreign key constraint, okay? And the conflict, where did it occur? The conflict occurred in the primary key test table's ID column. That means the ID 5 was not found in the ID column of the primary key test table. Okay, so here, if I check at any point in time, if I check my foreign key test table, I'll find values that are there in the primary key test. One other property of the foreign key is that you can insert as many null records as you want. For example, here, I can insert a null value into my foreign key column. Okay, and that's the default value. See, I inserted about 3 records now with null. So it allows, okay, that's the default property of a foreign key constraint. It allows null values into your foreign key column. You can certainly prevent it by adding a not null constraint, but it's up to you. Okay, if you want to not allow null values into your foreign key, you can use the not null before the foreign key. If not, you can just let it be and it will allow null values into your column. Okay, so that is about a foreign key constraint. Okay, it just helps us establish relationships between the table. We are now talking about relational databases, and foreign key and primary key are the ones that help us build relationships inside the databases. Okay, but let's move forward and talk about the check constraint. If you remember, I gave you another example earlier wherein I said we are definitely not going to have salaries in negative. Am I correct? And that doesn't make sense to have salaries in negative values. So here we can apply a check constraint. So check constraint helps us in checking for the value against a condition. So here to start off with, let's say I have a table wherein I want to store only the data related to senior citizens, right? So if I want to store data related to senior citizens, obviously I need to have all the records that I will have should have an age of greater than 60, isn't it? Greater than equal to 60, because only individuals on and above that age are qualified as senior citizens. So I can say I have these 2 columns, ID as integer, age as integer as well, and I say check and make sure that the age is greater than equal to 60. So this is the column name and this is the condition. So I say greater than equal to 60, and if I create this table, the table is now created, and if I do Alt F1, you will notice at the end here we have the check on column age, and the age should be greater than equal to 60. So if I try to insert a record with age as 60, it works. if I try to add a record with age as 59, which is obviously not fulfilling the condition, it throws an error. It says the insert statement conflicted with the check constraint. Now, if I wanted to apply the rule for the salary column, I should have said salary is greater than 0. That means it should have only allowed positive values for the salary column. So at any point in time, if I see the check test table, I will find the age value to be always greater than or equal to 60. Again, we are applying the rule, but SQL Server ensures that it checks for all the constraints. Now, if I want to create a check on a varchar column, I can certainly do that too, right? So I'm creating another table, and here I have name and a flag, right? And I say I'm putting a check on the flag column now, and I'm saying it should only accept yes or no. Okay, no other values are allowed. So let's say I create this table, okay, and here if I try to insert a record with the value to the flag column as no, it should obviously work, as you can see. But if I try to insert another record with the name as John and flag is Y, okay, we have specified yes here. So that means only yes and no in the same format are allowed. But if I try to pass Y, it will not allow it. You see, it says insert statement conflicted with the check constraint. But if I pass yes in here, it should now work. You see, one row affected. All right, let's talk about the last constraint that we have, which is called as the default constraint. Now, what does the default constraint help us do? If you remember, we had a set of mandatory columns and optional columns that we discussed about earlier, correct? So in order for us to, and we can choose to exclude the optional columns while we were inserting. Let me show you again so that you can recall it well enough. So here, if you see, we were able to exclude the default, the optional column altogether. And in which case, the table SQL Server used to store null for that particular record in the name column. The default constraint will ensure that instead of the null, when we exclude the column, when we don't provide a value for that column specifically, then the null value, instead of the null values, the default value will be stored. Okay, so here, how do we create it? Just creating a new table called default as 2 columns, ID as name, ID as integer, name as a varchar, and I say the name column add a default value of no name provided. Okay, so here I go ahead and create this table. Commands completed successfully, and here I insert a record 1 and Dinesh. It works well, right? So if I check the default test table, I should have 1 and Dinesh. If I insert into ID and name 2 and null, let's say, and insert, one row affected again, and here, if I again check the default test, you will find 2 and null. So until and unless I specify a value, I specify the column and specify a value, irrespective if it is a null or a proper value, it will be inserted. Okay, it will be inserted as it is. But the moment I exclude it, the moment I leave out that column and only pass the mandatory value, this is where, if I query it, this is where I'll find the name column set to the default value, which is no name provided, right? So the no name provided, the default value is only applicable when we...
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
When we do not provide a value for the name column explicitly. Okay, so next up, let's talk about the identity constraint. Now, the identity constraint, let's say we have an employee table, a product table, and multiple other tables. And what we want to do is we just want to insert the data into that table, but we don't want to take the headache of generating the IDs, right? Because for every employee that we insert, for every department that we insert, we need a new ID, correct? And that ID should be just the next value of whatever value we already have in the table, right? So to let SQL Server generate the IDs for us, we can use the identity constraint. Okay, the identity constraint helps us in generating identity values for each row of the table. So here I can create a table, identity test, and I can provide a value. I have two columns here, ID and name. ID is of type integer, name is of type varchar, and the ID column is of, what I'm saying is I set it to identity 1, 1. Okay, now the 1, 1, one of them is the seed value, another is the increment value. Now the seed value means the first row that is inserted will have an ID of 1. That is the seed, basically from where it origins. How does it start? That is 1. And furthermore, the increments, that means the subsequent records that will be inserted with this value incremented over the seed value. That means the second value will be 1 plus 1, which is 2. Third record will be 2 plus 1, 3. Fourth will be 3 plus 1, 4, and so on. Okay, so let's get this table created perfectly. Perfectly fine. Now, if I do Alt F1 on this table, you can find the identity constraint right below the columns. Okay, you won't find this one at the bottom. Unlike the other constraints, you'll find it here. So if as you can notice, the identity column has a seed value of 1 and increment value of 1. So if I try to insert two records, let's say Dinesh and John, and I pass the ID value, let's say 1 and 2 on my own, let's see what happens. If I try to insert these two records, it throws an error saying cannot insert explicit value for identity column in table identity. One thing that you need to remember is in normal circumstances, you cannot insert data into an identity column manually. Okay, so what as this again, we have just created the rule. It is up to SQL Server to generate IDs for us, right? So we are going to let SQL Server generate the IDs for us, and if I execute it, it says two records affected. And if I show you the table now, you will see that Dinesh and John has been inserted, and SQL Server has automatically generated the ID values for us. Brilliant, isn't it? Now, what if you definitely want to insert a value into your identity column? Okay, what can you do to be able to insert these value? In such cases, you can set the identity insert option on the table. This is the table name, by the way, on, and then insert into the identity test with whatever value you want. Let's say I insert it as 85 and the name is Leo. And then right after, you need to set it to off. So when we say set identity insert option to on, that means I'm telling SQL Server, hey, please do not generate the identity values anymore automatically from your end. I am going to pass the identity value for this table explicitly in my query. Okay, and we need to ensure it's always a good practice to turn it off in the same query itself. Why? Because there will be a lot of other users using the system, right? And they will be under the assumption that SQL Server is going to generate the ID column for us, right? The value for the ID column will be auto-generated. But if it is turned to on, SQL Server will not generate the ID values anymore. So we need to turn it to on just so that we can insert it explicitly, and need to turn it off right after. So here, let me execute this, and it says one row affected. So now I should be able to see the record inserted. So I can see 85 and Leo is inserted. Now, if I, let's say, want to insert these two records again. So what we have until now, we have 1, 2, and 85, right? Let's say I insert these two records again. Okay, two rows affected. What do you think would be the IDs that is generated? It will generate IDs which is 86 and 87. Now, why is that? Because when we have a value inserted explicitly that is greater than the earlier seed value. So the earlier seed value was 2 and we inserted 85. In that case, the seed value will be updated to the new higher value, which is 85. So the subsequent records are generated using that particular seed value. So it becomes 86 and 87. So now what is the seed value? 87, correct? So the next record should be 88, 89, and so on. But now let's say I again insert this record, but this time with a value that is lower. Let's say I insert 35. Okay, and I again turn it on and insert the record with ID 35 and turn it off. Says one row affected. And here, if I show you the identity test, we had it until 87. Now I've inserted 35. If I insert into the identity test table again, two records affected, and if I show to you, it continues to have the same seed value. It continues to use the same seed value. Why is that? Because only when the inserted value is greater than the seed value, that is, earlier in our case, we had seed value as 2, but we inserted 85, right? So it became a higher value. So in that case, the seed value will be changed. But when the current seed value, which was 87, is higher than the value that we are inserting, in that case, the seed value won't be updated. So it will continue to use the seed value as 87 for the next set of records that should be inserted. So now the seed value is 89. So the subsequent records will be 90, 91, 92, unless we insert specifically a value which is significantly higher, in fact, higher than 89. Only then the seed value will be updated. What happens when I turn identity insert on while some other user is trying to insert record before I turn it off? What happens in this case? Let's try. So let's say you have turned it to on and you are trying to insert a record. Let's say 105. Okay, you're trying to insert a record. One record affected, that means it allowed you to insert it, right? We haven't turned it off yet. Let's say some other user is trying to insert 2 records, and it is under the assumption that the ID values will be automatically generated. See, this is the error that they'll get. Explicit value must be specified for identity column because it is set to on, or you need to turn it off first. Is it? It's set to on. So yeah, it's not a good practice because their query will start failing. So you need to turn it to off right after, and then now you'll be allowed insert again. All right, that being said and done, we are done with all the constraints now. Let's play a little bit around the data retrieval part, right? That means how can we modify the data that we are trying to extract? How can we limit or control that the data that we are extracting from the tables? That is important, right? Because you'll be asked to build a lot of reports, you'll be asked to extract a lot of metrics. So in that case, they'll say, okay, I need only the data for India. I need only for the for a specific set of employees. So in that case, what do? How do you filter it? There are two things, right? One is, how do I select only a specific set of columns? Because when I run a select star from employee, I usually see all the columns from the table. Now, what can I do to restrict the columns that I'm seeing? Okay, I can use the select condition, the select statement to filter the columns and see only the specific columns that I want to see, because the star here, it represents all columns in the table. Okay, but if I don't want to see all the columns, I can always get rid of the star and instead replace it with the specific columns that I want to see. So I want to see, let's say, the first name, last name, and address. So I can only specify these 3 columns. Now, what is the EMP that you see here? EMP dot. EMP is a table alias name. It's like a short name for the employee table for this particular query. Okay, for this particular query, the short form of the employee table is EMP. Okay, we will discuss we'll see the relevance of this in the queries where we use more than one table. Okay, that is when you will find the advantage of the alias names. But for now, let's just think of this as a short name for the employee table. Okay, so here I'm saying fetch the first name from the EMP, which is the employee table, last name from the EMP employee table, address from the EMP, as address of employee. So what does as mean here? This is a column alias. That means if I don't want to see the address column as it is, like it shows in here, you see, it shows as address. I want to see it as address of employee. So I can use that as an alias. So this is again an alternate name for this column. So the data will be selected from the address column, but will be shown as address of employee. So here, if I run the select, you'll see that it shows only 3 columns: employee first name, last name, and you see the third column here, it says address of employee. Instead of just saying address, it extracts the data from the address column, but it says the column is called as address of employee. So this is how we can use the select statement to specifically see only a set of columns instead of seeing all the columns. Okay, so let me get this uncommented and let me keep all of these 3 commented. So here, if I run the select again, you will see it shows all the data. Now, what if I want to restrict the rows? I don't want to see all the records. And most of the time you will never, you will not need to see all the data here. Okay, so here now let's say I want to see the details only for employee ID 5. Okay, so I should say where employee ID is equal to 5. So the select statement helps us filter the row columns, whereas the where condition, the where clause helps us restrict or filter the rows that are displayed. Okay, so here if I run the select now, it'll show me the details only for this particular employee ID, which is 5. If I want to similarly filter on one specific name, let's say, so I can say where employee first name. So here, if I say where employee first name is equal to John, it'll show me all the employees with first name as John. So in this case, it satisfies these 3 records satisfy the condition. So it shows all these 3 records here. Similarly, if I want to filter on multiple values, okay, we use the in clause. The in clause helps us filter on multiple values in a single query. Okay, so here if I say in 1, 2, and 5, it'll give me all the details of ID 1, 2, and 5. The same applies for the varchar fields as well. I can say in John, Dinesh. So let's say I want to see the details of John and Dinesh both. Then I just put it in a filter saying in John and Dinesh, and this should give me the data related to John and Dinesh. Okay. We can also use arithmetic operators like greater than, less than, and everything. So let's say I want to see everything, all the records with employee ID greater than equal to 3. In this case, it should give me all the records which is greater than equal to 3, for which the employee ID is greater than equal to 3, which is these 4. Which is these 6 records. Similarly, I can do a less than equal to 3 as well, which will give me all the records which have IDs less than equal to 3, which is 1, 2, and 3, and its respective details. Again, if I want to exclude a record, I can use a not equal to, right? So not this symbol exclamation equal to and less than greater than symbols are not equal to operators in SQL Server. Okay, so here I can use this, and what you will notice is it will show you, it will display you all the records except for the ID 3. So it shows 1, 2, 4, 5, 6, 7, and 8. Okay. Similarly, if I can also use this other operator, this will yield the same result as earlier. You see, it shows us 1, 2, and then 4, 5, 6, 7, and 8, and its respective details. Okay. Now, until here, we have used only a single condition, right? What if we want to use multiple conditions? So if I want to use multiple conditions in my query, I can use logical operators for that to separate them, like and, or, right? So if I say and, that means the records will only be returned if both these conditions are true. That means if employee ID is greater than 3 and only when the address is India, then only the records will be returned. So both the conditions should be true for the record to be shown in the result set. So here, if I execute this, you see it shows us 5 and 6 and the details of it. So 5 and 6 are both greater than 3 and the address is India. So that's the reason both these records are returned. Whereas if we use the conditions with the or in between, that means it will return us the records if at least one of these conditions is true. I mean, it's very simple English, guys. Okay, there's no complications in this whatsoever. Whenever you say and, that means you really want both your conditions to be satisfied, right? But when you say or, like get me an ice cream of strawberry or vanilla, right? So in that case, you are okay with either of them. Okay, but when you say I need an ice cream which has a strawberry and vanilla in it, that means you need both of those flavors to be in that ice cream. I mean, that would be weird because you never get any ice cream of that flavor. But yeah, I mean, just hypothetically speaking here, right? So, and basically means both the conditions should be true, or means at least if one of the condition is true, the record should be returned. So if I execute this, you will notice that it returns me all these records, right? Now, if you notice 1, 3, and 5 are certainly not greater than 5. 1, 3, and 5 are not greater than 5, but it still returns these records. Why? Because the address is India, and the address is India means one of the condition is satisfied. So these records are returned. This record, for example, 6 qualifies both the conditions, so well and good, right? But 7 and 8 again are the address is US, but they're still returned. Why? Because the employee ID greater than 5 condition is satisfied. Both of these have employee ID greater than 5. So at least if one of these conditions satisfy, then the records are returned. Okay. Now, if you want to exclude a set of records, right? We have seen how to exclude one record. If I want to exclude a set of records, I can use the not in condition. The not in condition, not will basically reverse that condition. So employee ID in 157 would have given us only 157. The not will give us the opposite of that. That means it will exclude these records. So here, if I run this, it'll give me everything except 157. So you see, we don't get 1, we get 2, 3, 4, then there is no 5, we get 6, no 7, and we get 8. So the not is the opposite of whatever condition we are specifying here. Now, if I want, we can also use a between operator to filter based on a range. Okay, but this is mostly applicable for integer values. Okay, integer columns, wherein we can specify a upper range and a lower range and an upper range. But while retrieving the data, it will include both of them as well. So when I say between 3 and 6, it'll get us 3 and 6 both inclusive, and everything in between them. So here, if I execute, you see I get 3, 4, 5, and 6 and their respective details. Okay. Now the distinct clause helps us in retrieving only the distinct set of values from the specified columns. So let's say I select data from the address column in the employee table. As you can see here, we have multiple same addresses, right? There's India, 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 India. We have US and US. What if I want to see only the unique addresses? That is when I can apply the distinct condition here, the distinct clause here, and this will get me only the distinct addresses out of the entire table. Now, if I want to add, let's say, another condition, another column here, first name, and execute this, what you will notice is, you will notice that now we have again India appearing 4 times. Why? Because as the address itself, considering only the address, it was duplicated. But if you consider the address with the first name, it certainly gives different values, right? It is distinct records. So the distinct is usually applied on all the columns specified in the select. Now, if you notice here for US, we have only one record, which is John. Observe this. Okay, let me add the employee last name here and let me execute this. So you will notice that we have 3 records for John, but we were getting only one because the distinct was earlier applied on address and the first name only. But when we add the last name as well, this combination, this last name makes these records unique. So here, the distinct is now applied on the address, first name, and last name together. Just for viewing, can we calculate one column which has calculated values, not actually in the database table, but only in the display? Yes, we can. Yes, we can. Let's say you want to get the salary converted to INR maybe. Okay, let's say the salary is in dollars and we want to convert it to INR. So salary is at 73 rupees, 73 Indian rupees. $1 is 73 Indian rupees. So if I want to see the salary as salary in INR, I just say salary into 73. This is the salary column into 73 as salary in Indian rupees. And this would give me, so these are the salaries in Indian rupees. And if I want the salary in USD, I would say salary as salary USD. Okay, so this will give me, this is the salary in USD and this is the corresponding salary in Indian rupees. Simple. So yeah, you can calculate it like this. I'm just going to move over here. All right, okay. Next is the top clause. Now, what does the top clause help us with? The top clause in a query, so we can have tables with millions of records, right? But let's say we want a sample set of records. I want a sample of, let's say, only 5 records to see the data. I want to see the sample data, like how the data is stored in the table. That is when I can use the top clause. So here I would say select. Earlier we used to say select star, right? But if I want to see the top 5 records, I would say select top 5 star. That means all the columns from employee as EMP. And this would give me all the 5 records from only the top 5 records from the employee table. If I say select top 2 star, it will give me only the first 2 records from the employee table. Now, what records would it give you? The first 2 records stored in the table. Okay, it will not be in any specific order or anything. It will be from the top 2 records in the table. That means the first 2 records that are stored in the table. Okay, moving on to another very interesting operator, which is the like operator. Now, sometimes, okay, while we are working on databases, we might be asked to retrieve data based on certain patterns. Like we might be said, hey, can you get all the employees whose name contains A in it, or whose name ends with H, whose name begins with S, right? So we can have requirements like this wherein we might have to match patterns. That is where the like operator comes in handy. The like operator has 2 wildcard characters. One is the percentile, another is the underscore. The percentile refers to 0 to n number of alphanumeric characters, whereas the underscore refers to only one alphanumeric character. So underscore is for one single character, fixed, whereas percentile can be treated dynamically, can be considered as a dynamic wildcard, wherein it can represent 0 to n number of alphanumeric characters. So here, let's say I select star from employee, it should definitely give us all the data. But if I say where employee first name like percentile O percentile, that means it will filter all the records which contains O in it. That means it can start with any number of alphanumeric characters, 0 to n, and it can end with any number of alphanumeric characters after O, right? That means O can either be in the beginning, considering the first percentile represents 0 characters. It can be in between the string, considering the percentile has n number of characters and this percentile represents n number of characters. It can be at the end of the string, considering the last percentile represents 0 characters. Okay, so if I execute this, it will give us all the records which has first name with a O in it, with an O in it. So you can see we get John, Santosh, John, and John. So all of these employees have O in their name. All right. If I say, let's change this condition a little bit, and I say where employee first name like percentile H. Now, what does this mean? This means percentile H means it will get us all the records which has a first name like, and then it can have 0 to n number of characters in the beginning of the string, but it should end with H, because after H there is no pattern. So that means H should be the last character in the name. That's it. And if I execute this, we get Dinesh and Santosh. You see, in both these cases, H is the last character in the name. If I say where employee first name like D percentile, that means it should begin with the D and then can have 0 to n number of characters after D. So if I execute this, you will notice that it gets me the record with first name as Dinesh, right? Because Dinesh is the only employee whose name starts with a D. And then it can have as many characters as necessary. Now let's use the underscore as well with a combination of the percentile. So here if I say employee first name like percentile S underscore, what does this mean? Here I'm trying to ask SQL Server for all the records that has first name which can have 0 to n number of characters to start off with, then have a S, But after S, there should only be one character. That means S should be the last but one character in the name. Okay, but after S, there should be only one character at the end. And if I execute this, I get Dinesh and Santosh. And if you see in both these names, S is the last but first name in the string, isn't it? We have H at the end. So the underscore represents one character. Percentile can be any number of characters, but S should be right before the last character, which should be the last but one character. Now, if I say where employee first name like underscore 0%, what does this mean? Underscore 0% means it should start with any alphanumeric character. It can start with any alphanumeric character, then have a O. That means O should be the second character in the name. And then a percentile. This percentile means there can be any number of characters after O. So it can start with any character, then have a O, and then can have any number of characters after O. So O should basically be the second character in the name. You see here, on all these records, we have O as the second character. All right, so okay, we have seen only integer and varchar and date time, right? Let's see a bit more of the numerical data types. So in numerical data types, so as far as the numerical data types are concerned, we have mostly used int, and this will mostly satisfy all the requirements that you will have on numbers going forward, because it has a range of about negative 10 digits to a positive 10 digits, which is probably a very huge number and should be accommodating most of your use cases. But let's say you have bigger values, probably more than these, right, which is a positive 10 digits to a negative 10 digits. If you have something beyond this range, then you go for a big int. But big int is a more space consuming data type, so be very choosy about which data type you use. Most of them should be okay with the integer data type, because obviously you're not going to store numbers which are greater than 10 digits. Most of the time it will be inside 10 digits, so you can go for an integer. But if you feel no, I need even a bigger range or a bigger data type, go with a big int. Small int has an even smaller range, which is from -32768 to +32767. Okay, so yeah, this is this negative that you see here is a typo that needs correction. But yeah, it's from -32768 to +32767. Then we have tiny int, which is even lesser. It cannot accommodate negative values. It can only have positive values, which is until 255. So when you have tables which stores the states in the US, counties in the US, or maybe the countries in the world, right? In that case, you can go with the tiny int, because they're obviously not going to go beyond 255, right? So anything that you feel is can be used inside the 255 IDs or inside the 255 values, go for a tiny int. Now we also have a decimal data type. In a decimal data type, we have two values here. One is the size. The first one is the size. The second one is the decimal places. So here, let's say I said decimal of 7,3. That means the total number of digits in my value should be 7. So 1, 2, 3, 4, 5, 6, 7. So 7 values in my in the entire number, but I can have 3 values after my decimal. So
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
like this. So 4 will be in front and 3 will be after. So if I, let's say, make this 5,3, that means I should have 3 digits after the decimal, which is here, and 5 should be the total number of digits. So that leaves us with 2 digits before the decimal. Simple. So decimal accepts 2 values. I mean, you can specify the size of your number and the number of digits that you need and the number of decimal places that you want. All right. Okay. Next, talking about the character data types, we have char, wherein we can specify the size, but it can hold up to 255 characters only. But it is not an intelligent data type. So what do I mean when I say it's not an intelligent data type? If I say char of 100, right, that means irrespective of any number of characters that I store into that field, I can, let's say I store only 5 characters into that field, it will still take up space worth of 100 characters. Okay, so use the char data type only when you know the specific length of your values. For example, the currency code. Currency code is always 3 digits, isn't it? INR, USD, EUR for euro, right? So it is always 3 characters. So in that case, use a character data type for the currency code column and char of 3. When we are using country code is usually 2 characters, right? So use char of 2 there. When you know the exact length of the characters that you're going to store, then go with the character data type, solely because of the reason that it usually takes up space. It takes up that equivalent amount of space irrespective whatever number of characters you store. So to make the full to utilize it to the complete extent, we will store the same number of characters as the size that we are specifying, so that there is no unnecessary usage of the space. Varchar, on the other hand, can store up to 8,000 characters. Okay, again, this is a typo. I'm sorry for that. 8,000 characters. But this is more of an intelligent data type. So let's say I define it as 8,000 characters, but let's say I store only 5 characters in it. That means it will take up space only worth of 5 characters. That's it. It will not store the entire length and the space. Text is more of a free text field. Let's say you have on your user interface, you have given a field for product feedback or for comments from the users. Obviously, they can write how much ever they want, right? In that case, we can use the text data type. But the text data type again is not a very usable data type. There's a lot of limitations. So SQL Server is trying to get rid of it, maybe in the next version for sure. They have already started preparing, and they've already rolled out an intimation saying that if you are using text data type a lot in your databases, which I'm pretty sure not most of the organizations would be using, then they're recommending to move to a different data type or stay prepared to move to a different data type, because I'm certain they might give or increase the space or the amount of number of characters that can be stored in a varchar. Also, we have another data type called the nvarchar. Okay, the nvarchar is used when we have special symbols, like let's say we have percentile, hash, dollars, ampersand. Whenever we have special symbols that we want to store in a column, we go with the nvarchar data type. So special symbols, alphabets and numbers, nvarchar. Only alphabets and numbers, varchar. Okay. Coming to the date time data types, the date data type always stores it in this format: YY, MM, and DD. Always, I would recommend you storing the data in this specific format. Let SQL Server store it in whichever format it wants, but then we can always convert it to any format that we desire to while we are retrieving the data. Let it store in whichever format it wants, but while we retrieve it, we will retrieve it only in the format that we want to see it. Okay. I'll probably show you when we are talking about the convert function. Okay. The time is usually stored in hours, minutes, and seconds. Year can be stored as an integer as well. Okay, because year will only have 4 digits, right? So we can use integer data type as well for the year. But then there are 2 more important datetime functions that we have. One is the datetime, other is datetime 2. Now the datetime can store the precision up to seconds. But with datetime 2, it will store up to milliseconds as well. Now, where do you use datetime 2? Mostly in stock market related databases. Okay. So in those kind of databases, every millisecond counts, right? So whenever you need a precision of 2 milliseconds, go with the datetime 2 data type. If you are not bothered about the milliseconds, go with date type. So these are the different data types available with SQL Server for now. So we have discussed about all the constraints. I mean, here only 4 of them are specified, but we discussed about all the 7 that are existing. So that's good. Let's move on straight to the quiz because we have finished everything else. Again, I would request you guys to put your answers on the chat window. I'll request all of you to participate because, I mean, I'm not going to score you guys here, but at least you can see where you stand. And probably if you have any questions that might arise from the quiz, I'll be glad to answer them. Okay, so at least this can be a self retrospection section. All right. The first question is which of these is the syntax to create a database with the name Sparta? So which of these options commands will help you create a database with the name Sparta? Whoa, a lot of answers. Nice. I'm so glad all of you are participating. Good job. Okay, I'm going to open up the answer in 3, 2, 1, and here we go. So the correct answer is B, and all of you have I mean, told it correctly. So that's a great start. Thank you so much for the participation. Moving on, what is the purpose of the where clause in MS SQL? Okay, ignore the MySQL, it's MS SQL. What do we use the where clause for? Okay, right. I see a lot of answers. Maybe I'll wait for a few more seconds before I open it up. Okay, opening in 3, 2, 1, and here we go. So the correct answer is filtering out unwanted rows from the result sets. The where clause, if you remember, helps us in filtering the rows, isn't it? Filtering out unwanted or filtering in the wanted records is one and the same. Filtering out unwanted columns is by using the select command. So we use select and then specify the columns that we want to see. Filtering out unwanted columns and rows is something that the where clause doesn't entertain. It is only related to rows. On to the last question. For which of these is the syntax to select all customers whose name starts with SA %? A part of the answer is already there in the question itself. So yeah, this one should be easy. You guys seem to make everything a cakewalk. I mean, you're good at a lot of things. Nice. You're good at this quiz as well. Nice. Anyways, okay. Wait for a few more seconds. I already have a lot of responses. That's good. That's good. Keep them coming. All right. So opening the answer in 3, 2, 1, and here we go. So the correct answer is B. Select star from customers when name like SA %. So whenever we want to match a specific pattern, we go with the like operator. Like the in is usually used for multiple values filtering. Is something that we'll discuss at a later point in time. This is mostly to do with null values, and we don't use is and in together in SQL. Okay. Okay, so let's talk about joins in detail. Now, what are joins and why do we need it in the context of SQL Server? So here, let me take you back to the examples that we have been discussing a lot. This is the employee and the department table. Now, let's say we are asked to fetch the employee details along with the department name of the employee and the establishment date or the established date of the department. So where do we have the department name and the established date? In the department table, correct? So we have the employee details in here and the department details in here, right? So if I want to get the department details along with the employee details, I need to somehow combine both these tables, the employee and the department table. Now, obviously, if I want to combine them, I need to combine them based on something that is common across both these tables. So in our case, the common column that we have that we can use to compare or combine these two tables is the department ID column, isn't it? The department ID column is common across both these tables that will help us combine both of these tables. Okay, now this concept of combining tables has a technical name that is referred to as joins. Okay, joins plays a crucial role, especially in RDBMS, because we have a lot of relational data that we have. And as they are related using primary key and foreign key, the only way we can consolidate data from across two or more tables is by using joins, so that we can join both these tables based on a certain column, right? So what we would get the details of Dinesh, and alongside the department name of Dinesh, which is software, and the established date, which is 1/1/2010. For Leo, let's say this employee, we will have all the employee details, and then the department name should be department ID 2. So department name should be admin, established date should be 1st of January 2012. Okay, so joins are basically of three types. Okay, and why we have this one here. Okay. Joins are of three types. I mean, if you read more and more articles on the internet, you will find it a lot confusing. But I mean, overall, we have only three types of joins in SQL Server. I mean, you might find articles that says talks about other fancy joins, but those are nothing. Those are derived out of either of these type of joins. Okay, so the first type of join that we have is the inner join, the second is the outer join, and the third is the cross join. Okay, so we have three types of join: inner, outer, and cross. The outer is further subdivided into three types, which is a left outer join or a left join, the right outer join or the right join, and the full outer join or the full join. Okay, so we have three types of outer join. So inner join, outer join, and cross join. These are the only three types of joins that we have. Outer join is further subdivided into three: left outer or left. That means the outer keyword is optional here. You can choose to use it or ignore it. I mean, it'll work exactly the same. So left join, right join, and full join. Now let's understand each of these examples a little more. Let's understand each of these joins with the help of examples. Okay, so here to begin with, what I'm going to do is, we already have an employee table, correct? I want to create another table called the employee date of birth. Okay, now what I'm not going to do here is, I'm not going to create a foreign key on the employee ID column here, because as I want to demonstrate the different types of joins, I want to just make sure that I have a variety of values across both the tables. That means some values are present in that, some values are which are not present in this table, and some values are present in this table, the date of birth, which are not present in the employee table, and some common values. Okay, so we have all the three scenarios covered. So I'm going to create an employee table, employee date of birth table, very simple table, which will have only two columns: employee ID of data type int and date of birth of date time 2, right? As we discussed yesterday, date time 2 is of millisecond precision. So we have the two columns, employee ID and date of birth. So for each of the employees, we will have one date of birth, obviously, right? So let's go ahead and create this table. And as always recommended, let's check for the database name if it is correct. So this is the database that we have been using until now. So let's go ahead and create this table. So the table is created. It says commands completed successfully. And now let's insert some random values into it. For all the employee date of birth, for all the employee IDs that we have, let's insert some random values into it. So here I say insert into date of birth for the employee ID column and the date of birth column. The values that I'm providing is, as you can notice, I have 1, 2. I have then left out 3 and 4. Then I have 5, 6, 7, 8, 9, and 10. So I've left out 3 and 4 in here. That means employee ID 3 and 4 doesn't have a date of birth configured. In fact, I'm not inserting the date of birth for 3 and 4 employee ID. But again, if I compare it with the employee table has 8 employees, 1 until 8, correct? So here, what I'm doing is, I'm also adding 2 more rows with ID 9 and 10. Okay, so I have 3 and 4 missing from here, and then I have 9 and 10 extra in the date of birth table. Okay, now you also must be seeing a get date minus 7,000, get date minus 7,300, get date minus 7,900. Now, what is the get date here? Get date is nothing but a function. Okay, the get date will give us the current date and time, which is 1st of August 2021 at 8:09 p.m. in the evening IST. So when I do minus 7,000, that means it will subtract 7,000 days from today. So today is 1st of August 2021 minus 7,000 days. Okay, so it'll give us a random date. Now I'm just using the same trick, same approach for all the rest of the values, and generating random date of births. Okay, just so that I can fill in the values. So I'm providing the IDs in the beginning and the date of birth for all the employees, and knowingly I have left out 3 and 4 so that we can see the different types of joins, and also added 9 and 10 as extra. So let's go ahead and insert these records. All right, so 8 rows are inserted. And now if I show you both these tables, let's say I show you the date of birth and the employee table, this is what you will notice. So the date of birth is what we inserted just now. As you can see, it has generated 1, 2, and then 3, 4 has been knowingly missed. That's okay. 5, 6, 7, 8, 9, and 10. And the date of birth that's generated by using the above formula. Right, we have the formula, right? We use the function get date, and we subtracted random numbers from it to generate random date of birth for the employees, just to fill in the data. Now we also have the employee table, wherein we have the employee ID and the rest of the details. Now, if you see for the employee ID in the employee table, we have only 8 records, right? That is 1 till 8. Whereas in here, we have still 8 records, but we have 9 and 10 extra, and 3 and 4 are missing. Simple. So keeping this structure and this data in mind, let's get into understanding inner join in depth, right? So the inner join returns the common records across both these tables. So when I say common records, what do I mean? So when I do an inner join between both these tables using the department ID, it will only return me the common departments across both these tables, right? So in this example here that we discussed, for the employee and the employee date of birth, ideally it should return me the details of 1, 2, right? And then 5, 6, 7, 8. Isn't it? Because 3 and 4 are not present in this employee date of birth table, and 8, 9 and 10 are not present in here. So all that we are going to get are the common the details for the common employee IDs, which is 1, 2, 5, 6, 7, and 8, because these are the only IDs that are common across both the tables. So let's see how we build an inner join. Okay, so to build an inner join, we say, so we have been always writing select star from employee as EMP, right? And it gives us all the data from the employee table. Fantastic. Now, all that we have to do, let's say I have to join some other table. All that I have to do is I need to say inner join, right? Because we're talking about the inner join now. Inner join with the date of birth table as EDOB. All right. So I'm joining my employee table with the employee date of birth using an inner join. Okay, the type of join matters. Okay, we'll talk about when we speak about the others, you will understand the difference. But for now, we are just using the inner join. And then, as I mentioned, we also need to specify, okay, I want the employee and the date of birth to be joined. But on what basis should they be joined? So here, once I specify the alias name for the employee date of birth, which is EDOB, I say on. That means using which column are we going to join both the tables. So I'm joining based on the employee ID of the date of birth to the employee ID of the employee table, right? So this being an inner join, it will return us only the common employee IDs across both these tables. So let me execute this, and you will notice, as discussed earlier, you will only notice 1, 2, 5, 6, 7, and 8, because 3 and 4 are not present in the date of birth. 9 and 10 employee IDs are not present in the employee table. Now, Two things that I want you to remember. One is the alias names. You cannot have the same alias name for two or more tables in the same query. So in this particular query, you cannot have two alias names which is the same. Second thing is, when you're joining on a column, based on a column, it does not have to be necessarily a primary key and a foreign key. It doesn't have to be necessarily that. You can also join two normal columns, but ensure that they have common data in them. I mean, you cannot join employee ID to name. That will make absolutely no sense, right? So join a column that has common data, that has similar data in them across both the tables. All right. Now, if you notice, earlier when we used to say select star, it used to give us all the data for the employee table, correct? But now when I do a select star with inner joined with another table, it gives us not only all the data from the employee table, all the columns from the employee table, but also it gets us all the columns from the employee date of birth table as well, right? As you can see, it gets us the employee details. That means the details from the employee table and also from the date of birth table as well, which is the employee ID and the date of birth columns. Now, let's say I don't want, obviously, no one would want to see the same employee ID twice because it's an inner join. So obviously the ID value is going to be the same. So why do we need to show it twice? So in this case, we can choose to replace the star with the specific columns, right? We can specify, no, I want to see employee ID. And then what I want to see is I want to see my first name concatenated or added to the last name and shown as full name. And we have a space in between because I want my first name plus my last name. But if I don't put a space in between, it will concatenate them together without any space. So it'll be confusing to read. But when I put a space in between, it'll be easier to read the first name and last name separated by a space in between. And then I just need the date of birth. I don't care about the salary nor the address. Now, if I execute this, whoops, it throws an error. It says ambiguous column name employee ID. And why is that? Because if you have noticed, I mean, by now you have understood that both the employee and the employee date of birth has the employee ID column. So it's asking, hey, you want to see the employee ID column? Fine, but from which table do you want me to pick it up from? So I say, okay, go ahead and pick it up from the employee.employee ID. EMP refers to the employee table, correct? And now if I execute this should work. Okay, so it just returns the common records across both the tables in whichever format you wish to retrieve them. Okay, so this is about the inner join. Now, if you notice, this alias names comes in handy when we have the same column across multiple tables. Plus, I mean, if you don't use the alias name, you should have used employee.employee ID is equal to employee date of birth to employee ID. And again, as I've explained earlier, the alias names makes your query look simpler, smaller and simpler both, right? So yeah, that is basically why we use the alias name for. See, if I use the employee table as is without using the alias names, this instead of EDOB, I would have mentioned it was necessary for me to mention it as employee DOB, and here it should be employee.employee ID. And here as well, it should be employee.employee ID. You can do that as well, but this looks a lot cleaner and simpler. So it's not mandatory, but it's a good practice, I would say. Let's move on now to the next type of join, which is a left outer join. Now, a left outer join again helps us join more than one table together, combine multiple tables together. And in this, it returns all the records which are present in the left table. I said return all the records which are present in the left table and only matching records from the right table. Now, let me first show you how to join it, and then I'll explain what a left table and a right table is about. Now, if you see, if you the way we write a left outer join is exactly similar to how we write an inner join. The only thing is we need to flip or switch the join name. That's it. So here, earlier we used to say select star from employee as EMP, inner join the employee date of birth as EDOB on EDOB.employee is equal to EMP.employee, correct? We used to use inner join instead of left outer here. That's it. That's the only change that we are doing here. Instead of the inner, we use left outer and everything else stays the same. Okay, now what is a left table and what is a right table? So when I choose to put this query in a single line, as you can see right now that I have done it, I see my employee table on the left hand side of my screen and the date of birth table on the right side of my screen. Right? So that means this is my left table and the date of birth is my right table. And in a left outer join, the preference is always given to the left table, that is the employee table. So it will generate or it will pull all the data from the left table, which is the employee table, and only matching records from the date of birth table. Okay, let's execute and see how it looks like. So if I execute this, this is the output that we will see. Just concentrate on the left side of the data here. Okay, on the left side of the select, you will find records from 1 till 8 in continuous order. Now this is what we have in the employee table, isn't it? But on the date of birth side, on the data from the date of birth table, we only get the matching records, like 1 and 2 are present, correct? 5, 6, 7, 8 are present, but 3 and 4 are not present. I mean, we have knowingly skipped them so that we can, as I said earlier, demonstrate you all the different types of joins. So it gets us all the data from the left table, 1 until 8, and only matching records from the right table. The ones where the data is missing are shown as null. Simple. Now you will get a lot of interview questions very similar to this, wherein they might ask, or related to this in fact, wherein they might ask you, hey, can you given two tables and we have, let's say, employee ID as a common column, how do you know the employee ID is present in one of the tables but missing in the other? So all that you have to do is use a left outer join in between both the tables, and then try to find out where edob.employee ID is null. Right, that means these two columns are from the employee date of birth table, right? So we just say edob.employee date of birth is null, so it will only pick up these two records, isn't it? So here, if I execute, you see we get only 3 and 4. Now we know that, okay, for 3 and 4 employees, we do not have the date of birth configured. Simple. Now, as these only had like 10 or 8 records, we were able to see it with our naked eyes that yes, we have only 2 records which are null. But let's say we have millions of records from which we have to find out. The best way is to use this where clause in here. Okay, so this is about a left join wherein all the data from the left table is selected and only matching records from the right table are shown, and the ones which are not matching or which is not present in the other table will be shown as null. Coming to the right outer join, if you have understood the left outer join, right outer join will be a cakewalk for you guys. The right outer join does the exact opposite thing. It now works. Okay, one more thing that I forgot to mention in here is the left outer join can also be written as left join. Okay, it's going to work exactly the same. If I run this and show it to you, it's going to work exactly the same. It selects again all the records from the left and only the matching records from the right table. Okay, so the outer keyword is optional in here. We don't really need to add the outer keyword, but if you add it, again, there is no harm. I'm going to take these two examples here, so it'll be easier for you guys. Okay, so let's take this into.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
One Excel. Okay, this is my employee employee table. I mean, to make it simpler, I have used only 8-10 records and not more, because joins are really important, and I want you guys to understand this very carefully. This is the employee table. Let's pull the employee date of birth table. Now the employee date of birth table. All right. So now with the inner join, we are going to get only the common employees. Simple. What are the common employees between both these tables as per you? Obviously 1, 2, 3, 1, 2, and then 4, 5, 6. Correct? Because here we have only 1, 2, 4, 5, 6, and 6, 7, and 8. I'm sorry. So we need to add 7 and 8. Okay. So we have about 6 matching records. So the inner join is going to give us only 6 records. That is these two and these, which is these. Can you relate to it? Not this one. I'm sorry. This one is a no fill. So with the inner join, we are going to get these details and these details, and along with that, we're going to get these details side by side. In a left outer join, okay, let's say this is the left table. In that case, we will get all the data from here, which is 1 till 8, and then we will get the matching records from the right, which is 1, 2, and then we don't have 3 and 4, right? Because it'll try to match with this result set. So we don't have 3 and 4. So it'll not show 3 and 4. I mean, for 3 and 4 on the right table, it'll show as null. And then for 5, 6, 7, 8, it will show the data like it did here in the left outer join. If I execute, sorry, if I execute only this, you see, I have 1 till 8, but only 1 and 2 are the matching records. 1, 2, 5, 6, 7, 8 are the matching ones. For 3 and 4, it shows as null because the date of birth doesn't have anything configured for these two employee IDs. Exactly, Favor, exactly. So the left table is given the preference in the left outer join. Okay. In a right outer join, the right table is given preference. So now if I do a right outer join, exactly the same query, just that we replace it with a right join. Okay, that's it. Change the left to right. And if I execute this, now what will happen if I take you back to the example? Let me clear all these off. Now we will be getting all of these as the output to start with. Okay, so all of these will be selected 1, 2, 5, 6, 7, 8, 9, and 10. But when we compare this with this table, what are the matching IDs that we have? So we have 1, 2, 5, 6, 7, 8. We don't have 9 and 10. So for 9 and 10, it is going to show as null. If I bring you back here, you will notice that now it gets us everything from the right table because it's a right join, and only the matching records from the left table and the ones that are missing are shown as null. So if you're asked a question saying, hey, can you please help us figure out the records that have a date of birth but does not have the employee entry? Again, with naked eye, with this small result set, you can easily tell, okay, for 9 and 10, we don't have a corresponding employee. But how do you do it in a more professional manner? You use a where condition and say where emp.employee is null. This time we are saying wherever the employee ID is null, that means that employee ID doesn't exist in the employee table, but it exists in the employee date of birth table. And here, if I execute, you'll notice that it gives me 9 and 10 only. Real-time examples, I cannot relate to anything right now because, to be honest, I would use a left join more than a right join. So what I do is I put my table, whichever I need to be set a preference as on in the from, and then the other table in here, and I use a left join instead of a right join. So most of the time, I personally feel, I personally use left joins a lot. Right joins you specifically use when you only have two tables, because then it is easier to control. your data. When you have a lot of other tables joined below this, it gets a little too complicated. Okay, because then this table is given the least preference and then the rest are given the preference, and then it complicates a lot of things. So if you want something to be given a lot of preference, make sure you use it in the beginning, and the one that you want to give the least preference, use it at the end with a left join. Okay, that means this table is just used to pick up the reference records that matches. That's it. All right, let's take this example. So here, let me replace this with a select star. Okay, so I replace this with a select star, and here if I execute, it works, right? Now, if I want to join a third table, let's say I want to join the primary key test table, I give it an alias name, and I say on the primary key test table's ID column, match it with the employees ID column. And if I execute this, I get only 2 records. Why? I get only 1 and 2. And why is that? Because if you look at the primary key test table, we only have 1 and 2. So when we inner join it, inner join with another table, which is the primary key test, obviously it's going to give us only those employee IDs that matches with the ID from the primary key test table, because inner join mostly gives us the matching records, right? So you can either join a third table using the first table like I have done here, or you can join a third table with the column from here. It doesn't matter. Okay, you can join it with whichever table you want to join it with, provided both the tables are joined earlier. I'm hoping that should answer your question. If we want all columns from table 1 and selected column from table 2, then how do I write? Okay, that's another interesting question, and a good one in fact. So if you want to, let's say, select all the columns from the employee table. So what do you say? You say emp.start, which means it'll get us all the data from the employee table, and from the employee date of birth, I just need the employee date of birth column. Okay, so here if I execute this, you see it gets us all the data from the employee table and only the date of birth from the employee date of birth table. Okay, so this is how you can get all your columns from the employee table and only selected columns from the employee date of birth. Next up, let's talk about the full outer join. A full outer join helps us in joining 2 tables and getting all the data from the left table as well as the right table. That is from the employee and the employee date of birth both. And only when the data doesn't match, it shows up as null. Okay, the matching records, it will show it as it is, but the not matching ones will show as null. So if I run this, notice that it gets us all the data from the employee table. You see 1 till 8, everything from the employee table, and only the matching records from the date of birth, right? The ones that are not matching, obviously it shows up as null. But again, as this is a full join, it also brings up all the records from the right table. So if you see 1, 2, 5, 6, 7, 8, 9, and 10, right? So it also gets us 9 and 10 as well. But for 9 and 10 employee date of birth, we don't have the corresponding employee. So with that, it shows as null. So basically what we have now with the full join, the output that we have now gets us all the data from both the tables, and at the end tries to get the matching records from the other table. Okay, and the ones where it doesn't match, it shows up as null. Okay, now let's say you want to um, see the data wherein you want to find out employee IDs which are present in one of the tables but missing in the other. Here what you can do is you can say emp.employee ID is null or edob.employee ID is null, and in this case it'll give you all the employees that are present in either of the table but missing in the other. Right, now moving on to the cross join. Okay, the cross join is like a Cartesian product of both the tables. Okay, what does the Cartesian product really means? So let's say I have one table which has 3 records, 1, 2, and 3, and another table which has 2 records A and B. Then if I do a cross join between these two tables, the output will be 1A, 2A, 3A, 1B, 2B, and 3B. That means all the records from the first table will be joined with all the records from the second table, irrespective of the values, irrespective of the row, irrespective of anything. When you use a cross join blindly, it will map all the rows from your first table to all the rows in the second table. Okay, so when we say Cartesian product, this is what it means. Cartesian product means whenever we multiply two result sets, whenever we join two result sets, the output number of records should be equal to the number of records in the first table times the number of records in the second table. Okay, cross join is the Cartesian product of both the tables. Now, cross join is something that we use very rarely. In fact, in my 8 years of experience, I've rarely used a cross join. And I mean, if just to give you an example, I have thought of something. Maybe let's say we are asked to regenerate the salaries for all the employees in the last year. Let's say we want to build a report for the salaries of the last year for all the employees. Now, before you begin, let's say you have 1,000 employees in your organization, you would need a template to begin with, isn't it? Wherein all the 1,000 employees are mapped to all the 12 months of the year from Jan till December, isn't it? To start off, you would need a template wherein it will get you all the employees mapped to each of the month of the previous year. So that means it will have about 12,000 records in the entire template, right? So how do we achieve this? In order to achieve this, obviously we will have an employee table, right? Let's consider our employee table to be the employee table in the database. And then what we need is we would need another table just to have all the 12 months inserted together. So here I create a table called months, have only one column in it, month name as varchar 10. So basically 10 characters for the month name. Now here I'll say insert into months and the month name column, and I'll insert all the 12 records into the months table. Okay, so if I just go ahead and create this table and insert these records, so 12 records are inserted, correct? Now, as we mentioned earlier, it will blindly join all the records from the first table to the second table, right? So there's no concept of the on condition here, right? We don't need the on condition because in the earlier joins that we saw, it was joining the two tables based on a certain column. But now with the cross join, it is no longer essential. So all that we have to do is I select all the data from the employee table and cross join it with the months table as M. And then what do I select? I select the employee first name, last name, and the month name. And if I execute, so how many employees do we have in the first place? Let me show you here real quick. So we have about 8 employees, correct, in the employee table. And we have about 12 months. So the output should be 8 times 12, which should be 96. And if I execute this one, you see for Dinesh, it is mapped to Jan till December. For John, again, it is mapped from Jan till December. And then for Santosh as well, it is mapped from Jan till December and so on. All right. So this is how we efficiently use a cross join. But I mean, the use case of this is very rare. I mean, you won't find a use case for this, at least in my work experience. It's Rarely I have found this situation. The last time I used it is, I can tell you, maybe when we had a list of projects, right? Let's say we had about 30 or 35 projects, and for all the 35 projects, we had to calculate a list of about 10 metrics. Okay, so we had 35 applications or 35 projects, and we had to build metrics, around 20 metrics for each of the applications. So now to start off the calculation, before we start off, we needed a template, right? Wherein for all the 35 projects should be mapped, each of them should be mapped with the 20 metrics to generate a structure first. So in here, I used to cross join the projects table with the metrics table, which had about 35 and 20 records. So the output used to be 700 records. So this used to be my template, right? Because 35 times 20 would be 700. So I used to start out with this and then slowly run the calculations for each of the application. This is the last time I used a cross join in a real-time project. In a full outer join, it is joined based on a column. Okay, it will never join all the records from the first table to the other table. If I show you this with the full outer join, it only gets us the data from the left table and all the data from the right table, as you can see. And then against each of those records, it'll try to match the ID. If the ID is present, it'll show the record mapped. If the ID doesn't match, it'll show it as null. Okay, so the same applies for here as well. You see 9 and 10 is not present in the employee table, so it shows up as null. Full outer join is mostly done on a particular condition, whereas a cross join would blindly join all these records with all these records. So that means the first record from the employee table would have been joined with all the records from the date of birth. Then the second record from the employee table would have been joined with all the records from the date of birth. Third one again would have been joined with all the records from the third table, and so on. Okay, and whereas in a cross join, it'll but with the full outer join, it was it'll give you only the matching IDs. Okay, I think I showed it to you. Okay, I don't know how I can show this with an example. So here, if I say select one, union all, select two. Okay, or let's say select one, or select two. So if I run this, it combines the records one below the other, right? But in a join, if you notice, the tables are joined, the records are joined side by side from two tables. Simple. I mean, they are entirely different concepts. Okay, union all is just used to get the data one after the other, all in a single result set, one below the other. If you see, the more records I join, it just keeps getting more and more records. But here, if I join, I get more and more columns, the different properties. Yes, you can tell that it appends the tables, doesn't come. I mean, append and combine is the same thing, but think of this. Okay, when you join your tables vertically, it is using a union or a union all vertically, wherein the records are appended below or combined to the end. Then you know that it's a union or a union all operation. Whereas joins are more of horizontal operation, wherein it is joined side by side using a matching record. Okay, whereas in a union all, there is no matching at all. Okay, it just keeps appending the data one after the other. What is the meaning of a metric? Could you please give an example? I mean, this, I was working on a dashboard wherein each of the applications, let's say my company had, like my organization has about 35 projects. Now for each of the project, we were calculating some metric, like what has been the resource utilization, what has been the capacity utilization, how much of effort has been used, how many man hours has been used, right? All of these are different metrics that we were calculating. Obviously, each of them had a different formula, and that was a very complicated and a very fun to work application on. But yeah, to start off with, obviously we needed a template, right? So that wherein I can map all my 35 projects to all the 20 metrics that are available. So in that case, I used to start with a cross join. Okay, let's now talk about a very critical data manipulation, a couple of very critical data manipulation operations that we do on a day-to-day basis on our databases. We're going to talk about update and delete in detail. So, right. So, and both of these deals with manipulating the data. That means whatever data we have already stored in the table, how do we either update or remove them as per our need? Okay, now the importance and the criticality of these two increases multifold, owing to the fact that it is very difficult to revert back the data once it is updated or in fact deleted. Right. I have seen in my teams very early in my career. I can talk about an example of a real life example. There used to be a very senior database developer in our team, a SQL database engineer of at least a decade long experience in the on-site. Okay, not in India, but basically in the head office. And we used to coordinate together and work. And there was a production issue. There was an issue wherein he was required to delete about a 250,000 records, about 250,000 records. I mean, plus or minus a little bit from there. Now, he instead of firing a delete command on those specific 250,000 records, he fired a delete command on the entire table. What went wrong? He just missed to filter the records that he wanted to delete. Okay, and that silly mistake of his cost his entire job, because the entire table became empty. And if we wanted to get back the data, because it was a huge table, it was a very important table in the context of the project, and the project would fall apart if the table doesn't have the necessary data. Now, to get back the data, the only option that we had available with us was to restore the database. And to restore the database, at least in a live environment, you would at least need 4 to 5 hours, considering you have a few tens of gigabytes of data. Let's say you have around 20-30 gigabytes of data. That database backup will take at least 3-4 hours to restore into your system. Right, and this is on a small scale. Okay, I'm talking about data on a small scale. It might go even more. Now, for all the duration, the business will be down. Okay, you will be losing revenue hour after hour during the day, and it'll cause, obviously, it caused a lot of disturbances back in the day. A single update on the same lines, a single bad update. I used to work again back in the day and we used to deal with insurances. Okay, title insurances, wherein this is something that is very uh, uh, um, relevant in the states wherein your properties are insured. Anyone from the states would know what title insurances are. And we had these claim amounts attached to each of the claims, and any wrong update on the claims, let's say there is $100,000 dollars claim that is attached to a particular property, and one bad update, let's say we add another zero to it, becomes a million, right? As simple as that. Now the company is liable to pay $1 million, which is 10 times of the claim amount, just because of a bad update. So you see how millions of dollars of revenue is impacted just because of one wrong update or delete, right? So the one thing that you can lose your job on is on these two commands, most probably. Okay, and what I've learned is, I mean, you do a mistake once, you have to definitely learn from it. And I in fact learned a lot from that particular mistake. I spoke to a lot of senior resources or senior developers back in the time, and checked with them what exactly do they do in order to not repeat that particular mistake, right? And over a period of my own experience and whatever I have got from my other senior developers. I have three golden rules that you can follow to ensure that you don't end up with the problem or in the situation that I just spoke about. To start off, always ensure to take a backup of the rows before you update or delete them. And I'm talking about the rows here, all right? So let's say you're updating 5 rows, take a backup of those 5 rows. You're deleting 10 records, take a backup of those 10 records. Where do we store them? How do we store them? Is something that I'll explain you in detail in some time from now. Next, always start with your update and delete query with a select. You might say, I mean, come on, we are trying to write an update and delete command. Why do we start with the select? The one thing that I've learned over these years is the more confident you are on your query, the lesser is the chance of the query uh, having after effects, right? Because whenever you execute a query, there are chances that it might have some after effects. That means you might do a delete or an update now, and it might have repercussions on the other records or on the application at a later point in time, right? So how can we build the confidence on our update and delete? By starting with the select. You might ask, how? What I'm going to do is I'm going to first see the records that I'm planning to update or delete using the select command. And on top of that, we're going to write our update and delete. Again, I'm going to show this to you as well in detail. And to complement that select, never, ever, 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 I'll repeat this again and again. Forget your where clause, right? Because very rarely at your workplace, you will be asked to update or delete an entire table's data. Most of the time, it will be for a specific filter. Okay, it could be any filter, which you will be using in the where clause. Okay, now the moment you miss your filter, everything will go for a toss, right? You will have your entire table updated with the wrong value, or your entire table getting cleaned off because you don't have a where clause. It will clean off everything, right? So let's talk about these three details to start with. I mean, these might take a couple of more minutes for you to arrange and prepare, but it is totally worth the time. Okay, it is always better to be safe than to be sorry at a later point in time. So let's first talk about how to take a backup of the rows before you perform any DML operation, especially the update and delete. So what we usually do is we say select star from employee, correct? And this would give us all the data from the employee table, isn't it? Now, all that I have to do, let's say I have to take a backup of all these records into a table. All that I have to do is I'll have to just say into and specify a name for your backup table. Okay, so here the name of the backup table that I provide is employee underscore backup. That means when I execute this query, the employee underscore backup table will be automatically created in our own database, which will have the exact same structure of the employee table and all the data that is there in the employee table. All right, so let me run this query. You see, it says 8 rows affected. Let me show you something. Now, if I go to the Object Explorer here, on the Intellipaat 25th July, if I refresh the tables, this is our database, right? If I refresh the tables, if you notice here, we have an employee underscore backup table. Isn't it the same table that we just mentioned in the into command, right? So it's exactly the same table. So the employee backup that we specified here automatically got created as a table in the DBO schema, obviously because of the reason that I did not specify any schema name here. If needed, you can also specify a schema name, but I didn't want to. So I just left it as it is. And this got created where? In the DBO schema, right? So now we have a physical table with us in the database, which has all the data from the employee table in the form of a backup.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. the course link of which is given in the description below.
Right? So if in case we are trying to update anything in the employee table, obviously we will be, right? That's the reason we are taking a backup. In case something goes wrong, we can always refer to the backup table for the original data, for the original values. So if I run a select from the backup table, you will notice that it has all the data backed up from the employee table, copied from the employee table. Okay, so this we are going to keep it in the database. I usually prefer keeping it for about 2 to 3 weeks. I call it as a cooling period, because the moment, let's say you perform an update or a delete, now you are satisfied with it, you find and test the data and everything looks good. That doesn't mean everything has turned out to be good. Okay, sometimes you might find the after effects of your query in a week or two. Okay, and you need to ensure that your backup table is intact until then. So make sure, what I do is I keep my backup table for a period of 3 weeks, and after that I just drop this table. Okay, this is again your responsibility. Make sure that you drop this table after you're done with your 3-week cooling period. So this is how we create the backup table. It's created as a physical table in the database itself. This is the first rule, wherein we are just taking up the backup of the data before we perform the update or delete. We are yet to come to the second and the third rule. Okay, now taking the entire table backup might not be always feasible. Let's say the employee table has about million records. Obviously, you don't want to create a backup table that will have another million records solely because of the space crunch. I mean, you don't want to overload your database with again the same million records stored over and over again, right? Because end of the day, let's say you just want to update 3 records, wherein the employee ID is 1, 4, and 7. Let's say you want to update only these 3 records. So what do you do in that case? You can have a backup table created from the employee table only for these 3 employee IDs, right? So here, if I execute it, you will notice that it now says 3 rows affected. And if I show you the backup only rows table, you will find that it has only the 3 rows backed up for all the 5 columns that we have. So the backup table has now become even more lighter, isn't it? There's no need to take the backup of the entire table if you're trying to update only the 3 records. Let's say you want to make your backup table even more lighter, right? If you want to do that, what you can do is, let's say you want to update only the salary of a few employees, which is for employee ID 147. So what you need is, you would need your employee ID and the original salary, right? You wouldn't need to store everything, right? Because the name, first name, last name, and address is irrelevant, because we are not going to change it with our update. All that we're going to do is work on the update column for these 3 employees. So all that I need to store is the original salary of the employees from before the update into a backup table. So now, instead of select star that we have been using earlier, as you can notice, I was always using a select star into, right? But here, only for this specific requirement, wherein I'm only going to update the salary for 3 records, I just take a backup of the employee ID and the salary column. Okay, and I can create a backup table for it. Okay, and if I execute this, again 3 rows affected, but this time the backup table will be even more lighter, wherein it'll have 3 records, but only 2 columns for those 3 records. Okay, so this is how we create backup tables as per our need and requirement. Okay, if you are trying to update the entire table, take the backup of the entire table. If you're trying to update only a few set of rows, take the backup of few set of rows. If you are very specific to one single column for the 3 records, then you change your select to remove the star and specify the columns, and also put your where clause. So now you can specifically keep your backup table to as lightweight as possible for easy revert back or for ease or to put less load on your disks. So this covers the first point wherein we spoke about how to take a backup before the update. Now, how do we write an update, right? As we discussed earlier, we need to start with the select, right? So let's start with the select. So here I say select star from the employee table as EMP. All right. So here, if I execute this query, I would see all the data from the employee table, right? Now let's say I want to update the employee ID 1. So what do? I say where employee ID is equal to 1, right? Let's say I want to update the employee name for the employee ID 1 from Dinesh to Dinesh new. Okay, if I execute, this is the record that I would get, obviously, right? Because I'm filtering based on the filter employee ID is equal to 1. Let's say, so now I'm confident that this query is always going to return me the record with employee ID 1. So I'm now confident. I've built my confidence around this query. What if I told you we can continue from this query and build an update on top of it? That would be better, right? Because we are already confident on this query. We know that this query is always going to impact the employee D1. All that we have to do is, now that we are confident, by applying the select and the filter, we comment this line, take it below, and here we can say update EMP set employee first name is equal to, let's say I want to update it to Dinesh new. Okay, currently it is Dinesh and I'm trying to update it to Dinesh new. Okay, so you see how we have used that exact same query to build an update on top of it, right? Now if I try to execute this, I am more confident on my update because I have already seen by executing the select and it impacts only one record. So if I execute, brilliant. See, I exactly have what I expected or what I intended to do. I have my query has only affected one row. So great. Now the other uh, beautiful thing about this select that we wrote earlier, this select can now serve as a test query for you. Testing after any change that you do is always essential. Okay, so we need to test if the change has been exactly done as the as per our need. So here, let me run this select again, and you will notice that, okay, brilliant, Dinesh has been updated to Dinesh new. Now, the very next moment, once you're done with your specific testing, you need to check if none of the other records have got impacted. Because again, this is called as impact analysis, wherein we analyze the impact of our query just to make sure that our query hasn't impacted any other record in the table. So in order to do that, we can just run a select from the employee to see all the data. And we see that, okay, none of them are updated. Only the one that we intended to update has been updated. So we are cool until now. All right. So this is how we start with the select and use a where clause just to ensure that we our select our update statement exactly impacts those records that we are interested in. All right. Now let's say you have a, a crazy friend of yours working in the office, and he or she comes over to you while you're executing this update, talks to you, asks you if you want to grab a coffee or something end of the day, and you get busy talking, which you should not be doing, especially when you are working with SQL servers and modifying, especially when you're working with updates and deletes. But you did a mistake, and while executing a query, instead of executing with the where condition, you executed only this. Oops. So you wrote the query brilliantly. You put everything as per what is recommended, but while executing it, you missed out on the where clause. And what happened? All the 8 rows got impacted. And so if you check the employee table, there you go. This is the mistake that I was talking about. One silly mistake wherein you left out the where clause and everything gets updated to Dinesh new. So now the data in this particular table has corrupted, kind of become bad now. So how do we rectify this? This is where we are going to use the backup table that we created earlier. So if you remember the backup table, what we're going to do is to start off, let's again start by selecting from the employee table as EMP, and I'm joining with the employee backup table as BAK, because I know that I have all the employees from the backup table in the employee backup. So I join both these tables on the employee ID column. You see, the employee ID from the backup table is joined with the employee ID from the employee table. All right. And here, just to see, I'm selecting the employee ID from the employee table, the name, the first name that we updated wrongly from the employee table as the new name that we have right now in the table, which is the bad name. And I'm also selecting the first name from the backup table, which was the original name before the update, right? And if I execute this, I see that, okay, for these employees 1 until 8, this is the new name, which is the bad update that we did. And these are the original names. Thank God we have the backup table with us. Now, all that we need to do is, again, comment this select statement and write an update and say update EMP, because what we have to do, we have to revert back the changes into the employee table, isn't it? So I'm saying update the employee table and set the first name in the employee table to the backup table's first name. That means whatever first name we have in the backup table, bring that into the employee first name column in the employee table, right? And if I run this now, it was affected. Again, after any update, let's, as recommended earlier, let's run a select just to see if the data has been updated perfectly. And there you go. Now the new name that is in the table is this, whereas the original name was also the same. So now we have reverted back our data as to however it was earlier. You see the advantage of the backup table now? It might take you a couple of more minutes to frame the backup table query and to store it in the database, but it's going to be a lifesaver for you. All right. Although us in real life, the rows to be backed up will be specified by example senior manager. It will be specified. No one is going to tell you. They are only going to tell you that these records needs to be updated with these new values. Okay, so it's your responsibility to take first the backup of the rows that are going to be impacted by the update, and then work on your update. Can we run this from a text file to avoid any mishaps? But in any case, you wouldn't know. See, when it is a bad day, it is going to be a bad day. Okay, unless you just leave office, go to your room, turn off the lights, sleep for the rest of the day. I'm not kidding. Okay. So yeah, you can execute, you can take whatever precautions you take. See, we wrote this query brilliantly, right? As per our recommendation, we did the backup, we did everything that we could until that weird friend of ours popped in and everything went for a toss, right? So the backup table is strictly for this reason. Just in case some mishaps happen, you do it from a text file. You cannot run it from a text file, right? The query, you cannot run it from a text file. You'll have to run it on connected on your SQL Server Management Studio, right? So yeah, that's the thing. Why do we have new name in brackets as it is not a keyword? I don't know why I kept it here. Let me see. It might not be, but it should not be a problem as well. As I said, the new name, it should not be a problem as well. You see, it still works. And it should be for no specific reason. I don't know why I did that. Now let's move to our delete statement. Again, the delete statement stays exactly the same. We start with the select. Let's say I want to um, delete the employee ID 8. We know that, okay, that employee is no more relevant, and I want to delete that record. So I first start with the select as we did for the update. So I see, okay, with the select, I see that, okay, this particular record is what is going to get impacted, and then I comment the select here and mention delete emp here, and I run this command. Okay, so I am now more confident on my query because I knew from earlier that, okay, this query is going to impact only one single record, which is with employee ID 8. Now, again, we are going to run two tests, right? One is for that specific row, as we discussed earlier, to see, and we should not see that row anymore because we've already deleted. That's obvious. That's great. It worked. But again, at the same time, we need to do the impact analysis just to see if our delete did not impact any other record. And it indeed hasn't, because all the rest of the records are intact as is, right? So our delete has worked perfectly fine. Now let's say that friend of yours again reappears and he calls you for coffee again. Damn you. And while I'm executing, I again delete it without the where condition. So apart from killing your friend, the other thing that you would do is make sure you revert back this delete, because now your table is entirely empty. I mean, you will not see any data in your table. Everything would have vanished because you ran the delete without the where condition. So there was no condition whatsoever. We just saying delete from the employee table basically means delete everything from the employee table. So in order to revert back a delete, what we do is we need to insert back from the backup table. So all that we have to do is select all these columns from the backup table and insert into where the employee table, right? So here I do that real quick, and there you go. Again, we should have the data back again in the table. You see, now the employee table again has all the records back inside of it. Simple. Again, you see how this turns to be a huge lifesaver. I mean, it'll hardly take you a minute or a couple of minutes to take a backup, but it's certainly going to be a lot helpful. Now, what people tend to do is, I've seen this, okay, whenever I talk to or I groom juniors who join into the team, for the first few months, they'll be all obedient and they'll take a backup every time they do an update and delete. And the first time when they choose to not take a backup, saying, hey, I never falter with the update or delete. I mean, why do I have to take a backup? It just takes a couple of more minutes. Let me just do the insert, or let me do the delete and update on its own. That exact day is when you will need it. Okay, it's that human God connection that is always there, wherein the day when you don't take an umbrella outside on a rainy day, it'll rain. Okay, it'll rain cats and dogs. Okay, so I mean, every time make it a practice to take a backup of the rows every time you run an update or delete. Doesn't take much of your time, but is going to save your job and your life bit time. Okay, so we have one last thing that we have to discuss, which is the merge join. Okay, so let's just understand what the merge join is about and where do we exactly use it. Let's say we have an employee table, right? We have an employee table with the HR team, with the HR team managers. That means the HR is basically the human resources team who has all the details about any changes that has happened to any particular employee in the organization, right? So we call it as a live table. That means any change in any of the employees, it could be a raise in the salary, it could be a change in the department, it could be anything, okay, anything related to an employee will all be updated by the HR team straight away in the employee table. So this is managed real time. So whatever changes we have to do, I mean, whatever changes are supposed to be done is done by the HR team real time. So let's call it as a live table. Now let's say the organization, obviously every organization will have a salary database or a payroll team that will be that will need the data from the HR team to process the salaries. So obviously they would need the employee data to be refreshed so that they can process the salaries based on new increments or the new wages that might be applicable for the employees, right? So in such cases, right, what we might need is we might need a copy of the employee table to be refreshed twice a month for the salary database. Or let's say there's a table, another table in the same database where we would want the employee data to be refreshed twice a month. So that particular table, the other table that we have, will be used by the payroll team to process the salaries. Right now, why twice a month? Let's say the pay is released twice every month. So obviously they would need to refresh the data twice every month so that they know the actual salaries that needs to be dispersed for each of the employees. All right. Now, let's say we have, let me make this as one Dinesh. All right, so let me show you with an example what I just spoke about. So we have, let's say, an employee table maintained by the HR, which is a source table, and we have these 3 employees in it, right? And then we have another employee table for the payroll team, which is a target where we want to refresh twice every month. So the first refresh that we would do is obviously to copy all the data as is into the target, isn't it? It'll be a blind copy as it is, no changes whatsoever. But let's say we refreshed it on the 15th of July, and in between 15th to the 30th of July, we might have this table might have undergone multiple changes. Let's say this has been updated to Mahesh. Some employee changed their name. Okay, so this record has undergone an update because it's the source table, right? That means the HR team regularly maintains this table. And let's say this employee has resigned. So let's say this is deleted from the main table. And then there's a new employee who has joined in the last 15 days, which means it has been inserted. So what do we have? We have one employee which has been updated, another which is deleted, and the other which has been inserted. That is newly added, newly joined the organization. Now cometh the 31st of July, we will need to refresh the data again into this table. So there can be 3 scenarios in this situation, isn't it? What we'll have to do is obviously there needs to be something that we can use to compare the data, right? So here we are going to compare it using the IDs. So when the ID matches between the source and target, but the name is different, that means we can imply from that there's an update in the source and we need to do an update on the target. So if you compare all these 4 records in here, which one of these do you think the ID matches and the name doesn't match? Obviously this record, right? The ID matches for 2 and John, but it has been deleted, so it's no longer exists. For 3 and Smith, the ID matches, but the name is the same. So again, there's no point touching this record. So the only record that we need to touch is this one. So we say this needs to be updated to Mahesh. So this record is updated. This we are doing it on the 30th of July, 31st of July. Now, the second situation, when the ID is not found in the source, right? So this ID, for example, now let's imagine this has been deleted, right? So let me remove this from here. Now we have this ID in here, ID2, but it's not found in the source anymore. That means there has been a delete from the source. So we need to do a delete on the target as well. So we remove this record from the target, correct? See how the data is being matched based on the IDs. Now the last situation is when the ID is not found in the target. That is this particular record. So we have 4 which has been introduced newly, but it was not existing in the target from earlier. So what we do is we insert this record. So these are the 3 scenarios that you might end up while you're working on a situation like this, in a scenario like this. Can you think of any other situation? I don't think so. These three mostly cover everything. And what we have noticed until now is during the 15 days, this is a live table, right? This is the employee table with the HR that the HR manages is the live table. That means all the changes are done real time. So while we are comparing on the 31st, this table is just used as a reference. All the changes that are done on the target because we want to bring the target in line with the source, right? So we don't want to do any changes on the source. We want to do the changes, perform the changes on the target. So these are the three scenarios that we have to handle in order to map and match both the tables at the end of the day. I mean, twice every month, obviously. I have a question. Favor has a question. We do them manually or through a command. That is where merge join comes into picture, right? The merge join was introduced in SQL Server 2008 to perform update, insert, and delete all at the same time. And the merge command uses a source table to read the data and replicates the changes to the target based on these three scenarios that we just spoke about. And based on the matching records in source, we can set the operation to either insert, update, or delete from the target table. So ultimately, any DML operation that we execute in the merge is all done on the target. We do not modify anything on the source. Remember this. When doing a merge, we do not write to the source table. The source table is just used as a reference to know what data is there in the source. We always perform the insert, update, and delete during the merge only on the target table, right? So let's say we are going to use the employee table as a source that we already have with us. And I'm going to create a new table for the target. Let's call it as salary employee collection, which will have the same 5 columns: employee ID, first name, last name, salary. And this time I have named the address as employee address. Okay, so let's go ahead and create this table. So this will be another table in our database itself. Now, if you notice, the employee has all the data in it. The salary employee collection is something that we just created. Now, let's see how do we write a merge. So all that we need to do is factor in all these three scenarios and we should be good, correct? So this is a classic example of what I was telling you earlier. I mean, a query in itself might seem a lot complicated. Okay, big query in itself might seem a lot complicated, but when you understand what it does, okay, when you break it into simpler concepts, it seems to be very, very simple. The same thing is, I'm going to show you a live example of that. Let me show you what the merge statement looks like. Let me show you. This is the entire merge statement, but it'll take me hardly 5 minutes for me to explain it to you. And more importantly, you will understand it in the only 5 minutes, because all that you need to understand is these three scenarios that we spoke about earlier, right? And if you have understood this merge statement that I'm going to explain you now, you will be able to understand it in no time whatsoever. Right. So let's start with the merge. We say merge. We first specify the target table name and say as target. So we first specify the target table, and then we say using. That means using which table as a source. So I say using the employee table as source. So the target is the alias name for this, source is the alias name for this. And then we need to specify on which column these two tables should be compared, like how we did it earlier. We compared it using the ID column, right? So we are going to do it on the employee ID column. So I say on target.employee ID is equal to source.employee ID.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Now, let's prepare for the first scenario, the update. So in update, if you remember, we discussed when the employee ID matches across source and target, but one of the other columns has some changes in it, has a different value, right? So in order to tackle this, what we say when matched, that means when the employee ID matches across the source and the target, that means the employee ID is present in both the source and in the target table, and either of the columns are different. You see, I'm comparing this first name between the target and the source. I'm comparing the last name between the target and the source, comparing the salary between the target and the source, and the address between the target and the source. So only when the ID matches, but there is a difference in any of these columns, then update. And we have to update which table as discussed. Update, insert, and delete during the merge will happen only on the target table. So we set the target tables, the columns from the source. So any record that it finds that the ID matches, but either of these columns have a different value, that's the reason I said a or. That means if either of these has a difference, it will update all the columns from the source for that particular row. This is the first situation, right? The second is the insert. How do we do an insert? When the employee ID is present in the source, that means a new employee has been added in the source table, but is missing in the target. So in that case, we have to say when not matched by target. That means when the employee ID is present in the source, but it is not matching in the target, it is not found in the target, then we say insert. Again, we're not specifying insert into which table. Neither did we specify update into which table. But as is mentioned earlier, the merge will always insert, update, and delete from the target table. So it is automatically understood that it's going to insert into the target table, which is the salary employee collection. So when the ID is not found in the target, then insert into the target, and the values should be picked up from the source. Simple. The third and the last scenario is the delete. That means when the employee ID is missing in the source but is present in the target, right? When we have the employee ID in the target that has been imported earlier, but now it is no longer existing in the source because let's say an employee has resigned already. That means it was imported earlier when the employee was active, but now in the last 15 days, he or she has resigned. So the record has been removed from the table. So in that case, when not matched by source, then delete. That means delete that particular record from the target. And all of these is one single query. Okay, so when I run this, it will compare between the source and target and update, insert, or delete based on the need, based on the requirement, or based on its findings. Okay, so now if I run the merge between the source and the target, what do you think will happen? Obviously, the insert will get fired, isn't it? Because there are no records in the target right now. So everything will be considered as a new record. So everything will be inserted in the first place. Correct? So let me execute this in here. Okay, it says 8 rows affected. And now if I show you the employee and the salary employee collection, you should see the exact same data in both the tables. I say the source has 8 records and the target has 8 records as well. Now, the sign of a perfect merge statement is that it should impact no records when the tables are in sync. So now our tables are exactly in sync, correct? So now if I run the merge, it should affect no records whatsoever. So let's see if our merge that we have written works perfectly. You see, 0 rows affected. That means we are good. Our merge statement is good. Any number of times that you execute, it is going to not impact any record in the target because obviously all the records are the same. Let's say I update one of the employees for employee 8. I update the first name to Peter and last name to Fernandez. For now, let me show you what we have. So now the name is John Wright. I'm updating for the same employee ID 8. I'm updating in the employee table to Peter Fernandez. So from John Wright, I'm updating it to Peter Fernandez. And if I execute this, see, I'm updating on the employee table, by the way. And now if you see again, the source and the target would be out of sync, because for ID 8, the first name is Peter, last name is Fernandez. But in the target table, if you notice, we have John, right, still, right? That is the old value. So what are we going to do? Let's say this is the only change that has been done in the last 15 days. So if I run the merge again, here, you can notice that it says one row affected. And this is the row that has been updated. Okay, let me show you here. So here, if I execute, as you can notice, this was already updated by our update statement, but this table has now been updated, the target, by virtue of the merge statement. Okay, now again, both the tables are in sync, right? So if I run the merge again, it would have no change whatsoever, 0 rows affected. See, because now again, both the tables are in sync. Let's say I delete a record now. Let's just delete also. We have tested insert and update. Let's just delete also. I delete the employee ID 8 from the table. So one row affected, deleted from the employee table. And now if I run the merge again, this time one row affected, and you will notice again the source and the target would be in sync. You see 7 rows in the source and 7 rows in the target. So this is how we use the merge to insert, update, and delete all at the same time. Now I showed you individually, but let's say there was one update, another insert to be done together, it will still take care of that as well. Okay, let's okay. So again, I would let you guys put your responses on the chat window. I'd really appreciate that. And the first question is, with an inner join, let me just increase the font a bit. With an inner join, what are we trying to achieve? Okay, we discussed about inner join in the beginning of the session. Okay. All right, so I see a lot of answers already. I'll wait for a few more seconds before I open up. Guys, I've been telling this, make sure you participate, okay? It's not a matter of you giving the right answer or not, but it's just that I want you guys to attempt at least so that you can learn from it. I'm going to explain, okay, why is one of them a correct answer. All right, so I'm going to open up the answer in 3, 2, 1, and here we go. So the correct answer is A, matching information between 2 or more tables. With an inner join, we have been trying to get the matching records between 2 or more tables based on a common join information, correct? So yeah, that is about it. Moving to the next question, which of these is true about a right join? Which of the following statements are true about a right join? Okay, I see a lot of responses already. I'll wait for a few more seconds before I open up the answer. Okay, so let's open up the answer, and the correct answer is C. And I've seen all of you have responded correctly, so that's a great job again. Let's move on to the next question. Which of the following is a correct update statement? Which out of the below mentioned options or the commands is a correct update statement? All right, I see a lot of answers already. That's great. You guys are awesome, all of you. And all of these answers, you're nailing it. Perfect. All right, let's open up the answer in 3, 2, 1, and here we go. So the correct answer is A. Let me explain why the others are incorrect. This one, we have update table. The table keyword is not necessary. Okay. Second, the third one is incorrect because again, we have a table keyword here right after the customers table. So it's not a recommended thing again. This particular statement, the last one, is correct until here, wherein we have a as. It should have been ideally a where condition. Okay, so yeah, the correct option is A. So to start off module 4, let's see how to alter a table first. Let's see. So we have until now seen how to create a table, how to insert data into a table, how to modify data inside the table. Um, Now let's see how do we alter the design of an existing table. So in order for me to alter the design of a table, we can perform three operations mainly. Add a new column to an existing table, remove an existing column from a table, and then alter a column. Okay, these are the three operations that we can do on a particular on an existing table, right? Now, let's say we have a need to add a new table, add a new column to a table. Okay. Now, whenever, let's say I have a table with two columns, ID and name, and I have three records in it. And let's say I want to add a column called salary. Okay, so when I want to add a column called salary, the by default property of SQL Server is that for all the existing rows for this specific column, it will try to set them as null, like this, right? It'll try to set them as null for all these three rows. Okay, for the salary column. So in order for SQL Server to be able to do it, it should be a nullable field, isn't it? Because only nullable fields will allow the null values to be stored. Now, in case I want to definitely make this salary a not nullable field, what I have to do is I need to, I cannot make it a not nullable to start off because SQL Server's default property is to set null values, and it will not be allowed to do that if it is a not nullable column. So by default, you will not be allowed to add a not nullable column to an existing table. But let's say you want to definitely do it. You want a not nullable column to be added. In that case, you can only do it when you have a default constraint that you can apply on the salary column. So let's say I assign a default value of 0. Remember the default constraint, right? Only when you add a default constraint to this column, only then you can create it as a not nullable field or a not nullable column. All right. So to put it in words, we cannot add a new column in an existing table with a not null constraint. Whenever we add a new column to a table, the column stores null in it for all the existing rows, like how I explained just now. Now, if we set it to not null, SQL Server wouldn't know as to what data should be in the new column, because when it will try to store the null value, it will not work because it's a not nullable field. So whenever we want to add a column with not null, we can only do it when we have a default constraint attached to it. Okay, so the only way we can add a new not nullable column to an existing table is when we have a default constraint as well attached to it. Now, how do we add a field? In order to do that, we say alter table. So I'm going to use the default test as an example for this demonstration. For that, let's connect to our own database. All right, so in this particular table, we have three records, right? Two columns, ID and name, and three records in it. So I have only ID and name, and let's say I want to add a new column salary. I would say alter table, the table name, add, and the column name that I want to add, and obviously the data type. So I say salary should be an integer data type, and I want to say salary should not be nullable. So if I want to create a not null, let's try if it works. We already, as discussed, it should not allow us to create a not null field in the default test table in an existing table, right? So if I execute, you see, it throws an error already. It says alter table only allows column to be added that can contain nulls or have a default definition specified. Default definition means default constraint specified. So in order for us to do that, we say add salary integer not null, everything good until here. But the only thing that we need to add to create this column as a not null is to add a default value to it. So now the salary column will have a default value of 0 for all the existing records. Okay, and if I now execute with the default constraint, you see now it worked, commands completed successfully. If I show you the structure of the table first, let's do a Alt F1. You will notice that there's a new column added called salary of data type integer. Most importantly, it's a not nullable field. It's thanks to the default constraint on the salary column that we added. Now, if I show you the table data itself, you will notice that ID and name was existing already. We now added a salary column which has default values of 0. Now, if you want to update the existing salaries, you need to manually update them. Okay, there is no easy way to update them as such. So this is how you can add a column and make it not nullable at the same time. And the only option that you have is to add a default constraint to it. Okay. Let's say I want to add another column, but this time a nullable field. Okay, we added a salary field. Let's say I want to add the address field as well. I would just say alter table, the table name, add the column address. This is the column that I want to add. And I set the data type to var 100. That means it will allow only a maximum of up to 100 characters as a address. And if I execute this, it says commands completed successfully, no hash shell whatsoever. I did not provide any not null or null constraint because if you remember, null to make a column nullable is it happens by default. If we do not provide any constraint, it automatically treats it as a nullable field. So only when we specifically add the not null constraint, it considers that column to be not nullable. So now if I do Alt F1 on this table, we will see another new column added with the name address, and this is a nullable field, by the way, which is obviously the case because we did not add a not null constraint. And if I run the select from the default test, what you would notice is the address column that is now added has default values of null. Okay, because this being a nullable field and having no default value in it, SQL Server automatically stores null for all the existing records. All right, now let's see how to remove columns. So what have we done until now? We have added two columns, one for the salary and another for the address. Okay, in the table default test. Now let's see how to drop a column. So let's say we already have a column existing in the table and we want to drop it. So what I'm going to do is let's try to drop the salary column first. So in order for us to drop the column, we just have to say alter table default test and drop the column salary. Now you need to be very, very careful about the repercussions that you might have when you remove a column, okay? Because this might be referenced in other objects, okay? So be very, very careful before you remove a column, okay? Until and unless you're not confident, do not remove your column, okay? As for my case, okay, what I always prefer is not to remove any column whatsoever. If you don't want to use it, just leave it as it is, because you never know, removing a column might break one or the other objects inside your database, which I don't prefer doing, okay? But yeah, in case you have to drop a column, you can use the command alter table and specify the table name and drop column. So while adding, we just had to say add, right? We never mentioned the column keyword, but while dropping, we need to specify the column keyword and say the column name here. So here I say alter table, the default test table, and drop the salary column. And when I execute this, there you go. We have an error. It says there is an object dependent on the column salary. Okay. Now, whenever we want to delete a column, for columns with constraints, we need to first drop the constraint and then the column. Okay. So in my case, if you remember, for the salary column, we added a default constraint, isn't it? The not null constraint is something that you don't have to specifically drop. But constraints that you find at the end of the table design, like here, if you scroll down to the bottom, you see the constraints that are here. It can be default constraint, can be primary key constraint, it can be unique constraint, it can be check constraints, any kind of constraints that you have. First, those constraints needs to be removed and then only you can drop your column, if there is a constraint on that particular column. Okay, if that particular column that you're trying to drop does not have a constraint, you're good. But in our case, the column that we are trying to drop is the salary column, and we already have a default constraint on the column salary, and this is the name of the constraint, right, which was automatically generated by SQL Server. So if I paste it here, so first I need to drop the constraint on the column. So I say alter the table default test and say drop constraint. Okay, earlier to remove a column we used to say drop column. This time from the table I want to remove a constraint, so I say drop constraint and I paste the name of the constraint that I got from the metadata. And here we go, alter, and it removed the constraint. Now that the constraint is removed, there should not be any problem, or there should not be any impediments in dropping the salary column. There you go. Okay, no blockages. So the salary column has now been removed. And if I show you the default test table now, you will notice that it is back with ID and name, which was already there before we begin the session. We added the salary and the address, but now we got rid of the salary column. So the salary column is now, so only we have the address column left over. Now the address column, does it have any constraints on it? Let's check. Alt F1, go to the end of the structure. No, we only have another default constraint on the name column. So the address column does not have any constraint. All that we have to do to remove it is say alter table default test and drop the column address. And if I execute this, it works like a charm because there's no constraint. So it allows us to directly drop that column. And now if I select it, you will notice that we have only two columns with which we started the session, which is ID and name only. So we added the salary column, made it not nullable, added the address column, left it nullable. While removing it, we first removed the default constraint on the salary, and only then we were allowed to drop the salary column, and then we were able to remove the address column. Then what is the use of not null? The not null is a constraint that we are applying. The not null is for the future values as well. Let's say I do not want null values in my salary column. That is when I create a not null. That means for any new employee coming in, they should definitely have a salary. Okay, like the date of birth. Date of birth is a not null column. That means it should always have a value for every new employee that is inserted. That is the reason, that's the whole point we create a not null constraint. It is not because of the value, it is because of the property of that column. That means every employee that is inserted, every record that is inserted for that particular column, a value should definitely be provided. So the not null is to for that particular criteria. Okay, the default constraint is for whenever you want to leave out that column. Okay, let's say someone ignores it. Now it's a not null column, right? So that is when the default constraint will automatically apply the value. Instead of automatically storing null, it will now store automatically the default value in case someone leaves the salary column out knowingly or intentionally. All right, so let me drop the salary column again. So it'll drop the constraint, and now we should be good to drop the salary column. There you go. All right. Okay. Now let's see how to alter a column. Okay. So we have seen how to add a new column, remove an existing column. Now let's see how to alter an existing column, modify an existing column. Okay. So let's say again, let's work on the unique test table again. Now, if I do Alt F1 on the unique test, what I have is I can see that it has two columns, ID and name, right? Now, ID is of type integer, name is of type varchar, and the length of name that is allowed is only 100 characters. Now, let's say for some reason we start getting bigger names, and we want to extend the length of the name column, right? Let's say we are starting to get bigger names, so we want to extend it by another 20 characters. So basically the length needs to be increased to 20 characters. At the same time, you see this nullable property here, it is set to yes. That means the name column now is an optional column. That means users can choose to provide a name or ignore it. But in my let's say going forward, we don't want that to happen. We want everyone to insert their name. So that means we'll have to make this not nullable, isn't it? So we have to make two changes. One, increase the length of the allowed names, plus make it not nullable so that everyone who inserts a record will insert a value for the name. So in order to do these two changes, what we do is we start with alter table unique test. This is the table on which we're going to do the change, right? And we're going to alter a column. And which column? The name column. So we are going to update the name column, and the data type is a varchar, and we want to make it 120, right? So I give here 120 directly. So that means now it will be changed from 100 to 120, and the property, the constraint that I'm now trying to have here is not nullable. Okay, and if I execute this, commands completed successfully. If I now do a Alt F1 on your unit test, you will notice that the ID column, the name column has a length of 120 characters after the change, after the modification, and on top of it, the nullable property is set to no. That means no null values are now allowed on the name field, on the name column. Okay, so this is how you modify an existing column, alter an existing column in your table. Now we also have a not null test table as well, right? Wherein we have the same name column, 100 characters, and it is set to nullable. But no, I want to change this as well. So what do? I run the same query, but this time I use the not null test table, and I say alter column name, and I set the data type to varchar 120 and the not null, right? So if I execute this, there you go, we get an error, right? And the error says cannot insert the value null into column name. What? We're trying to alter the column. Why is it saying we cannot insert the value null? This is something that you will have to remember. While altering a column, make sure that the data in the column clearly obeys the constraint or the rules that you are trying to apply. So if I'm trying to make a change of, let's say, I want to increase it to 100, and let's say somehow I have 100 characters as length, and I'm now decreasing it to 50. That means all the names in that column should have a length of less than or equal to 50. If there are names which are greater than 50, it won't work, because these are rules that we are applying, isn't it? Now, if the existing data does not obey those rules, these changes won't apply. So when I'm trying to apply a not null, it is saying we cannot insert null value. That is because if I show you the not null test table, we already have a couple of null values in the name column. We might wonder, okay, what about the unit test? In the unit test, we did not have any null value. That is the reason this went through fine. But with the not null test, we have these two rows with null names. So that is the reason when I try to make it not nullable, it doesn't work. So what do we do? In that case, we'll have to first treat these values, run some data treatment on them, either remove them or update them to anything that we wish to. Let's say we can update it to blank, to empty, right? But we'll have to take care of these nulls. For now, what I'm going to do is I'm going to delete these records. Okay, I'm deleting from the not null test where name is null. Okay, so I'll delete 2 rows. Now, if I show you the table, we do not have any null values in the name column. And now if I rerun this query, it should work. And if I run Alt F1 on the not null test, you will notice that the name column has now been extended to up to 120 characters, and it is not nullable anymore. Okay, so this is how you alter an existing column, but make sure that your data that is there in the column already obeys the rules on the particular column. Dropping, renaming columns are biggest risk. There is a method that you can use that goes by the name sp_rename, wherein you'll have to specify the old name, I guess, which is dbo.table_name.column_name. So this will be
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
This will be your old name, and then to what do you want to rename it, alter column name, and what is this object about. So this is a column, right, that we are trying to update. So I guess you'll have to use this technique to rename your objects. Okay, I'm not exactly sure because renaming is something that I have never done. I mean, in fact, I have not done it in a long time, because this is a strict no. Okay, I mean, when you start working on development, you will understand why this is a strict no in databases. It brings in a lot of issues, to be honest. But yeah, you in fact have an option where you can do it. So you can read more about SP rename online. But from what I know, this is how you do it. This is the old name. You can also rename your tables, columns, whatever you wish to. And this should be your new name. And this should be the object that you're trying to rename. So now if you're trying to rename a column, it will be a column here. If you're trying to rename a table, it should be a table here. Okay. So let's say if you want to rename a table, you would just do dbo.table name, and this should be the new table name. Okay, and this one should be a table. All right, so yeah, you can read more about SP rename to find more details about this, by the way. Okay, so you see, I cannot, I mean, for a few of you who are asking about the go statement, what's its use case, you see, I cannot run two SP renames one shot like this, one after the other. I can only do that when I have a go in between. Similarly, you see, these two are not going NL because you cannot execute two of them back to back. So you need to have a go statement in between to let SQL Server know that, okay, this is one query, execute it separately, and then execute this query separately. Okay. By the way, if you try running this also, it will throw you an error. Okay, I mean, now it has an error, but it will throw you a caution saying that be careful while you're changing your renaming your objects. Okay, I think if I look at this, okay, object name is the beginning. No, object name, new name, and the object type. Is it a column? Yeah, you can maybe read about it, this SPD name. Okay, let me close this one. It's better to write go statement regularly. Not unless you really need it. I mean, to make your query look a lot better, or to segregate your queries in parts, you can use it. That's a good thing. All right, let's now move on to the next topic for the day, which is about temporary tables. Now, what are temporary tables and when do we exactly need them? So what are the need of temporary tables? Let's say we have to move some data from the source to the destination, from a source table to a destination table. Now, let's say it is not a simple data movement. Okay, we would also want to transform, calculate, and aggregate some data out of that before we move it to the destination. Now, one thing that you need to remember is the longer that you stay connected to a table, the longer that your query stays connected to a table, that means the longer your query runs on a table, the query locks the table to a certain extent. So it prevents other users, other queries from accessing that table. So those queries, those users will have to wait until your query finishes on the table for them to access it. Depends on the operation, obviously. Okay, but especially when you're doing heavy operations, like you are pulling the data at the same time, transforming, aggregating, calculating the data, that is when your query will obviously take longer time. So your source table will be locked for a longer duration. And ultimately, all the other queries or users looking to access or retrieve data from that table will have to wait until your query finishes execution. And that is where temporary tables comes in. Okay, in order to make sure that our source tables are available all the time and not locked for an extensive duration, what we can do is with temporary tables in picture, or we can get the data from the source table, the raw data from the source without doing any transformation. We can get the raw data from the source into a temporary storage, which is a temporary table, and perform whatever aggregations, calculations we want to do on the temporary table. The temporary table is now your own play area, right? It's your own playground. You can take as much time as you want, utilize the entire table's resources. No one is going to complain because no one is accessing your temp table. That is your own table, right? So the positives are your source table is available all the time, and then your query can take as long as it wants to churn the data before it is moved to the destination, right? And these are called as temporary tables. These intermediate storages are referred to as temporary tables. These are temp storage units to help us store and transform the data intermediately from the source before it is moved to the destination. And where are these temp tables created? Although we request to create them on the database, but the moment SQL Server knows that it is a temp table, it creates them in the temp DB or the temp database, which is one of the system databases, if you remember. All right. Now, the advantages, as I already explained, the source and destination tables have complete availability, and we can create indexes. Indexes, we haven't studied about them. It's another very interesting concept. We'll talk about them later, definitely. But yeah, we can create indexes, constraints like a normal table inside the temp tables. Now we have two types of temp tables. One is a local temp table and the other is the global temporary table. So let's review the local temp table first. So in order for us to create a local temporary table, we say create table, very similar to how we create normal tables. And then we have a hash symbol in front of the table name. So the hash symbol in front of the table name lets SQL Server identify or recognize that this is a local temporary table. Okay, so local temporary tables are identified by a single hash in front of the table name, and then you can give any name that you wish to for your local temp table. You can give any name that justifies the purpose of its creation. Okay, now we can define what columns should this temp table have. So here, let me create this temp table. So the temp table is now created successfully, and I can insert records into temp tables exactly how we inserted records into normal physical tables. So you see 3 rows affected, and I can run a select star from the local temp table to see all the 3 records are now in the table. Okay, and if I want, I can also inner join it with other tables as per my need. Let me show you something other than this. So if I open up a new query window and run a select star on a new query window, you see it says invalid object name local temp table. What? We just created it here, isn't it? It's still active. And when I run it now also, it gives me the data. But why on earth does this query fail on the other query window? That is because of the scope of the local temp table. The scope of a local temp table is only in the session where it is created. So this is the session in where we have created the local temp table, isn't it? So it is only available in this particular session. So in order for me to access it outside the session, it's not possible. Okay, so that means the local temp table has no existence in this session. So that means I can create another local temp table with the same name on another session, which is this one. That means I can create a local temp table with the same name, but on a different session. See, here I'm inserting 2 records only. I inserted 2 records. So here, if you notice, it shows 2 records, but on this query window, the original one, we have 3 records inserted. So it shows 3 records. So that means I should have in the temp DB 2 tables with the same name. But again, SQL Server should have an internal mechanism to identify which table belongs to which session. So how does it identify it? Let's see the TempDB to understand it better. So here, if I go inside the TempDB and open it, you will find a section called temporary tables. And if I expand this, you will find two local temp tables with an encrypted name at the end of each. You see, both of them have encrypted name at the end of each. Now, this is because this is just to identify the temp tables for each session. Okay, the underscore and the encrypted name at the end lets SQL Server identify which table belongs to which query window. Now, I don't understand myself about how SQL Server identifies using this code, but my educated guess is it is using this encrypted name here to somehow identify which session the temp table belongs to. And whenever we run a select star, it appends that encrypted name in here, and then when it selects it, it gets that exact name, exact data from the temp table. Okay, so we can create n number of local temp tables with the same name in different sessions of the same instance. And when does it get dropped? You can either choose to drop the table manually, okay, or it gets dropped automatically once the session is closed. Now, SQL Server is very good at garbage cleaning. Okay, temporary tables, temporary objects are nothing but garbage to SQL Server. It is temporary, and hence it knows that it has no real use to be stored permanently. So whenever we close a session without cleaning off the garbage that we created, that is the local, that is the temp tables, obviously it will drop the temp tables automatically. So now if I close this session, one of the local temp tables will be dropped automatically. Let me show you. So here, if I don't save, and here if I go in and refresh the temporary tables, you see there is only one local temp table now. The other one has been dropped. All right, so this is how the local temp tables work. The scope is only in the single session where it is created, and we can create n number of local temp tables with the same name in different sessions. And as far as dropping is concerned, we can either manually drop them or it gets automatically dropped once the session is closed. Okay, the session where we created it is closed. Now, the global temp table, we created the exact same way. We say create table. For the global temp tables, we specify double hash in front of the name. Okay, and with this, SQL Server identifies that this is a global temporary table, and then you can give a name of your own choice. And in here we have two columns, again ID and name. And let's go ahead and create it. Simple to create. And then if I can insert records into this table. So I've inserted 3 records. Now if I run a select star from the table, you will notice that the data can be seen. But interestingly, if I open this on new query window, I can see the data in the other session as well. How is that possible? Because if I refresh the temporary tables again, you will notice that the global temp table does not really have an encrypted name. It has that only single name called the global temp table. So from anywhere that you access, it will access this table. So the global temporary table is available across all the sessions inside the same instance. The scope of a global temp table is across all the sessions and for all the users who have access to the database. Now again, we can either manually drop the temp table from any session that we want, or it gets dropped automatically once the parent session is closed. So we have created it here. So if I close this session, automatically the global temp table will go off. Now you might be wondering, okay, where do we use a local temp table and a global temporary table? A local temporary table is used when you only want the calculations to be done inside one single query or one single query window. But when you have, let's say, a requirement wherein we have a query, a set of queries that first calculates something, stores the data, that does the first set of calculations, aggregation, stores the data. And then there is a second set of queries that takes up that calculated data, processes it again, calculates some more things, and then goes to the third query where it again calculates it. That means we have multiple sets of queries that does perform multiple set of calculations, right? So obviously those will be run on different query windows. And these set of queries, think of these as stored procedures. Okay, we haven't discussed about it yet, but whenever we have such kind of an operation that we want to do, wherein the calculations are done across multiple stored procedures, that is when we go for global temp table, because we need to calculate the data in one, move the data to the next, then calculate it again use the data in the third, calculate some more things. So basically we need to carry over the data to multiple stored procedures. The only way that we can do it is by using global temporary tables. But when we need the data only in one single procedure, we are better off using a local temporary table. Topic: how many reads without any transforms can be simultaneously done on a SQL table? You can do as many as you want. That's the whole benefit of a a RDBMS. But the thing is, it depends on what kind of an operation you're doing. If you're talking only about reads, it also depends what kind of read are you doing. If it is a simple read, if you're doing some calculations, some aggregations, it all depends on that as well. So you can have multiple users connecting to the same table, but it really depends. Like for example, if you're doing an update and delete, other operations will, other queries will have to stop. Okay, they cannot access your table until your update or your delete is running. So it clearly depends on the type of query that you're performing. In select also, it is not always the same. It depends on what kind of a select you're doing. All right, let's move on to table variables now. Okay, so we have a concept of variables in SQL Server. Now, what are variables? Variables are memory storages or memory places that are stored, that are reserved to store a value. Okay, so when I declare a variable, again, like we have hash for temp tables, we specify at for variables. Okay, and ID is the name of the variable. The data type is integer. So that means I say create a variable called ID of data type integer and set the value of ID to 5, and then I can select the ID value as well. Okay, so let's start by declaring the variable first. Declared, that means we are creating a variable. There will be a memory space reserved for ID parameter to store an integer value because it is dependent on the type. Now we have created the variable, right? But when I try to set it, it throws an error saying we must declare the scalar variable ID. But we did it, isn't it? Let's say somehow it missed out on, and let's create it again. Okay, and again I try to set it, gives me the same error. The reason is because of the scope of a variable, right? Like we had scope for temp tables, for for global temp tables. We similarly have a scope for a table variable. That means for how long is it going to stay active in our system, and when is it going to be removed, right? So that is a scope. That is what a scope is all about. Now, a scope of a variable is only inside the query or the batch where it is created or initialized. That means if this is a query that I'm executing, right? So the ID variable is created, and right after the query is finished executing, this variable is wiped off, right? That is again the default property of SQL Server. Okay, so if I want to store a value to the variable and use it further, I'll have to execute all of them together. You see, now it works. Now, do we have the ID variable in memory right now? No, it isn't there because right after the query finished executing, the ID variable has been removed. Okay, so it is active only in the batch where we are executing, where we are creating and using it. Right after the query finishes execution, the ID variable again goes off. All right. Similarly, now where are these variables stored? These variables are stored in the RAM of the system. Okay. Unlike the temp tables, which are stored in the temp DB, these are stored in the RAM of the system. That means when I create a variable and store my data, it uses the space in my RAM of the system. Okay. Similarly, I can create a varchar variable as well to store a value in it. And then again, I can select it. The scope remains the same. So I need to execute all of them together. I can use a variable over and over again, but all the thing is, all those queries where I'm using the name variable should be executed together along with the declare, like this. Okay, if I'm using the ID multiple times, I can use them multiple times in the query, but all of these queries should be executed with the declare itself. All right. Now, where do we use a variable? Variables are something that we use when we want to store a particular value, like a discount percentage. A discount percentage, there is no point storing it in a table, right? It could be a very simple percentage that can be applied on all the products, and that need not be stored in a table. That is when we use a variable. Passing as input parameters into procedures or functions that we're going to talk about later, we are going to use variables for that reason as well. Okay, we'll see the usage where variables are used as and when we move forward. All right. On the same line, when we can create integer variable, varchar variable, we can also create table variable as well. Right. So here I can declare a table variable. I obviously starts with at, prefixed with at, and then I give a name to this table variable. You can give any name that you wish to. It should not be table variable only, and the type is a table, right? So this kind of a table is created slightly differently as compared to physical tables and temp tables. This is created a little differently. So we start with create and then the table variable name prefixed by at and then the table keyword, and then we continue with the columns, the data types, and we can insert into the table variable exactly how we insert into our other tables. Okay, and then we can select from it, but it's just that we need to execute all of them one shot. Okay, and right after the query finishes execution, again the table variable is also wiped off the RAM. Okay, table variable, this one is also created on the RAM. Okay, so the moment the query finishes execution, the table variable is wiped off. Okay, table variables, when do we use them? When we have, again, we need an intermediate storage to store some configuration related data. Configuration related data is usually small amount of data, right, in multiples of hundreds. Okay, so for example, a list of countries, list of counties, right? Let's say for a gender, we want to assign a gender code. For male, we want to assign it as M. For female, we want to assign it as F. That is when we use a table variable, because for smaller volume of data, table variables are the best, because as they are stored in the RAM, the reads and writes are faster when compared to the temporary tables. Okay, whereas when we have huge amount of data, temp tables are the ideal candidates, because we don't want to store a lot of data in the temp table variable, because it might take up a significant space on our RAM and hence cause a lot of our softwares installed to not function properly, because most of the softwares in our system use the RAM, isn't it? Now, if the table variable takes up a lot of space in the RAM, obviously the system might crash as well. So be very careful about how much of data you store into the table variable. But nevertheless, these are the fastest out of the available temporary storages. Okay. All right. So that is about a table variable. Let's talk about functions. Wonderful. Okay, so what are functions? Let me give you a use case first. Let's say we have multiple tables with first name, middle name, and last name columns. Okay, now most of the time when we are trying to retrieve the the data from the tables, we try to retrieve the full name. Okay, instead of retrieving the first, middle, and last name separately, we try to retrieve all of them together as a full name. Okay, but when I try to do that, when we try to do that, we will definitely have multiple different objects, multiple different places in our database where we would be having that exact logic to generate the full name by using first, middle, and last name. On top of that, let's say you're also generating the salutation in front of the name, you'd also want to use the marital status and the gender, because in order for you to identify if it is a Mr., a Mrs., or a Miss, you need to know the marital status and the gender of each individual. So now, in order for you to generate the full name with the salutation, you need a combination of the marital status, gender, first name, middle name, and last name all together, so you can generate it. Now, let's say you have this logic across 50, 60 different queries and objects inside your database. So now, uh, the problem starts when the business is requesting you to make a change on the way the full name is generated. Let's say they want the full name to be generated exactly how we name it, how we have it in our in our passport or in our visa application form. Ideally, in there you have your last name in the beginning. Okay, you have a Mr., Mrs., or a Miss, and then you have the last name in the beginning, comma, the first and the middle name. So in order for us to generate the full name in this particular um, uh, format, we will have to change the way we are generating the full name across all the 50, 60 different places. This is where the problem lies. And this can be resolved by applying that entire logic inside a function. So when we store the logic to generate the full name inside a function, there are multiple advantages. One, we can use the function wherever and whenever necessary. Okay, so whenever we want to generate the full name, all that we have to do is use this function. Instead of writing the entire logic all over again, we need to use this function. Second of all, in case there is any change requested, we can change it only inside the function, and automatically it'll reflect in all the different places where the function is used, because in there we are just calling the function, so automatically it'll start using the new logic going forward. Third, you don't have to test your changes over and over again. In the earlier scenario, if we changed it in 50, 60 different places, we had to test each and every component, each and every query after a change is done. But with function, as we are only changing one specific object, we just have to test the function once. And if the function works, obviously, in the rest of the places where we have used the function will automatically work fine. Right? So function is nothing but a database object which has a set of SQL statements that accepts input parameters and returns the output or the result. And at any point in time, a function will definitely return something. You cannot create a function that would not return you anything. Okay, a function is meant to do that. It is meant to accept input parameters and return the output by processing the input values. Now, the functions can return a scalar value or a table value as an output. When we say a scalar value, it is basically a single value. It can be yes, no, Dinesh, John, today, tomorrow's, Monday, Tuesday, anything which is a single value is called as a scalar value. Okay, so a function that returns a single value by processing the input parameters is called as a scalar valued function, and a function that processes the input parameters to return the output in the form of a table is referred to as a table valued function. Now, one thing that you need to remember very importantly is that we cannot use a function to perform DML operations on physical tables in the database. That means by using the physical tables inside the database, we cannot, we cannot use a function to insert, update, or delete data into the physical tables like the employee data of birth tables that we have created. We can never do that. Advantages, as we have already discussed about the reusability and the maintainability aspect of it. We can reuse it, and as well, we no longer have to maintain the same piece of code at multiple places.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Right. Okay, so now let's talk about the different types of functions that we have available with SQL Server. Right. The first one is the system-defined functions. The system-defined function are basically functions that are created by default by SQL Server the moment we create our database, right? So the moment we create our database, there are a bunch of functions that SQL Server gives to us by default. Okay, those kind of functions are managed by SQL Server. That means we can only use them. Okay, we cannot modify the way they work, or we cannot change anything in them. The only thing that we can do is to use them whenever necessary. Okay, that is the reason they're called as system defined functions, as they're created and managed by the system itself. User defined functions are popularly called as UDF, and let's say the number of functions that are provided by SQL Server is a lot. You don't get to use all of them on a day-to-day basis. So we are going to discuss about a few of the frequently used ones, but most of the time, any requirement that you have can be achieved. Most of the requirements that you have can be achieved using one or multiple system defined functions. Okay, but just in case you have a requirement that you cannot achieve by using multiple system defined functions, you can then go for a user defined function. You can create your own custom function in SQL Server and use it for your own benefit. Okay, and these are referred to as UDF, popularly called as UDF. Now, user-defined functions, we will talk about them later, but first let's talk about system-defined functions to begin with. System-defined functions are of two types, scalar functions and aggregate functions. Again, scalar functions, that means they return a single value as an output. Aggregate function as well returns a single value as an output, that is usually the aggregated value. Okay, so let's start by talking about the system-defined scalar valued functions. Okay, and to start off, let's talk a bit about the datetime functions. Right, so datetime functions are usually used when we want to build date range metrics. Okay, that means, let's say we are asked to extract the sales for the last year, or extract the employees who are born on or after the year 2000. Find the employees who have the date of birth in this particular month, in the current month, right? Find out the sales for the last year's first quarter. These are the requirements for which we need to use the datetime functions. Okay, we will talk about all of these use cases a little later, but first let's only go through the functions and understand what they do. I'm going to just do that. I'm going to explain you a bunch of functions and see what they do and how they work. And then I'll show you real-time use cases for a few of them. Okay, so let's first understand what each of the function does. Now, SQL Server has a lot of these functions, but I'm going to just explain you a few of them, handpicked few, which are used very frequently on a day-to-day basis. All right, so let's start with the getDate function. Now, how do we execute a function? We use select and the name of the function, and you see these brackets. This is always a part of the function when it is called, when it is executed. Okay, now inside the bracket is where we would be passing the input parameters. Now, as we discussed earlier, the functions can operate on none, one, or more input values. That means they can accept 0, 1, or more number of input values, but will definitely return a output value. So the getDate, as you can see, it does not accept any input values. Now, how do you know? If you open the bracket here, you see it just says get date, open bracket and close bracket. That means there's nothing in between here. I'll show you for other functions which needs input parameters. You will find it requesting you for the input parameters, but in here there's nothing inside the bracket, so you know that this function does not accept any input parameters. Now if I execute this, it would return me the current server date and time. That means if I am in India, I'm in the IST, my laptop is in the IST time zone, then it'll give me the Indian standard time as of now. Okay, so the get date gives us the current date and time of the server on which your SQL instance is hosted. So now that my SQL Server instance is hosted on the on the Indian Standard Time, you will get to see the Indian date and time, right? But whereas if you're in the US and if you execute get date on your system, you should be able to see the specific date and time zone that you are on right now. If you're in the EST, you will see the EST date and time. If you're in the CST, you will see the Central Standard Time. Okay, if you're in Europe, you will see the date and time for Europe. Okay, also we have a get UTC date. Now, what does the UTC date does? The UTC date will return us the date and time of the UTC, that is the Universal Time Coordinated or the Greenwich Mean Time, right? Greenwich Mean Time is basically a standard time zone that we use as a reference for all our rest of the time zones. Okay, like for example, India is 5.5 hours ahead of the GMT. Europe is 1 hour ahead of the GMT. Okay, so similarly, I think US is 10 hours behind a GMT or something. So basically, when we use the get UTC date, it's going to give us a standard date and time, which will be the same across any SQL server that you execute it on. It can be in the US, it can be in the UK, Europe, anywhere. It is going to give you the same date and time because we are now trying to specifically extract the date and time of a particular time zone, which is the reference time zone or the GMT. Right now, India, as I said, is 5.5 hours ahead of it. So if you see now, it is 4:25 in the afternoon in GMT on the same day, but in India it is 9:55, exactly 5.5 hours ahead of the GMT. Now you might be wondering, okay, where do we use the get date and the get UTC date? Right, so the get UTC date is let's say we have an application that only runs in a single country as of now. In that case, we can use a get date. Okay, let's say we are working on a sales application, we can use get date to be so that we can store on the sales date based on that particular time zone. But let's say if we have our application running on multiple different countries, in that case, we need to use the get UTC date, because if you don't use it, let's say we have sales happening in India, the sales date will be stored from the IST based on the IST reference. When someone shops from US, it'll store based on the CST or the EST reference. When someone shops from Europe, it'll store the European Standard Time, and so on, right? So you will have discrepancies in your date and time, right? Because it'll be storing inconsistent date and time zones data. So when you use the get UTC date, it kind of standardizes everything. It kind of makes it consistent. So that is where the get UTC date is a lot handy when your application is shared across multiple different countries. Next, if I want to add a couple of days to today's date or subtract a couple of days from today's date, I can easily do a +2 and a -2. You have already seen this in one of the earlier classes, isn't it? So here, if I execute it, +2 will add 2 days to the current date and time. So today is 7th of August, so it makes it 9th of August 2021. And if I subtract 2 days, it becomes 5th of August 2021. Today is 7th, so if I subtract 2 days, it will be 5th of August. Now, this is how we can add and subtract days from the date, okay, from the date time. But if I want to, let's say, add hours, for example. That is when I use the date add function. Now the date add function, if you notice, has accepts some input parameters. How do I know it? If I open the bracket here, you see the first thing that it asks for is the interval. So that means I have to say for what interval do I have to increment or decrement the values. So here I increment the values for the R. And then what is the increment value? The increment value is 2. That means I want to add 2 hours. All right. I want to add 2 hours to my current date. Okay. And this will, when executed, will add 2 hours to the current date and time. So you see, it makes it 7th of August 2021 at 23:59 in the day. 23:59, now it is 21:59, so it makes it 23:59 in the day. Similarly, if I want to subtract 2 hours, instead of the increment value, I just pass a -2. Okay, and this will get me 7th of August 2021, but the time is now reduced to 7:59 in the evening, right, which is 19:59. Similarly, if I want to add or subtract years or add month, I can use the interval as year and month and add 2, subtract 2, or add 2 to the month. If I execute this, the first one is adding 2 years, right? So this becomes, everything is the same except for the year. You see, the year has now gone up to 2023. Second one is subtracting 2 years, so it becomes 2019. And the last one is to add 2 dates to the 2 months to the date, so it becomes 7th of October 2021. Okay, so this one, the date add function helps us in adding adding some numbers or values to each of the date parts, right? Each of the intervals, I must say. Now, if I want to extract the parts of a date, for example, if I want to get the year of the current date, so I would say year of, and it is expecting a date time so that it can return an integer. That means I need to provide a date time here so that it can return the year of the date and time. Okay, and this will give me 2021 because I'm saying year of the current date, and the current date is 7th of August 2021. So the year of 7th of August 2021 is 2021. Similarly, if I want to get the month of the current date, it'll give me the current month, which is August. Okay, we'll be seeing. Okay, we'll just wait with me for a few more minutes and you will see the use cases of these specific functions. Next is the date part, right? So in order for us to get the year and the month, it is easy. We can use year and the month function. But let's say I want to get the day, the hour, the minute, or the second. For that, I need to use the date part function. Now, the date part function, if you see, accepts 2 input parameters. One is the interval and the other is the date. So when I say interval, that means for what interval do you want to extract your value? So I say I want the day from the current date. And if I execute this, it gives me 7. So today is the 7th day of the month, isn't it? Similarly, I can extract the hour, minute, year, and month. So year and month we can extract using the functions itself, or I can pass it in the date part function as well. And if executed together, I mean, I'll get the hour to start off with, which is 22. The minute is 2, and the year is 2021. Month is, which is 8. All right. Now, what about subtracting dates? Let's say I want to get the difference between 2 dates. Again, I cannot do directly date 1 minus date 2. It's not going to work, right? Because that has a certain amount of calculations, right? Based on the date of the month, based on the date of the year, the calculation will have to differ. So that is when SQL Server makes it very convenient for us by giving us function called as date diff. Now the date diff will accept again multiple parameters, the first being the interval. That means in what interval do you want the difference between the dates in? So I say, okay, I need the difference in days. Now, between what dates? This will be the starting date, right? The first value is the starting date. Okay. And after the comma, the third parameter is the ending date. That means it should always be ending date minus the starting date. So the starting date will be subtracted from the ending date. So it should be end date minus the start date. And that is that after subtraction, I should get the interval in days. So here I'm using some hard-coded values. Get date plus 4 will be 11th of August, right? Because today is 7th of August, get date plus 4 will be 11th of August. 11th of August, subtract 7th of August from it, right? 11th of August minus 7th of August will be 4 days, right? So when I get the difference in days, it'll get me 4. Again, we'll see the real use case of date diff, okay? Just for you to understand how the date diff function works, I'm giving you a few examples here. Similarly, if I want to get the difference in hours, okay, between the same two dates, obviously it'll be 4 days times 24 should be the difference, isn't it? So 4 times 24 should be 96. If I want to get the difference in minutes between the same dates again, it should be 4 times, which is 4 days times 24 hours times 60 minutes, which should be around 5,760. There you go. So this is how you can efficiently subtract your dates, okay? And at the same time, get the interval in, get the difference in specific intervals as per your request, okay? Now, let's get to some use cases, okay? So we know that we have two tables called the employee and the employee date of birth, and we can join them together to get the date of birth of each of the employees, correct? Now let's say we are asked to extract the age of each of the employee. Now, storing the age in a table is not a good idea because it is going to change with every year that it progresses, right? Today, I might be, let's say 30, the next year on 2022, I will be 31. Okay, so the date of birth, the age of an employee is definitely going to change. So it's always better that we calculate it on the fly. And the best way to calculate your age is by using a date diff function. I remember someone had a question, how do we derive a column on the fly, which is not stored in the table? That is something that I'm going to show you right now. So earlier we used to select only star. If you want to select some other column, just put a comma in here, like as if it is a different column, and then use the transformation that you want. So I say I need the date difference in years. This is the interval, you remember? Between the current date, which is today, and the date of birth of the employee. So I directly pass the column date of birth here, right? So what it will do, this date diff function will now get me the difference between the current date and the employee's date of birth, and it will show the difference in years with the column name age in years. And if I execute this, this is what you would see. So employees who are born in 2002 has an age of 2019. Someone who is born in 2001 will have an age of 20. Someone who is born in 1999 will have an age of 22, and so on. At the same time, if you're also requested to get the year of birth of each of the employee, you can get year of the date of birth again as year of birth. Okay, so this is how you will get the year of birth for each of the employees as well. So this is how you can derive your age and your year of birth dynamically by using functions and your existing date of births. What if, okay, this is during the select, what if we are asked to filter based on the year? Let's say we are asked to find all the employees who are born after, on and after the year 2000. Again, very simple. It's a select star from the employee date of birth, where the year of the employee date of birth is greater than equal to 2000. Okay, so it will give us all the employees who are born on or after the year 2000. You see, all of these are born on or after the year 2000. Now, if you want to extract the sales for previous year first quarter, right? First quarter of previous year. So how do you do it? So here, I would say select star from the sales table where the year of order date, we are looking for the previous year, right? Let's break it into two. Let's first talk about the previous year and then we'll talk about the first quarter. Okay, so for the previous year, we would just say select star from sales table where the order date, the year of order date is equal to 2020, right? Because now it is 2021, we'll have to get it for 2020. But do you think this is a feasible solution? This is a scalable solution? Not really. I mean, this might work in this, this logic might work for this particular year until the end of 2021, but will never work once the year changes to 2022. Because in 2022 also, it will give you the sales data for 2021. Sorry, 2020, which is not fair because we are trying to get the previous year, right? So it's always better to make it dynamic. And how can we make it dynamic? By using the year function on the current date, because the get date gives us the current date and time. And if you apply the year function on top of it, we will get the current year. So this will give us 2021, fair enough. But in order to get the previous year, all that we have to do is -1. So it will get us 2021 -1, which will be 2020. Now, if we run this query in the year 2025, it will get year of the current date, which will be on 2025, right? So 2025 -1, it'll automatically pick up the sales for the year 2024. Now coming to the second part of the requirement, first quarter. The first quarter, to filter on the first quarter, we can say and month of the order date in 1, 2, or 3. Now, is the definition of first quarter going to ever change? No. I mean, the first quarter is always going to be the first 3 months. So if I say month of order date in 1, 2, and 3, it'll get me the previous year's first quarter sales data. I cannot execute it right now because I don't have a sales table. I'm sorry for that. But this is what will get you your sales for the previous year's first quarter every time you run it. You run it in the year 2025, you run it in the year 2030. Anytime you run this, it'll get you the previous year's first quarter sales data. Let's say we are also asked to figure out people born between March and September. Okay, now again, pretty easy to implement. Now that you have understood the functions, select star from employee date of birth. We say where the month of date of birth between 3 and 9, right? 3 and 9 is basically March and September. So here I get about 5 records, 5 employees who are born between March and September. Make sense? Now, let's say there is another requirement to identify all employees who have date of birth in the current month. So let's say we want to find out people who have birthdays this month, employees who have birthdays this month. All that we have to do is we need to add a where condition, say where the month of the date of birth is equal to the month of the current date. So again, I could have just put 8 here. It would have worked. It would have definitely worked. It could have given me the employee who was born in the August month. But every month that I want to run this, I'll have to change this manually. Instead, the better option is to just use it dynamically to get the month of the current date. So if you run it in August, you're going to get the employees born in the August month. If you run this in September, you'll get the employees born in month of September. See, now when I run it, I get to know that the employee ID 2 is born on this particular month, which is August. All right, let's talk about a few of the string functions that we have in SQL Server. The first one that we have is the upper function, upper and lower function, which helps us get the input string in uppercase or lowercase. So here, if I execute both of them, I get the first one in uppercase and the second one in lowercase. Similarly, if I want to get the length of the values, length of the string value, I would just say length of Dinesh, and it would give me the length of my name, which is 6. Now let's say I add a few numbers at the end, and if I execute this, it would give me 9. So basically, there are in total 9 alphanumeric characters in here. So the length considers both numbers and characters. And not only that, if I add 3 spaces, it will also add in the spaces to make it up to 12 characters, right? So I have the length function that counts the spaces, the alphabets, and the numbers, okay? Characters and the numbers, I'm sorry. Now for string values, you can also append them like this. You can concatenate them together by using the plus operator, right? So in numbers, when we use plus, it sums them up. But in this case, if we use the plus, it will just place them right next to each other. So here I'm saying Dinesh, then have a space in between, and then Kumar, okay? So if this is executed, I get Dinesh Kumar separated by a space. Now, if we have something called as a left and right function that helps us fetch the specified number of characters from the left side of the string. So if I say Dinesh comma 2, it will fetch 2 characters from the left of the string. And when I say right Dinesh and 4, it will fetch 4 characters from the right side of the string. So if I execute both, you will see DI as the first output because it fetches 2 characters from the left of the string. From the right, it fetches the 4 characters from the right. So it fetches NESH. Now, all that you need to know is the purpose of the function. Okay, how many input parameters it should take is easy. You just have to open the bracket and you should see it in the IntelliSense. Okay, IntelliSense is basically recommendations that are given by SQL Server for easier development. Okay, so you know that it takes 2 parameters, expression and the number of characters. So basically I'll have to pass the expression, the string, and the number of characters from the left side of my string, right? And then I have a trim function available with SQL Server. This is introduced newly in 2019. Okay, in 2017 also you might not find it, is what I feel, because until then we had ltrim and rtrim, but now we have a trim function that does both the tasks of both ltrim and rtrim. It helps us in eliminating the spaces from the beginning and the end of the string. Okay, so we have a bunch of spaces in the beginning and at the end of the string here that you can see, it'll eliminate all of them using the trim function. But the spaces in between, it won't touch them. Okay, so if I execute this, it gets me Dinesh Kumar, and if I paste it here, you will notice that there are no spaces in the beginning or in the end. All the spaces in between are retained. Then we have a replace function available with SQL Server that helps us replace a part of the string, find a part of the string and replace it with something else. So in here, I'm trying to find from Dinesh the entire string. I'm saying SQL Server to find NES and replace with X as output. Okay, so if I execute this, you would get DIXH. DI, NES is replaced with X, so DIX and H. So the replace function will help you replace a part of your string with something else, whatever you find, whatever it finds in the replacement expression. There is also a reverse function that helps you reverse a given text. So here, if you see, Dinesh has been reversed to, I don't know what in the world is that, but yeah, I think it's reversed my name. Then we have a substring function, again, a very handy function. We'll talk about a use case, okay? Right after this, I'm going to give you a use case by combining multiple of these functions. The substring function helps us extract a part of our string. Okay, so from Dinesh, let me show you what input parameters it has. The first one is the expression. That means from what string do you want to fetch a part of your string, a part of that string. Next is the starting position. That means from where do you want to start fetching your substring, from what position. And then how many characters, what is the length of string that you want to fetch. So that means here I'm saying from Dinesh, starting from the third position, which is N, fetch 3 characters. So that means it should fetch NES, correct? So let's see if it works the way we discussed. Yes, NES. Now, if I put 3,10, that means from the third position, fetch 10 characters. But sadly, it has only 4. So in this case, it will only fetch NESH and that's it. Okay. So if you have a higher value here, that means it will only fetch till the end of the string. All right. Next up is the char index function that helps us locate a character in a particular given input string. So I'm saying here find I in Dinesh, and if I run this, it would show me the second position. So that means I can be found in the second position of Dinesh. Now, just to show you an example, where can we use a bunch of these functions? Let's say I have email address that is given to me. Okay, let's say this as dinesh@microsoft.com, and I want to extract the domain name out of this email address. The domain name is nothing but the email address or the.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Text after the @ symbol, isn't it? So in this particular case, Microsoft.com is the domain name. So in order to approach this, okay, obviously it's going to be a little complicated, but if you approach it step by step, it's going to be a lot easier. So first of all, we need to select it. So obviously we'll start with the select, and then we are sure that we need to fetch a part of the string, right? So we need to use the substring at any cost. And from where do we want to fetch a part of the string? From the email address, right? The email variable. And now coming to the second parameter. The second parameter is the starting position. So the starting position is here. Now, I cannot use Microsoft like M as the starting position because some domain names could be as google.com, right? Or gmail.com. Those won't work. So I cannot take the reference of M. I need to take the reference of @ because @ will be present in all email addresses right before the domain name. We need to make it as dynamic and as consistent as possible. So first I need to find out the location of @. So what do? I use char index of @ comma email. So that means I want to find the position of the @ in the email address, but that means we will get this location. So the substring will be started will start fetching from here, including that. But we don't need the @ right? We need to fetch everything that's there right after @. So what we need to do, I need to add a +1 here. So now it will start fetching from not the @ position, but from right after @, which is this. So it doesn't matter what character is here, but it will start fetching from that character. Now, coming to the third and important part, which is the number of characters. That's the third parameter, isn't it? Let me show you. So here, if you see, the first is the expression, second is starting position, third is length. So how do we know what length of characters should be fetched? I cannot say it as 100. What if there is a domain name that is greater than 100 characters? Not practically possible, but what if? So we need to find out a more robust way of fetching till the end of the string. So in that case, what we can do is to play a safe bet. I can say use the length of the email. Now, the length of the email will always be greater than the domain name, isn't it? And as we discussed earlier, if the value is greater than the number of characters present, then it will obviously get us till the end of the string. So to play safe, we can use the length of email. Okay. This way, we will never run into the risk of having a bigger domain name. Because if we add 100 here, any domain name which has 101 characters will fail. If we add 1000 here, any domain name that has more than 1000 characters will fail, and so on. With the length of email, we can guarantee that it will never fail, because bigger the domain name, bigger will be your email address. And with this together, we will get the domain name. Now, does it work only for this? Ideally, it should not. Our expectation is that it should work for all the addresses. People my email, and let's say this one is google.com. I have changed the length significantly, and there you go, you get google.com. So it should work on all your email addresses. There you go. Okay, if I do this A and execute it, you see? So this is how you should be building and approaching your problem statements. Okay, break it down into simple concepts and you should be able to achieve it. What might look complicated in the first place, let's say I showed you this in the first place, you'd have been hell confused. But if you approach it in a systematic manner, it is the easiest that you can find. Okay, length of email seems dynamic. Exactly my point. Length of email is what we have used so that we never run out of the number of characters. Now on the same lines, okay, on the same lines, if I want to get, let's say, the first part, the username of the email address, which is this. Username should be again simple, substring of email. Okay, this is the email name, that is the username, and this is the domain name, right? So I have the email. From the email, the starting position is 0 because I need the username. So it should start from here and until where? Until the until here. So how do I know how many characters are here? I need to take the length of email, that is this entire length, minus I find the position of at -1. So until here, until h. So I'm saying from the length, entire length, subtract these many characters. Obviously, I should have these many number of characters, right? That is what I'm doing here. Length of email minus the at symbol previous to the at symbol, which is until here. So if I subtract everything, then I'll obviously be left with Dinesh. So if I execute this, you see sorry, did I make a mistake somewhere? Email and then 0. From the 0 position, length of email is how much? Okay, let me see. Length of email, select the length of email is 19 and oh, no, wait a second. I think I can make it easier. So how many number of characters, if I get the position, oh, why is there a length of email minus? If I get the position, let me see here. Oh, yes. This was easier. I don't know why I complicated it. Okay, so here to get the email username, it's easy. We just use the email from 0 position to how many characters? If I find the length of this, let's say the length of this is 5, that means I'll have to get till the 5th character. Simple. So I say find the position of at. So let's say if I change it to DIPU, I should now get DIPU and Microsoft.com. So irrespective of whatever changes, it should work. See, Dipu and Google.com. Okay, I have a table, employee table, and in that I have 2 columns, ID and email address, and I insert a bunch of email addresses into the table. Let's say I go ahead and do this. And then while selecting from the employee table, I want to select the ID, the employee address, and the domain name as well as the user name. Okay, so in this case, what I would do is I would pass, instead of the variable, I would just pass the column. That's it. And here, if I execute this query, I got this queries from above, guys. Okay, I've not written it again. I got these queries, but instead of using the variable, what I did was I used the column. That's it. And if I execute this, you see, I get the domain name here and the username here, brilliantly separated from each other. Interesting. So take as many values as you want, play around with these functions. I mean, like how we did it right now. Come across requirements and try to fix them up. Okay. All right, so let's say I have Dinesh and Kumar to be appended together. I use a plus symbol here. So this, what it to do is the plus symbol between 2 strings, the plus operator between 2 strings will help us concatenate 2 names. Okay. Also, if I want to, let's say, add 2 numbers, right? Let's say I have 2 numbers, 21 and 21, and if I use a plus operator between them, as these are numbers, it will try to sum them up. Okay, so if you see here, the sum of both of them is 42. That's fair enough. Now, if I have 21 in single quotes and the other 21 in single quotes, what do you think would be the output? The output for this would be 21, 21. Okay, 21, 21, because it is considered as a string now. But in instances where we would want to add Dinesh to 21 directly, this would throw an error. Conversion failed when converting varchar value to varchar value Dinesh to data type int. And absolutely understandable, because we are trying to concatenate a string value to a number. Now you might be wondering, okay, in what scenario would we do this? Let's say we have address line 1, address line 2, address line 3, state, county, and the state, county, and the pin code, right? The pin code, the postal code, or the zip code. These are usually numbers, isn't it? So that means the data type would be integer. So if the data type is an integer, and if we are asked to generate an employee report with the entire address, so we'll have to add up the address line 1, address line 2, address line 3, state, county, and zip code. Now all of these columns are in string except for the zip code. The zip code is in integer values. All right. So how do we tackle that situation? How do we add the zip code to the entire address is the question. That is where we have the cast and the convert function, right? The cast and the convert function helps us convert a given value to another data type. Now, obviously, we cannot convert Dinesh to integer, right? So we use the cast and convert to convert a value into a specific data type of our own choice. For example, if I have the zip code to be added to the rest of the address together, that is when we will be casting the zip code as varchar or converting varchar for the zip code. Right now, both of these works exactly the same way. They help us convert a value to a specific data type. Now you can see that both of them can be concatenated together or seen merged together, right? But is there a difference between the cast and the convert? The only difference is cast is more of a standard SQL function. That means you can find them in all the RDBMSs available. That is a SQL Server, Oracle, Teradata, PostgreSQL, and other RDBMSs. Whereas convert is something that is specific to SQL Server itself. All right. The convert function here is specific to SQL Server itself. Now we have another function called the isNull function that helps us pass two values as input. All right, see, the first value that I'm passing is Dinesh, and the second value is the first value is null. All right, so here if I execute this one, it gives me Dinesh back. Now Dinesh is returned because the purpose of isNull is to retrieve the first not null value in this particular, in the provided values, in the provided input values. All right, so the isNull function will return the first not null value out of these two. So obviously Dinesh is not a null, so that means Dinesh is returned here. If let's say Dinesh is null, if say the first value is null, then the second value would be displayed. Okay, so here execute. Now you can see that it shows the first value is null. Now, in what scenarios can we use this isNull function? Let's say we have the employee table, which has employee ID, first name, office phone, home phone, and we are asked to generate a report that will have the employee IDs, the first name, and phone number. Okay, so we are going to have only one phone number column in the extract. But what do we have in our table? We have two columns, office phone and home phone. So how do we manage this? How do we get only one column out of this? So in such a scenario, we need to prioritize our columns. We need to say which column should we look into first. We use the isNull function and we first pass the office phone parameter. Now it will display the office phone if it has a value for a particular employee. If the office phone is null, that means we do not have a value for the office phone for a particular employee, that is when the home phone would be shown, would be displayed as the phone number itself. So for an employee, it would give the preference to the office phone, and once the office phone is null, I mean, if it is a value, fair enough. If it does not have a value, that is when it will use the home phone. It'll select the home phone itself. All right, I don't have have these two columns, so I cannot execute this query, but hope you understand the purpose of the is null column now. This is when you have two columns which you want to prioritize. Okay, so if the first column is null, it will display the second column. Also, I give you the example of cast and convert. If you remember, let's say we want to get the employee ID and the complete address. Now, to get the complete address, we need to append address, city, state, and the pin code. Now, the pin code, assume that it's an integer, because pin codes are usually pin code, zip code, postal code, usually are numbers. So let's say the pin code is a integer column and these are varchar columns, obviously. So you cannot append them using a plus operator directly. So you have to cast or convert the pin code to a varchar data type. Okay, and this, when executed, would give the employee ID and the complete address itself. So this is how we use the is null and the cast and convert whenever necessary. Now, there is another very interesting thing about the null values, wherein, let's say, for example, let's use the unit test table. Now, what do we have here? We have two records in here, that is one Dinesh and two John, right? The third one is null and John. Now, if I want to see, let's say, the detail about ID1, I would do ID is equal to 1. And this would give me, this would return me the, this would return me the details for ID1. If I say ID is equal to 2, then this would give me ID is equal to the details for ID is equal to 2. But when I do ID is equal to null, that is when this will not return any record, because nulls cannot be compared in SQL Server using any operator that you are wishing for. Right? So in order to retrieve the null records, we need to use the is null. And this, when executed, would give us the null record itself. Okay. Now, let's say I want to compare the null value for a range of values. Like, let's say I want to compare if it is less than or greater than. Now, obviously, nulls can never be compared. So obviously, it won't work for a less than, neither for a greater than, right? So in that case, what do we do? In that scenario, we use the is null condition. If you remember the is null condition, we say if the ID is null, then use it as 0, then consider it as 0 on the fly. Okay, if the ID value is 0, then ID value is null, then consider 0. What if ID has a value, let's say 1 or 2 or 3 or 5 or something? Then it will consider it as 5. Only when the ID value is 0, then it will consider it to be, only when the ID value is null, it will consider it to be 0. Okay, and now what happens is, whenever we are running this comparison, we execute this comparison in the where condition and execute this, I get the null record as well. You see, when I say less than 2, I get the null record as well. All right. So this null is being retrieved only because while comparing on the fly, this null was treated as 0, and 0 is obviously less than 2. So if I do a greater than 2 or greater than equal to 2, I won't get any data. I won't get the null record. In fact, I would get it, but I'll get the details of 2. Okay, so this is how you can play around with your null values while you're trying to retrieve your data. So whenever we have a null in the ID, it cannot be compared using a equal to. So we used is null, right? But whenever we have, but the is null is very similar to equal to null. But what if we are trying to compare with a less than or a greater than? Now for less than, greater than, we cannot use is null, right? So in that case, we use the is null function. Now the is null function's purpose is to retrieve the first not null value. So if the ID, let's say, has a value of 5, then this will return 5. And 5, is it greater than or equal to 2? Yes, it is. So it will return the details about 5 here. But let's say the ID is null. Then what will happen? when the ID is null, it will consider it to be 0. It will now no longer consider the null to be a null value. During the comparison, it will consider the null to be 0 and then compare if 0 is greater than or equal to 2. And if it is the case, then it will retrieve the record, but 0 is not greater than or equal to 2. So that is how we use the isNull function to filter the null values when it is a less than or greater than operator. Next up, we have aggregate functions. Aggregate functions basically help us in aggregating the data. That means if you want to get the max, the min, the average, right, or the sum, that is when we are available by default in the system. So if I want to get the maximum of salary, let's say from the employee table, I would just say select max of salary as maximum salary from the employee table, and this one, if executed, will give me 5,000, right? So 5,000 is the maximum of salary from the employee table. Now if I just filter and say where address is equal to India, you would get 4,500. Why? Because before the aggregation, the filter is applied. So that means we first get the records where address is India, we first get the employees where address is equal to India, and then find the maximum salary out of it. If we want to get the minimum salary, we just switch it to MIN function, and this would give us the minimum salary from the employee table, which is 1,000. If I want the average, I would use the AVG function, and AVG is nothing but sum of salary divided by the count of employees, isn't it? So these two would retrieve us the exact same output. If you notice, both of them give us 3214 back. Why would we need to compare null with greater than less than operator? Sometimes you might also want to factor in, see, basically, let's say we have 100 records in the table. Now, if you do less than 50, you should get 49 records. And if you do greater than equal to 50, you should get 51 records. Am I correct? Less than 50 will give you 1 till 49, because less than 50 is 1 till 49. So you should get 49. But when you do greater than equal to 50, then you should get 51 records, because it will also include the 50 as well. Now, one of the purposes of extracting data is to ensure that you have all the records in your table that can be fetched using your where clause. Now, let's say while retrieving less than 50, you get 45 records, and while you fetch greater than equal to 50, you get 42 records, just random numbers. Now, what could have forced for the records to get missed? Because when we see the count of the table has a total of 100 records. But why is it missing on, let's say, 15 or 17 records end of the day? It is because they are null. So null doesn't mean null in a column, null in the ID column, that doesn't mean they do not have any existence. They still have existence. The ID could be null, but the rest of the columns might have values. So that is when extracting null values are also important in your queries. Because if you leave them out, you might leave out a chunk of your data in the table unextracted and unaccounted for. So it's always, whenever you are running a condition on a nullable field, make sure you use the isNull condition so that you can retrieve all the data from the table. Because if you don't use the isNull, then you will definitely miss on the null records. All right, okay, so let's move on now to the user-defined functions. Okay, now user-defined functions, as I explained you earlier yesterday, whenever we have a requirement that cannot be accomplished using a bunch of system-defined functions, that is when we go for user-defined functions. That means we build our own custom functions. Now, what are the different types of user-defined functions? We have scalar valued functions and table valued functions. Scalar valued functions will return a scalar value as an output. Table valued function will return a table as an output. Now, table valued functions are further subdivided into two types. One is the inline or single line table valued function, and the other is the multi-line or multi-statement table valued function. Okay, now inline or single line means the body of the function only has a single SQL statement. All right, but a multi-line or multi-statement table valued function means it has multiple statements in its body. Okay, so let's start with a scalar valued function and then we'll slowly move into table valued function, right? So how do we create a scalar valued function, scalar valued user defined function? We say create or alter function. That means if the function exists, if the function doesn't exist at all, then create it. If it exists already, then alter it. Now, prior to 2019, okay, prior to 2019, we had to check if the function existed, drop it, and then create the new logic for our function. Whenever we are trying to modify it, what we do, we drop and create it afresh if it exists. If it doesn't exist, then it will automatically create it. We used to write a condition for that. But from 2019 onwards, SQL Server has made it a lot easier, and it has taken up the responsibility to check the existence of the function upon itself. So we just have to say create or alter, and what they would do is SQL Server automatically will check if the function doesn't exist, it will create it. If it already exists in the server, then it will alter it. So we say create or alter function, and we give a name to the function. Now, whenever you're naming any objects inside SQL Server, except for tables, make sure you prefix it with something. Like here, I am prefixing it with fn underscore. Now, it's always a good practice because whenever I see the name, from the look of it itself, I can tell that this is a function. And then I say get employee full name. Now, this is a name that this is the original name of the function that I provide that justifies the purpose of the function, the existence of this function, right? So basically, if I for every function, fn underscore is a must. I mean, up to you. You can give it any thing that you want. You can say UFN as well. UFN is user function. I mean, up to you, but make sure you prefix it and put the prefixes consistently across all the functions that you are creating. Now here, the rest will be your name, but give a more meaningful name so that from the look of it itself, you can tell what exactly does the function do. Now, as part of this function, we are going to accomplish a very easy requirement. Okay, but the whole point is you need to understand the basic working feature of a function, and then you can implement any complicated logic that you want in here. So here, let's say we are trying to get the full name out of the input parameters. Now, if from the functions earlier, we have seen that functions accept multiple input parameters, like the isNull accepts multiple input parameters here. Similarly, our function also might need input parameters. That is where we provide parameters which are nothing but variables. So we don't have to declare it here. As we declare it inside the brackets, it is automatically assumed that it should be created as parameters. So the first name and last name are the two parameters that will be necessary to call this function. Okay, and both of them have 50 characters each as the limit, right? Now, very important, we need to say what is this function going to return, right? So I'm saying this function that we have here is going to return a output of varchar data type. So the output of this function would be a varchar data type of 101 characters in length. How come 101? Because 50 for the first name, 50 for the last name, that makes it 100 and a space in between. Obviously, you'll have a space in between first and last name, isn't it? Now that brings it up to 101 characters. So we say returns varchar 101 as begin. Now this is a part of the syntax. So every time you create a function, you need to go this particular way. Okay, this is especially for a scalar valued user defined function. And then the user will pass these two as input parameters. Now, how is this going to be processed to return the full name as output, we say return, and in the bracket, we try to trim the first name to trim off any spaces that might be there, leading or trailing, and then append a plus, a space in between, because we don't want to put the first name and last name together, because then it'll be a lot confusing, right? So first name and then a space and then the last name. Okay, and here if I execute this, so this function is now created, and if I do a alt F1, you would get the function name in here, and then the type is a scalar function, right? Because we created a scalar valued function, isn't it? And this has one single parameter as in two parameters as input, as you can see from the param model. So the param model, when it is greater than 1, it means input parameters. If it is 0, that means output parameter. So the output parameter is 101 characters in length.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Okay, so this is how we created the function. This is just the creation of the function. Now, where can we locate the function once it is created? Inside the databases, we go to our database, Intellipaat 25th July, and you can go to programmability, and in here you will have functions, scalar valued functions. Okay, so inside the databases, programmability, functions, scalar valued functions, here we will find it, and you can see that the function is created in the DBO schema. Correct? Now, how do we call it? How do we execute the function? As we have been doing until now, we just say select, and then we pass the name of the function, and in the bracket the input parameter. Correct? So in here as well, let's try to do the same. So here I say select the name of the function, and I pass two input parameters, because we need two input parameters, that is the first name and the last name, and this is just the alias, so I want to see it as full name. And also I'm executing the function one more time with Dinesh and Kumar as the two names as full name again, and if these two queries are executed, whoops, we get an error that says is not a recognized function name. That is weird, given the fact that we just created the function. Now, what has gone wrong in here? Now, whenever we say select and the function name followed by the parameters, it looks for this function in the list of system defined functions. Okay, it looks for this function in the list of system defined functions, and if it and obviously it won't find it because it's not a system defined function, it's a user defined function. So in order for us to force the SQL server to look into the list of system user defined functions, we will have to specify explicitly the DBO schema. Okay, the schema name needs to be mandatorily specified for the user defined scalar valued function, so as to ensure that the optimizer tries to look into the list of user defined functions and not into the system defined functions. And if this one is executed, you would get, now we get the output. One is John Smith, the other is Dinesh Kumar. So this is how we get the output after executing the functions. So this is how we create and use the function. Now let's try to create another simple function which will add two numbers. Again, the same format, create an alter function, fn underscore add numbers. It will accept two numbers as input parameters. Okay, and this will return integer, because obviously these two are numbers, integer numbers. So obviously if we pass we will have to pass numbers to it, and the sum will also be a number, so it returns an integer this time, and as begin. And here in the return section, I say number one is null, number one is 0. That means if the number one is null, then consider it to be 0, else it will use the number one itself, and else the number 2. All right, the number 2 will be again, if it is null, it will be set to 0 here. Okay, so here let's Let's execute this. So commands completed successfully again. And here, if I try to run these functions, again, it's exactly the same. Select dbo dot the name of the function. And I have three examples here. Let's execute all of the three. The first one is straightforward. 1 and 2 gives us 3. Second is 10 and 15 gives us 25. Now for 10 and null, if you notice, whenever it is null, we add a number. Let me show you something. So if I say select 10 plus null, it'll always give us null. Anything you add with null, multiply with null, subtract null from it, it'll give you null. So in order to carefully evaluate the operation, we need to use the is null, which we have already done, isn't it? So now if I execute this, it gives me 10 because while adding it, it considers the null as a 0. So 10 plus 0 is 10. In normal circumstances, 10 plus null would have been null. But as we have taken care of the null in here inside the function itself, it considers it to be 0. Simple. Why would you want to alter a function? Tomorrow, you might be asked to change the logic inside of a function. Let's say now they want the function to work on 3 numbers. You definitely need to alter it, right? So that is the reason we use create or alter. So you can create it with 2 numbers, but later on they might say, no, we want to add a third number to it. Yes, if you think about it, it's a single command itself. Earlier it was only create was allowed in front of the object names, but now this doesn't work on the tables, by the way. All right, the alter, create or alter only works for functions, views, stored procedures, and so on. Okay, so it's a part of the same command itself, I would say. But yeah, it does 2 things at the same time. Can we use column names when we have millions of data? Exactly, Surabhi. I mean, that is the whole point. Okay, if we want, for example, here, I'm just going into the example. All right, so we have created this user-defined scalar valued function, right? So whenever I'm retrieving from the employee table has first and last name, right? But I want to generate the full name, and I already have a function for that. So I just use the function in here, as you can see. So very similar to how we used this in the system defined functions. Let me show you. So here we use the column inside the system defined function, right? The same way we can use the columns inside scalar valued functions as well. All right. So here, if I execute this, it gives me the employee ID, the first name, last name, and the full name. Okay. And here in the where clause, we have the function full name, wherein the employee first name and the last name again can be passed, and we can use it as a filter. Very similar to the system defined functions. We could use the month of the date of birth, year of the date of birth in the filter, if you remember. The same manner, we can use the user defined function also in the where clause to filter on specific values. Okay, so yes, you can pass your column names like this in the function. Cool. Let's talk about the inline or single line table valued function. Now, the inline single line table valued function will return a table as an output. All right. Now, it will return a table as an output provided it has only a single line of code embedded inside the function. Okay. So here I say create or alter function. Again, the same syntax, fn underscore as a good practice, and then give a name. So here I give a name, which is get employee details. Okay, so as part of this function, any user can only provide the employee ID, and they'll get the details of that particular employee ID as output. So the input parameter is just an employee ID of data type integer. Okay, and it returns, unlike earlier, we used to say returns varchar, returns an integer. Now it returns a table. Okay, so returns table as, and then here it says return, and here I say select. So what am I selecting here? I'm trying to select the full name, the salary, the address, the employee date of birth from the employee table and inner joined with the employee date of birth. So see, using this function, I'm trying to get the full name using the scalar valued function that we created, the salary, address, date of birth from both these tables, where emp.employee ID is equal to, we have to filter it, right, for the employee ID that is selected. The employee ID that is selected is the user that has specified it. Let's say the user specifies the employee ID as 5, then we should only select the details for 5, right? So that I'll only see the full name, salary, address, and date of birth for the employee ID 5. Okay, so here, if you would have noticed, we do not have any begin or end. And that is how SQL Server expects you to create your inline table valued function. As it is an inline, that means it is a single line. It does not need the begin and end. You see, this is a single command, right? We don't have multiple commands in here. So if I go ahead and create this function, the function is created. And if I do a Alt F1 here, you'll find that this function is a inline function. Okay, this is an inline function. Now, the function has been created. So if I want to execute this function, if I want to call this function, I'd have to say select star from the name of the function. Earlier, what have we done? We were just saying select and the function name. But now, as this is going to retrieve a table as an output, we need to call this function exactly how a table should be called. So we call a table by using select star from, correct? So here we say select star from the function name, and in the bracket we provide the input parameter, that is 7. So I'm saying I need the details for ID 7. And just to make sure that we are getting the details only for ID 7, I need to execute the select from employee as well. So you see, apologies for the name, but yeah, the first name is John and the last name is Sina. So the full name is John Sina here. Salary is 3750. The address is US. And along with that, we get the date of birth as well from the date of birth table. Okay, so that means when we pass a specific employee ID, we get the details for that employee ID exactly how we have specified here in the form of a table, right? Now let's move to the multi-line or multi-statement table valued function. Now, how does the multi-line or multi-statement table valued function helps? This helps us in returns a table itself, but this time it uses multiple SQL statements in the body. Inside the function, we can have multiple SQL statements. So how do we go about creating it? It's the same syntax, create or alter function and the name of the function that we provide. Now here I append ML at the end so that I know it's a multi-line function or a multi-statement function. Again, here I'm going to pass employee ID as parameter, and in the returns, in the inline, we just set table, right? But here, for a multi-line or multi-statement table valued function, you need to define the structure of your table. So we have to specify a table variable and we need to specify the structure of the table. Okay, so whenever you're creating a multi-line table valued function, you need to declare and specify the structure of your table variable. All right, and here I say as begin, and when do we use a multi-line table valued function? When we want to prepare our data. Okay, when we want to prepare our data before it is ultimately selected, then we use a table variable. Okay, so here I say as begin, and then let's start preparing the employee table variable. So I say insert into the employee table variable, employee ID, full name and salary. And here I try to select the employee ID, the full name by using the full name function, salary from the employee table, where the employee ID is not equal to the employee ID that is specified. Again, this is just a hypothetical example. Want to do a equal to, because if I did a equal to, I would have gotten only one single record. Okay, so to increase the record count into the table variable, I just did a not equal to. So that means if the user passes 4 as an input, except for 4, everything will be inserted into the table variable. Okay, again, this might not sound like a real scenario, but let's consider this as a hypothetical example. All right. Now, once we are done inserting all the employee data into the employee table variable, except for that particular employee ID, then I update the table variable for employee ID 2 and 5 set the salary to 5,000. Okay, and then I delete these two records, which is 6 and 3. Okay, from the table variable, I delete 6 and 3, and ultimately what I do is insert into the table variable the ID with the record with ID 100. Okay, so I insert into the table variable with ID as 100, and ultimately what I do, I return. When I say return, it has to return which one? The table variable that we have populated. So we have populated the EMP table variable, which is ultimately returned in here. So if I create this function, this created, if I do Alt F1, you see it's said it's a table function. The earlier one was called inline function. This one is called as a table function. Okay, and here, if you notice, we have a begin and end because it has multiple statements. Plus, if you notice, we can perform insert, update, and delete, but not on physical tables, only on table variables. Okay, you cannot insert directly into the employee table from here. Okay, all right. Okay, I'm sorry. So here, if you see, we can perform DML operations on the table variable, not on the physical tables. Okay, so now the function has been created. How do we extract the data again? We do select star from the function name and pass the input parameter. So if you notice here, we did in the code, if you notice, we did not equal to, right? So if we have passed 4, we passed 4 as the input, so 4 should not be there in the output because we never inserted 4 into it. We said not equal to 4. So fair enough, we don't have a 4 here. For 2 and 5, the salary should be 5,000. So let's check for 2 and 5. The salary is 5,000. And then we deleted ID 6 and 3. So 6 and 3 is not visible here. Perfect again. And then we inserted 100 and record with ID 100 into the table variable. Okay, so here goes the table record with ID 100. Okay, and yeah, so this is how we create and utilize a multi-line table valued function. Now, where do we use single line and multi-line? When we have to prepare, when we need to prepare a table variable, that means the output before returning it to the user, we use a multi-line table valued function. When we already have everything ready in a table, we just have to join and get it, then we can directly go over an inline table valued function. That's the only advantage and disadvantage of both. I mean, that is where you use one or the other. Okay. Now, we can also use table valued functions to join it with other tables, right? Because table valued functions are exactly like tables. Okay, so here I can join the employee table with the table valued function, multi-line table valued function as the function on any common column name that I have. So here, if I execute this, this is the output that I would get. Now, if we want, SQL Server gives us an option to see the code that has been written inside the function. Okay, so using the SP help text, I can see the code that is written inside the function. You see, I have the entire code that I can see from inside the function, SP help text, and provide the name of the function. Now, if I don't want people to be able to see this definition, right? Now the definition shows in the form of a table, which is very difficult to read. So what we can do is we can see this in the form of text. Okay, because by default in SQL Server, the result span always shows the data in a grid format because everything is stored in tables. But if I want to see it in text format, all that I have to do is switch to this particular option. You see results to text here, and here if I now execute, I would get to see it in text, which is easier to read and understand. Okay, but here if I but by default it is usually results to grid. Okay, so once you see it, you can again go back to results to grid. Okay, but once this one is let's say you don't want users to be able to script it out. In that case, what you can do is you can enable the encryption. Okay, in my working experience, I've never used it, because there will never be a need. Okay, for people who you don't want to see the function, you will never give them access to the function. You will only give them read access on the database. But let's say you want to do it. Okay, you can enable the with encryption option inside while you're creating your function. And here, if I execute, now if I run the SP help text, you would see that it will display a message saying the text for object is encrypted. Now you will never get to see how it is encrypted and where it is stored. Okay, it's just that you'll get a message that it's encrypted and you cannot retrieve it anymore. Okay, and in case you encrypt it, make sure you store it safely somewhere in a repository in the form of files, in the form of a SQL file in one of the repositories, so that you do not lose out on it. Tomorrow, if you want to change it, you need to get it from the file there and change it on your management studio and deploy it. Because once encrypted, decrypting needs a lot of effort. You need to have complete access on your server to be able to do that. I mean, if you need more details on it, you can refer it online. I will not be able to give you enough details on that because I've never worked on the decryption part, but encryption is as easy as this. Decryption needs a lot of time, effort, and access as well. Okay, so be very careful when you're doing encryption. Make sure you save this query in plain text in a repository somewhere in the form of a SQL file, so that tomorrow when you want to make some changes, you can get the code from there and then make the changes on this function. Okay, so that is all about functions. Now, obviously, if you want to remove a function from the database, you can say drop function and the name of the function goes here. All right, let's move on and talk about the case statement now. Now, what is a case statement used for? A case statement is a typical conditional statement that is used during the retrieval of the data. So while we are trying to retrieve the data, let's say we want to apply a condition for a particular column. That is when we go with the case statement. Let me explain you with an example. So here we have all the employee data, correct? Now, when we have the employee data here with the employee ID and the rest of the columns, let's say I want to identify the employee IDs if they are even or odd. Very simple requirement. So how do we do that? In this case, we can use the case statement. So we can say case when employee ID percentile 2 is equal to 1. So what is the percentile? The role of the percentile here. The percentile is referred to a modulus operator as well. Now the modulus operator will help us divide the first number by the second number and retrieve the remainder after the operation. So here, if I divide 13 by 5, obviously the remainder would be 3. Remainder would be 3. If I divide, let's say, 9 modulus 5, the remainder would be 4, right? Because 5 times 1 is 5, and then we have remainder as 4. If I have, let's say, 27, for example, what would be the remainder here? It would be 2. Simple. So if I want to identify even or odd, I need to modulus it with 2, and if the output is 1, that means it's odd. So employee ID is like 1, 3, 5, 7, which after the modulus gives us 1, then it's odd, else it is even, right? And that is what we refer to as even or odd column. And if I execute this is the output that I get. Okay, I get a new column here and it says 1 is odd, 2 is even, 3 is odd, 4 is even, and so on. All right, we can extend the case statement to more than one condition as well. This is only one single condition, right? So we can extend it. Let's say we want to derive the buckets or salary grade. So salary grade is when we identify buckets for each of the salaries. So similarly, what we can do is we can say we are selecting from the employee table, and here I'm saying case when the salary is less than equal to 1,000, then assign it to a grade of 0 to 1,000. Okay, when the salary is greater than 1,000 and it is less than equal to 3,000, then the grade is 1,000 to 3,000. Okay, when the salary is greater than 3,000 and less than equal to 4,000, then assign it a grade 3,000 to 4,000. Okay, and for everything else, you see the else here, assign it as greater than 4,000. So I have only 4 grades in here: 1, 2, 3, and 4. So for these 4 grades, I will be distributing the employees. So if I execute this here, you will notice that based on the salary, it determines the grade. So 1,000 is 0 to 1,000, right? Because when I said less than equal to 1,000, I'm assigning it to 0 to 1,000 grade. If it is between 1,000 to 3,000, it is 1,000 to 3,000. So for these 2 examples, as you can see, it is the salary is 2,000 and 3,000, right? So this is what it is, right? So you can have one or multiple conditions specified while you're trying to retrieve your data. So only while you're trying to retrieve your data in a derived column, if you want to run some conditions, this is when you use a case statement. Now we also have a if function, if. This also works like the case, but has a limitation. What is the limitation? It can only work on one single condition. So the condition here that I'm specifying is, I'm saying if employee ID is less than equal to 5, then show the value as employee ID is less than equal to 5. Else, this is the output. So this is as if condition. And that means this condition will be evaluated. If the condition is true, then this one will be shown. If it is false, then this one would be shown. Okay. So here, if I run the select here, you would see the we have the if condition. Output is employee ID is less than equal to 5 for the first 5 records, and for the rest of the 2 records, it is greater than 5. Any type of condition that you want to use, you can in fact add multiple conditions using AND, or you can use the between operator, you can use the like operator, even any kind of operation. We have discussed about whatever we can use in the where condition can be used in all your conditions here. The else is if none of these conditions satisfy, then the else will work. Yes, it would definitely work, but the reason, I'll tell you why I chose to write it this way, because if I use a between 1,000 and 3,000, it'll include 1,000 and 3,000 both. But 1,000 is already considered here in this part as part of this condition, right? So I need to only consider from 1,001 until 3,000. And that is the reason I did greater than 1,000 and less than equal to 3,000. So yes, I can do between 1,001 to 3,000. That should work. This one should be between 3,001 to 4,000. That should work. Okay. So yeah, you can replace it with the between. No worries. All right. Let's move on to the next thing that we have here, which is the if condition. Right now, what is the if condition used for? The if condition helps us in identifying the program flow. That means what queries should be executed and what queries should not be executed. Okay, so let me just show you a fresh example so that you understand this better. So here, let's say if 1 is equal to 1, then select the first condition is true. Okay, so if I execute this, obviously I should get the output like this. First condition is true. It's perfect because this condition is true. Now if I say 1 is equal to 2, obviously it's false, so it wouldn't execute anything. Now if I create another condition right below in here, if I say this time 2 is equal to 2, and here I say second condition is true, and if I execute this, you see it displays first condition is true and also second condition is true. Okay, now if let's say I want to check for this condition and print this, and only if this condition is false, then I want to print this. I don't want to print both of them together. right? So if you look at it right now, I mean, if we put it in a different perspective, these two queries are independent of each other, isn't it? I mean, do you think these two conditions are related? Not at all. They're two independent conditions. So if I want to make this one single condition, that means I want to first check for this, only when this is false, this one should be executed. If I want to do that, I'll have to somehow join these two queries to make them one, join these two conditions to make it one. That is where we need to use else if. So if this is true, then print this else. That means if this one is false, and if 2 is equal to 2, then print this one. Okay, so now if I execute, these two conditions have now been merged to make it one. Thank you to the else condition here. So here, if I execute, you see it only prints the first one. Why? Because the second one should only be executed if the first one is false. Look at the else condition here. So only when the first one is false, let's say this, then the second one will be executed. Second condition is true. And if both the conditions are false, that is when I use the else condition and I say third condition is true. Or instead, let's say else condition. Okay, so
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
here, if I execute this one, we still get second condition is true because it goes on a top to bottom basis. So this one is executed first. Else, that means if the first one is false, then this one is executed. Let's say the second one is as well false, then it'll go to the else part. And there you go. Else condition is now executed. Okay, let me get rid of this. One thing that you need to remember while you're working with the if, else, if statements is that whenever you have multiple lines of queries that you want to include in your condition, okay, you need to use begin and end. Let me show you why I recommend it. So whenever we have multiple queries that we want to include in our condition, that is when we need to use begin and end. Why? Let me show you. Here, if I say 1 is equal to 1, that means the condition is true, right? So if I execute this together, you will notice that it prints first and second both, which is all right, right? Because it is true. So obviously I expect both of them to be executed. But let's say if this condition is false, what I expect is none of this should be printed. But if you notice, it will still print second. Why? Because when you don't have a begin and end while using multiple queries inside your condition, then only the first statement is considered to be a part of your condition. The second condition is independent. So if you want to include both of them, you need to use begin and end like this. And now if I execute, none of them will get executed. And if it is true, both of them will get executed. Okay, so you need to remember this while you're working with if statements. Okay, let me show you a real use case of a if. Okay, where do we exactly use it? So until now, whenever we have been inserting data, we blindly run an insert command, right? Insert into the table, select whatever values we want to insert. Now, what if that value is already there? We will end up having duplicate records. That is where the if condition will really help us. So what we can do is we can check if the record does not exist, then we will insert, else we will not insert it. Simple. So how do we write it? We say if not exists. That means if the record doesn't exist, for which from the employee table where employee ID is equal to 5. So when the employee ID is 5, that means there is no employee with ID 5, then we insert into the employee table with ID 5 and name as Smith. What if it exists? That means it's a else, right? So if it exists, then we print saying record already exists. And in our case, it already exists, right? So here it says record already exists. But if it was not, it would have inserted this record. So this is how we perform our DML operations by using the if condition. Okay, this is a more sophisticated way in which we execute our DML operation so that we don't end up performing the same insert, the same update, or the same delete over and over again. Can we use DML with the case if and if then clause? Yes, definitely. So you can say update name is equal to case when this condition, then apply this name, else apply this name. Yes, you can do that. You can do that in the set statement, by the way. Difference between if and if. If helps us in identifying which query to be executed and which not. Clear? Whereas the if condition helps us in determining what value should be displayed. Okay, so this is more of a select operation. This is used mostly with the select. Whereas if helps us in deciding the program flow, that means what queries should be executed. Okay, I mean, there is no comparison between the if. You can compare if and case. IIF and case can be compared, but if and if cannot be compared because these are completely two concepts. So if always starts before select statement. Yes, I mean, it's not only a select. See here we wrote a if before the insert, right? For an insert. So you use a if when you want to conditionally execute your statement. That means if the conditions satisfy, I want to execute this condition, else I don't want. Okay, whereas the if is mostly for identifying a comparing values and then determining which value should be displayed. Okay, so if is used with the select, whereas the other if is used as a condition to determine which queries to be executed and which not. Oh yes, no, you cannot use a if else inside your select statement. That is correctly understood. Okay, all right, so let's go ahead and now folder and let's go through the module. All right, all right. So again, let me get the chat window to the extreme right in here and squeeze it in. All right, so the first question on your screen, in which database are the temporary tables created and stored? You guys are fast. All right, so I've gotten a lot of answers. I'm going to open up the answer in 3, 2, 1, and here we go. Well, the correct answer is TempDB, as all of you answered correctly. So great job on that. A very good start. Let's continue further. On to the second question. Which of the following statement will help us add a new column called f_name to the student table? Right. So these are the options that you have. You have about 4 options. Okay. All right. Keep going. I'll explain you which one is incorrect and why it is incorrect as well. So go ahead, key in your options. It's okay. Participation is important. All right. So I'm going to open up the answer in 3, 2, 1, and here we go. All right. So the correct answer is D. Let me show you why the rest of them are incorrect. The first one, if you see, we have alter table student add column. The column keyword is not acceptable. If you remember, when we learned on how to add a column, we just used to say add the column name. We never use the column keyword. Okay, now the second one does not have the column keyword but has these brackets. You see these brackets here? So these brackets are not used, are not necessary. So it will throw an error because of that. In the third option, the column keyword is unnecessary plus the data type in here, right? So these two things spoil it here. And ultimately the fourth one is where we have all the correct specifications. So this will help us add a new column to the student table. All right, moving on to the next question. User-defined function in SQL Server can return what values? What kind of values can a user-defined function in SQL Server return? Okay, I'm going to open up the answer in 3, 2, 1, and here we go. So the correct answer is D, all of the mentioned. Obviously, we can select scalar values, result set. A set of values is nothing but multiple values in a single column, isn't it? And that is nothing but a result set again. So that means it can return all of the above mentioned values out of a function. All right, moving on to the last question for the module. Which of the following functions will give us the average value of a numeric column? This must be a cakewalk for all you guys. Nice. I'm so happy you guys are catching up so fast. Okay, so I'm going to open up the answer in 3, 2, 1, and here we go. So the correct answer is B, AVG, which all of you have answered correctly. Okay. All right. Yeah, that's all that I have for the evening for you guys today. Thank you so much for being a part and hoping the session was interesting today. Bye, everyone.
So what exactly is SQL? So this is a very basic question. So to answer this, SQL stands for the Structured Query Language. And according to ANSI, it is a standard query language for relational database management systems, maintaining the relational database, and also to perform different operations of data manipulation on different types of data. So SQL is widely used language for maintaining relational database. And in the year 1986, SQL became the standard of American National Standards Institute, or ANSI. So basically it is a database language which is used for creation and deletion of databases. And it can be used to fetch and modify rows from the table and also multiple other things. So let's head on to the next question. So we are supposed to explain the different types of SQL commands. So the SQL commands can be divided into 4 categories. So we've got data query language, data definition language, data manipulation language, and data control language. So the data query language comprises of just one command, select, though it can be accompanied with many clauses to compose queries on a database. Then we have the data definition language. So DDL is that part of SQL which defines the data structure of the database in the initial stage when the database is about to be created. So it is mainly used to create and restructure the database objects. So you can see commands like create table, alt table, and drop table in DDL. And after that we have the data manipulation language. So DML is used to manipulate the already existing data in the database. That is, it helps the user to retrieve and manipulate the data. And it is used to perform operations like inserting data into the database through the insert command, updating data in the database through the update command, and deleting data from the database through the delete command. And finally, we have the data control language, which is used to control access to the data in the database. So these DCL commands are normally used to create objects related to user access and also to control the distribution of privileges among users. And you see commands such as grant and revoke in DCL. Right, so this is the next question. So what exactly are constraints? And we are supposed to explain about the default and the unique constraint. So constraints are basically used to specify some sort of rules on the data and limit the type of data that can go into a table. Alright, so let's understand about default constraint. So the default constraint is used to provide a default value for a column. So the default value will be added to all the new records if no other value is specified. For example, if we assign the default constraint to this e-salary column and set the default value to be equal to 85,000, then all the entries of this column will have a default value of 85,000 if no other value is assigned during the insertion. So similarly, we can also assign a default value of analytics to this EDEPT column. Right. So now we'll go to SQL Server and we'll work with the default constraint. Now I'll start off by creating a new table and I'll add the default constraint to one of those columns. So I'll create a new table and I'll name this table as stu1. So the syntax would be create table stu1 and this would comprise of these columns. So there would be SID, which basically stands for the student ID, and the data type of this column would be integer. After this, there is SName, which stands for student name, and the data type would be varchar, and the length of the string, or the maximum length of the string, would be 20. And then I'll finally have the marks scored by the student, which would be SMarks, and this would be of integer type. Now after this, I will give in the default constraint and I will set the default value to be equal to 50. Right, so I have successfully created this table. Now let me have a glance at this table first. So select star from stu1. So this is our table which is empty as of now. Now what I'll do is I will go ahead and insert some values into the table. So I'll type in insert into stu1 and then I'll give in the name of the columns. So this needs to be INSERT. So the name of the first column is SID and then I've got SName. Now I'll type in values and give in the values for these two columns. So let's say the first ID is 1 and the name of the student is Sam. Now I'll click on execute. Now let me have a glance at this modified table now. Select star from stu1. So now we see that we have this default value of 50 in this S marks column, and this is because we had assigned the default constraint to this column. Now similarly, let me add two more records into this table. So insert into stu1 SID SName. I'll give in values. So it'd be 2 and the name of the second student is Bob. Right, so I've also added the second record. Now let me add in the third record. So the student ID is 3 and the name of the student is Matt. Right, so now I have 3 records in this table. Select star from stu1. So these are the 2 new records and the default value is 50 for these 2 new records. So this is how we can work with the default constraint. Now comes the unique constraint. So the unique constraint ensures that all the values in a column are different. For example, if we assign the unique constraint to this ename column, then every entry in this column should have a unique value. So here we see that all the names of the employees are different. Now again, let's go to SQL Server and work with a unique constraint. So again, I'll create a new table and add the unique constraint to one of the columns. Create table, and this time the name of the table would be stu2. Again, there would be the ID, and this is of integer type. Now I would be assigning the unique constraint to this SID column, and there would be a second column which is basically the student name, and this is of varchar type. Again, the length of the string would be 20. Right. Now let me have a glance at this table again. So select star from stu2. So this is our new table which is empty as of now. Now let me go ahead and add values into this. So insert into stu2 values. I'll add in the first record. So 1, which would be the student ID. Name of the student is Julia. Now let me look at this table. Select star from stu2. Right, so we have successfully inserted this record. Now let me add a new record. So insert into stu2 values. Now what I'll do is I will again give the ID of the student to be 1 and the name of the student to be Matt, and let's see what happens. So this time we get a message or a warning message, and this states that violation of unique key constraint, and we cannot insert duplicate key in object dbo.stu2, and that is because we had given the unique constraint to this SID column. That is why this has to be different. So let me change this to be 2. Now let me again run this, right? So now since this is a unique value, 2 is not a duplicate. That is why we were able to insert this record. Now again, what I'll do is let me add another record with the ID 2. So let's say now the name of the student is Annie. Now again, we get this warning message because ID number 2 is already present. So let me change this to 3. Now let me run this again, right? So now we are able to insert this record. So this unique constraint basically makes sure that there are no duplicate records inserted into this column. So now we have the next question. So again, we have this employee table with us and we are supposed to find out the second highest salary from this table. So let's go to SQL Server and find out the solution. So let me start off by having a glance at the employee table. Select star from employee. Right, so this is our employee table over here, and we see that the highest salary is 159,000 and the second highest salary is 125,000. So we are supposed to extract this particular value from this data set. Now let's see how can we do this. So we can perform this operation with the help of subquery. Now let me just type in the command select, and since we want the maximum value, I'll use the max aggregate function, and this would be e salary. So I want the maximum salary from the name of the table is employee. I'll give in the where clause and given the condition where e salary is not in. After this, I will give in the subquery over here. So the subquery again would be the same. So select max of e salary from employee. So now if you have a glance at this, you would see that both of these queries are same. So select max of e salary from employee and select max of e salary from employee. Now this subquery would give in this result, which is 159,000. So and then this main query would make sure that this salary does not lie in this. So this would give us the 125,000 result. So select max of e salary from employee where e salary is not in 159,000. That would mean 125,000. So let me click on execute, right? So we have successfully got the result, which is 125,000. And this is how we can extract the second highest salary. So we have our next question over here. So what do you understand by normalization and denormalization? So this is a question which is very frequently asked during the interviews. So let's get to the answer. So normalization and denormalization are basically methods used in databases. And normalization is the process of reducing data redundancy and dependency by organizing fields and tables of the database. So it involves constructing tables and setting up relationships between those tables according to certain rules. And the redundancy and inconsistent dependency can be removed using these rules in order to make it more flexible. So I'm repeating it again, guys. So simply put, normalization is the process of reducing the data redundancy. And we are able to do this by organizing the fields and tables of the database. And then we have denormalization, which is a contrary process to normalization. So in denormalization, we basically add redundant data to speed up complex queries involving multiple table joins. So in denormalization, we attempt to optimize the read performance of a database by adding redundant data or by grouping the data. Right, so this is our next question. Now we are supposed to find out what exactly is wrong with the SQL query. So this is the SQL query over here. Select gender, average of age from employee where average age is greater than 30. And again, we are grouping this with respect to gender. So this is our employee table over here. Now let me go ahead and just type in the command, which would be select e gender. And then I would want the average of age. So average of e age from the name of the table is employee, where again the average of e age needs to be greater than 30, and this is being grouped with respect to gender. Now let me go ahead and click on execute. So let's see what is the error. So this warning message states that an aggregate may not appear in the where clause unless it is in a subquery contained in a having clause or a select list, and the column being aggregated is an outer reference. So this basically means that whenever we are working with aggregate functions and we are using group by, we can't use the where clause. So instead of the where clause, we would have to use the having clause. Now let me change this to having and let me click on execute. So now again we get an error over here, and this error says that incorrect syntax near the keyword group. And this is because if we are using the having clause, then group by would come first and having would come second. Now let me cut this over here and let me paste this before having. Right, now I'll click on execute. So this has to be e gender over here. Now we've successfully got the result. So just to reiterate, the error was whenever we are working with aggregate functions, we cannot use the where clause and we would have to use the having clause. And if you are also using group by with having, then group by would come first and having would follow it. So next question. So what do you know about the stuff function? So the stuff function deletes a part of the string and then inserts another part into the string starting at a specified position. So this is the syntax of the stuff function. So stuff, this takes in these four parameters: string 1, position, length, and string 2. So the string 1 is basically that string which would be overwritten. Position would basically indicate the starting location for overwriting the string. And length is the length of the substitute string. And string 2 is that string which would overwrite the string. So again, let's go to SQL Server and work with an example with the stuff function. So now let's say I have this string which basically stands like this: SQL tutorial. Now I'd want to replace this SQL tutorial with Python tutorial, right? So for this purpose, we can actually use the stuff function. So let me go ahead and write the syntax for that. It would be select, I'll give in the function stuff. So let me start with the first parameter, which is the string which is to be replaced. So the string which is to be replaced is SQL tutorial, and then I'll give in the second argument, which is the position. So the position would be 1. That is, I want to replace this. So this is position number 1. And then I would have to give in the length of the string which is substituted. Right. So the length of SQL is 3. I'll just type in 3 over here. And then finally I will give in string 2, which is basically that string which would replace this over here. So I would type in Python over here. Now I'll execute. So initially our string was SQL tutorial. And with the help of the stuff function, we were able to change this from SQL tutorial to Python tutorial. So next up, we'd have to explain about views in SQL. So what exactly is a view? And then we'd have to give an example of view. So you can consider views as virtual tables, which are used to limit the information that we want to display. And these are actually nothing but the result of an SQL statement, which have a name associated with them. And since views are not virtually present, it takes less space to store. So let's take this example. From this employee table, let's say we wanted to perform multiple operations on the records where the gender is female. So we can create a view only for the female employees from the entire employee table. So let's go ahead and perform this in SQL Server. Now let me type the syntax for this. So I would want to create a view which would comprise of only the female employees from the entire employee table. Now let me just have a glance at the employee table first. So select star from employee. Now I would want a view which would comprise of just these two records. Now let me go ahead and write in the syntax for the view. So it would be create view, and the name of the view would be female employee. And after this I will give in the keyword AS. After that I'll type in select, and then I'll give in the condition. So select star from employee, where after the where clause I will give in the condition which actually matters. So gender needs to be equal to female. Right, so I have successfully created this view with the name female employee, which would comprise of only the records of the female employees. Now let me delete this and let me have a glance at the view which I've just created. So select star from female employee. Right, so this is our view which comprises of these two records, and the names of the employees are Anne and Julia. Now similarly, let's say if I wanted a view which would comprise of only those employees whose age is greater than 25. So let me go ahead and write the syntax for that. So create view, and then let's say the name of the view is age, and then I'll type in the keyword AS, select. Now over here, let me give in the statement. So select star from employee, where, and then the condition would be age needs to be greater than 25. So we have created this view. Now let me have a glance at this. So select star from age.
Just a quick info, guys. Intellipaat provides online SQL training in partnership with Microsoft, the course link of which is given in the description below. Now let's continue with the session.
Right, so this is a view which would comprise of only those records where the age of the employee is greater than 25, and we've got 4 records over here. So Sam's age is 45, Julia's age is 30, Matt's age is 33, and Jeff's age is 27. Right, so what is a stored procedure? And then we'll have to give an example of stored procedure. So a stored procedure is a prepared SQL code which can be saved and reused. Or in other words, you can consider a stored procedure to be a function consisting of many SQL statements to access the database system. So we can consolidate several SQL statements into a stored procedure, and execute them whenever and wherever required. And stored procedure can be used as a means of modular programming. That is, you can create a stored procedure once, store, and call for several times whenever required. So this supports faster execution when compared to executing multiple queries. Now, let's look at the syntax of a stored procedure. So we'll given the keywords create procedure, and then we'll give the procedure name over here. After that, we will give in the keyword es, and then we'll give the SQL statement for which we'd want to create the procedure. And then we'll end the procedure with the go keyword. Now, after we create a procedure, we need to execute it. So this is the syntax to execute the procedure. So we'll type in exec and then give the name of the procedure which is to be executed. Right, so again, let's have an example with the stored procedure. So now I'm going to create a stored procedure which would help me to extract the age of the employees in a very easy way. So let me type in the syntax for that. Create procedure. And then I'll give in the name of the procedure. So this would be employee age. After this, I will type in the keyword es, and then I'll give in the select statement. So select age from employee. Now that this is done, I'll give in the go keyword. Right. So now I have successfully created this stored procedure with the name employee age. Now I'll go ahead and execute this. So it'll be exec or execute employee age.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Right, so we have created the stored procedure which would help me to easily access the age column from this employee table. So next question. What do you understand about join and explain about different joins? So a join clause is used to combine rows from two or more tables based on a related column between them. So there are various types of joins which can be used to retrieve data, and it depends on the relationship between tables. So first we have inner join, which basically returns records that have matching values in both the tables. Then we have left join. So left join returns rows which are common between the tables and all rows of the left hand side table. That is, it returns all the rows from the left hand side table even though there are no matches in the right hand side table. Then we have right join. So right join returns rows which are common between the tables and all the rows of the right hand side table. That is, it returns all the rows from the right hand side table even though there are no matches in the left hand side of the table. And finally we have the full join. So full join returns all rows from the left hand side table and all the rows from the right hand side table. So now we'd have to explain about inner join properly. So the inner join basically gives us those records which have matching values in both the tables. So we've already learned this. Now let's say we have two tables, table A and table B. And when we apply inner join on these two tables, we'll get only those records which are common to both table A and table B. So this gray portion which you see over here, so this would be the result of the inner join. Now let's look at the syntax of inner join. So we'll give the keyword select and then we'll give in the list of the columns. Following which we'll give the from keyword and then we'll give the name of the first table. Then we'll use the keywords inner, join and then give the name of the second table. After which we'll give in the on keyword. So this on keyword tells SQL that this inner join needs to be done on some condition. And the condition over here states that the values from column X of table 1 should be equal to the values of column Y from table 2. So let me just reiterate this. The values of column X from table 1 should be equal to the values of column Y from table 2. Now let's go to SQL Server and work with this inner join. So I have two tables over here. So the first table would be the employee table and the second table would be the department table. So let me have a glance at both of the tables. So select star from employee. Now the second command would be select star from department. So this is the employee table over here which we've already seen, and then we have this department table. Now I'd want to have an inner join on both of these tables where the EDEPT column from this table is equal to the DNAME column from this table. That is, wherever the values from these two columns match, I'd want only those records. Now let me go ahead and write the syntax for this. So I will type in select and then I'll give in all of the columns which I want. So I want the e-name column and e-department column from the employee table. So this would be employee.ename. Then I would want employee.eDepartment. After that, I would want the department name and the department location from the department table. So I'll type in department.dname and then I also want department.dlocation. Right, so these are all of the columns which I want from both the tables. Now after this, I'll type in from and then I will type in the name of the first table, which is employee, and then I'll just type in inner join and then given the name of the second table, which would be department. Then I'll give in the on keyword and then given the condition. So here the condition is the values of the dname column should be equal to the values of the eDEPT column. So employee dot ename should be equal to department dot dname. Now I'll execute this. Right, so this is the result. So we have our employee table over here. This is the department table, and finally this is the result of the inner join. So here we see that we've got only those records where the departments match in both of the tables. So the matched departments are support, analytics and sales, right? So we've got support, analytics and sales from over here because only those departments are present in this department column. So next question. Well, what do you understand about temporary table? And then we'd have to write a query to create a temporary table. So simply put, temporary tables basically help us to store and process the intermediate results. Now these temporary tables are created in the tempDB and are automatically deleted when they are no longer used. So the temporary tables could be very useful in cases where we need to store temporary data. Now let's look at the syntax of a temporary table. So first we will give in the keywords create table, and before we go ahead and give the name of the temporary table, we'll have to precede it with a hash. So again, let's go ahead and create a temporary table. So now what I'll do is I'll create a temporary table and I will name this as, let's say, book, and then before the name of the table I'd have to precede it with a hash. Right, now this would have two columns. So first would be the book ID and this would be of integer type, and then this would have book cost, which is again of integer type. Now let me execute this. Now I'll refresh over here. I'll click on the plus sign. I'll go into system databases and I'll go into tempDB, and over here let me click on the temporary table. So we see that we have successfully created this temporary table with the name book. Now let me see what is present in this table. So I'll type in select star from, I'll put in the hash symbol over here and then I'll give in book. Right, so as of now this temporary table is empty. Now let me go ahead and insert something into this table. So the command would pretty much be the same. So insert into and then lb book. I'll type in values over here. So the only difference which you see when you're creating or working with a temporary table and the normal tables is you would have to precede the name of the table with a hash. So as simple as that. Rest everything would be the same. And over here let me give in the values. So the book ID is 1 and the book cost is 100. Right, now let me also add another record. So the second ID would be 2 and now the book cost would be, let's say, 232. Alright, now let me have a glance at this modified temporary table. So select star from hash book. Right, so we have added 2 records into this temporary table. So now we'd have to explain the difference between OLTP and OLAP. So let's start with OLTP. So OLTP basically stands for online transaction processing, and you can consider it to be a class of software applications capable of supporting transaction-oriented programs. And an important attribute of an OLTP system is its ability to maintain concurrency. So OLTP systems often follow a decentralized architecture to avoid single points of failure. And these systems are generally designed for a large audience of end users who conduct short transactions. And queries involved in such databases are generally simple, need fast response times, and return relatively few records. So the number of transactions per second acts as an effective measure for such systems. Then we have OLAP. So OLAP stands for Online Analytical Processing, and it is a class of software programs which are characterized by relatively low frequency of online transactions. So queries are often too complex and involve a bunch of aggregations. And for OLAP systems, the effectiveness measure relies highly on response time. So such systems are widely used for data mining or maintaining aggregated historical data. And this is usually used in multi-dimensional schemas. So then we have the next question. So what is the difference between the delete and the truncate command? So again, keep this in mind, guys. This is a question which is very frequently asked in interviews. So let's start off with the delete query. So the delete query is used to delete or remove one or more existing tables. So let's have a look at the syntax. So we'll start with the delete keyword and then we'll put in the keyword from. Then we'll specify the name of the table. After that, we'll specify the where condition, but then that's optional. So let's see an example of this delete command. So we have this table. So the name of the table is STU, which basically is the student table. Now from this table, I'd want to delete the record where the name of the student is Bob. So let me write the syntax for that. So delete from, and then I'd have to give in the name of the table. So the name of the table is STU. So delete from STU. After that, I'll give in the where clause and give the condition where S name is equal to Bob. Let me execute this. Right. So we have successfully deleted that record from this table where the name of the student was Bob. So similarly, let's say if I want to delete that record where the student ID is 3. Right. So over here, the condition would change. So delete from STU where SID equals 3. So now this time we have deleted that record where the student ID was equal to 3. Now let's look at the truncate statement. So the truncate statement deletes all of the data inside the table. So here we'll give in the keywords truncate table and then give the name of the table. So let's go to SQL Server and work with this truncate command. So now we have this stu1 table. So let me go ahead and use the truncate command of this table. So I'll type in truncate and then I'll give in the name of the table, which would be stu1. So before that, I'd have to type in table. So truncate table stu1. Let me run this. Right, so we have deleted all of the records from this table. Right, so this is how the truncate command works. Now let's understand some differences between the delete command and the truncate command. So when it comes to the type of language, truncate would be a DDL command or a data definition language command, and delete is a DML command or a data manipulation command. Now another difference would be we can't really execute a trigger in case of truncate. While with delete, we can accomplish a trigger. Now, also if a table is referenced by any foreign key constraints, then truncate won't work. So if you have a foreign key, then you'd have to use delete and you wouldn't be able to use the truncate command. So next question. What is the difference between union and union all operators? So the union operator is used to combine the result set of two or more select statements. For example, if the first select statement returns these 3 fish, and the second select statement returns these 3 fish, then the union operator would return the result of these 2 select statements. And if there is a record which is present in both the tables, we'll get only one of them in the final result. So here we see that this blue fish is present in both the tables A and B. Now, when we apply the union operator on these 2 tables, the final result of A union B would have only one of these blue fish. And this is the syntax of the union operator. So we'll give the first select statement. After that, we'll give in the union operator, following which we'll give the second select statement. Now you also need to keep in mind that the number and the order of columns must be same in both the select queries. So let's work with this union operator now. So we have these 2 tables over here. So the name of this table is student details 1 and the name of this table is student details 2. And if we have a glance at the columns, we see that both of the tables have 3 columns and the names of the columns are same and also the order of the columns are same. So here we have SID, SNAME and SMarks. Similarly over here we have SID, SNAME and SMarks. Now let's go ahead and apply the union operator on this. So I'll type in the first select statement. So it'll be select star from student details 1. So let me change the spelling to student details. After this, I will apply the union operator and then give in the second select statement. So select star from student details 2. Now let me click on execute. So this is the result over here. Now let me also print in the first two original tables. So select star from student details 1, and then I'll also put in select star from student details 2. So let me just change the spelling to student over here. Let me also change this over here. So this will be student. Right. So this is student details 1, this is student details 2, and this is the result of the union operator. Now, if you have a glance at these two tables, then you see that these two records are repeating over here, right? So there's Anne, Julia over here in the first table, and there's also Anne and Julia in the second table. Now, when we apply the union operator, then we'll just have one record coming from each of these tables, right? So we've got Anne over here, we've got Julia over here. And then we finally have Matt, which comes from the second table. This is how the union operator works. Right, now let's look at the union all operator. So the union all operator gives all the records from both the tables, including the duplicates as well. So here, since this blue fish is present in both the tables A and B, the final result of A union all B would also have the duplicate value. So here we see that we've got both of the blue fish from table A and table B. Now let's go ahead and implement this in SQL Server as well. So here we have these two tables already ready, which are student details 1 and student details 2. Now what I'll do is I will copy this, I'll paste this over here and just type in union all. So union all, I'll click on execute. So student details 1, student details 2. Let me just expand this over here. Right, and this is the result of union all operator, right? So if you have a glance at this, you'll see that these two are repeating, so we would have duplicate values. So we've got Anne twice over here and also Julia twice over here. So next question, well, what is the use of the intersect operator? So the intersect operator helps to combine two select statements and returns only those records which are common to both the select statements, right? So if we've got table A and table B over here, and if we apply the intersect operator on these two tables, then we'll get only those records which are common to the result of the select statements of these two. Now let's look at the syntax. So over here, this is the syntax. So we'll start off by giving the first select statement and then we'll give the intersect operator, following which we'll give the second select statement. Now let's see an example on this. So again, we have these two tables over here, student details 1 and student details 2. Now let me apply the intersect operator on these two. So let me just type in intersect over here and I'll click on execute. Now let me maximize this over here, right? So student details 1, student details 2, and this is the result of the intersect operator. So we see that since Anne and Julia are common to both of these tables, this is the resultant of the select statement, right? So the select statement on the first table gives out Anne and Julia, and the select statement from the second table also gives out Anne and Julia. So the intersection of these two would be this. So we have our final question. Now let's say you're given a table. Now you'd have to copy the data of this table into another table. So you have this employee table. Now you'd have to go ahead and copy the data which is present in all of this table into another table. So let's see how can we do this. So this is our employee table over here. Now we'd have to copy all of this into another table. So for this purpose, we can use the insert into select operator. Now before we go ahead and do that, we would also have to create another table which would have the same structure as this table. So if the table doesn't have the same structure, then you wouldn't be able to copy the data. So let me go ahead and create the table first. So I'll type in create table and I'll name this as employee duplicate. And then I'll give in all of the values over here. So my first column would be EID and this would be of integer type. Second column would be ENAME and this would be of varchar type. and the length of the string would be 20, and then I would have the e-salary over here. This would be of integer again. After this, I would have the e8, which is of integer. Then I would have the gender of the employee. So the gender of the employee would again be of character type. Now I'd have to make sure that I give in commas after all of these. So let me just put in a comma after this as well. And then the final column would be EDEPT. And this again would be of variable character of length 20. Right. So I've successfully created this employee duplicate table. Select star from employee duplicate. Right. So as of now, we see that this table is empty. Now I'd want to copy all of the table present in the employee table into this table. So let me write in the command for that. So I will start off by giving the keywords insert into. Now after that, I'll give in the name of the table into which I want to insert. So the name of the table would be employee duplicate. Then I will type in select star from, and then I'll have to give in the name of the original table. So the name of the original table would be employee. Right? So 6 rows have been affected. Now let me have a glance at the new table, which would be select star from employee duplicate. Right, so we have successfully copied all of the data which was present in employee table into this employee duplicate table.
Just a quick info, guys. Intellipaat provides online SQL training in partnership with Microsoft. The course link of which is given in the description below.
Okay guys, we've come to the end of this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below.
Thanks for watching.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.